السلام عليكم. Engineer Mouaz Shahmeh, software engineer and developer. With experience of Flutter about 5 years old, and in Dart or any programming language other about over 10 years. What we talk in this video, we talk about Dart programming language. We will talk about basic Dart program, important concepts, keywords, variables, default value, late variables, final and const, built-in types, numbers, strings, Booleans, list, set, map, runs and grapheme clusters, symbols. We will talk about functions, parameters, the main function, functions as first-class object, anonymous functions, lexical scope, lexical clusters, testing functions for equality, return values, operators, arithmetic operators, equality and relational operators, type test operators, assignment operators, logical operators, bitwise and shift operators, conditional expressions, cascade notation, other operators, control flow statements, if and else, for loops, while, break and continue, switch and case, assert. We will talk about also exceptions, throw, catch, finally. We'll talk about classes, object-oriented in Dart language, using class members, using constructors, getting an object type, instance variables, constructors, methods, abstract classes, implicit interfaces, extending class, extension methods, enumerated types, adding features to class mixins, which is similar to protocol in Swift language, for example, class variables and methods. We will talk about generics, why use generics, using collection literals, using parameterized types with constructors, generic collections and the types they contain, restricting the parameterized, using generic methods, libraries and visibility, using libraries, implementing libraries, asynchrony support, handling features, declaring async functions, handling streams, generators, callable classes, isolates. We'll talk about type divs, metadata and comments, single line comments, multi-line comments, documentation comments, and summary. All of this we will talk about in this video. What is Dart programming language? Dart is programming language from Google, is official programming language for Flutter technology. We talked about Flutter in many times previous. For example, there is a full course for Flutter in Udemy. You can refer it in description details in this video. And many videos in our channel on YouTube. You can refer it. Dart programming language is easy to use, familiar to you if you come from any programming language. What you need to program, you need initially Dartpad or any IDE integrated development environment. For example, VS Code, Visual Studio Code, or Android Studio, or Xcode, or IntelliJ, anyone you deal with it, no problem. We don't need IDE in this video. We use only Dartpad. A basic program Dart. The following code uses many Dart's most basic features. Print integer. This function. Let's see what this function do. Now, before if you want two references, we used two references in this video. One is important, is Dart Apprentice first edition. This in 2020 in Dart Null Safely 2.10. Beautiful and useful, valuable book you can find on Amazon. Dart Apprentice first edition, beginning programming with Dart. Another book, if you want to over programming concepts, data structures and algorithms in Dart. This new edition in Dart 2.15, latest version of Dart, null safely already, data structures and algorithms in Dart. We don't talk about these concepts in this video. We talk it in little or shortcut about these concepts. Now return to Dartpad. Here we find this. We will talk about functions later. Print integer, pass parameter, name it parameter a number, then print the number. In main function, all of these concepts we will talk about this later on this video. Here we find main into main. So this is a problem. We need to delete main. Here, if we run the code, we find the number is 42. Declare value. We will talk about all of this. Print integer, call function, and the result is the number is 42. This is a comment. We'll talk about comments. Single comment line. Void function. Don't return any value. Integer data type. Print handy way to display output. String literal. Variable name or expression. This concatenate strings into each other. Main special required top-level function where apps execution starts. Var. This is introduction about Dart programming language. What is important concepts? Everything you can place in variable is an object, and every object is instance of class. Even numbers, functions, and null are objects, with exception of null. All objects inherits from object class. Dart 2.12 is using null safety. Language versions, if you want to language versions, this in Flutter, you can refer to Flutter course to understand this environment SDK. Two changes in each release from 2.0 to 2.16. Dart is strongly typed, type annotation optional. If you enable null safely, variables cannot contain null. When you want to explicitly say that any type is allowed, use object. Dart supports generic types like list of integers, for example, or strings. Any other. Dart supports top-level functions such as main, as well as functions tied to a class or object, static and instance methods, respectively. You can also create functions within functions, nested or local functions. Similarly, Dart supports top-level variables, as well as variables tied to a class or object, known as folders or properties. Unlike Java, Dart does not have keywords public, protected, and private. If an identifier starts with an underscore, it's private to its library. For details, see libraries and visibility. You can refer this issue on GitHub to more information. Identifiers can start with a letter or underscore, followed by any combination of those characters plus digits, similar to any programming language. Dart has both expressions, which have runtime values, and statements which don't. For example, condition expressions has a value of expression 1 or 2. Compare that to an if-else statement, which has no value. Dart tool can report two kinds of problems, warnings and errors. Warnings are just indications that your code may not work, but they don't prevent your program from execution. Errors can either compile time or runtime. A compile time error prevents the code from execution at all. Runtime error results in an exception being raised while code executes. Now we talked about important concepts in Dart and introduction. There are many keywords resolved in Dart programming language. For example, abstract, else, import, show, as, enum, in, static. We will understand all of this later in this video. Assert, export, interface, super, async, extends, is, switch, await, extension, late, sync, break, external, library, this, case, factory, mix and throw, catch, false, new, true, class, final, null, try, const, finally, on, type diff, continue, for, operator, var, covariant, function, part, void, default, get, required, while, deferred, hide, rethrow, with, do, if, return, yield, dynamic, implements, set. Avoid using these words as identifiers because it's reserved keywords. Words with superscript when are contextual keywords. Words with subscript to built-in identifiers. Words with the superscript 3 are limited reserved words related to asynchrony support. All other words in table are reserved words which cannot be identifiers. This is keywords in Dart programming language. Now we will talk about variables. Here an example of creating a variable and initializing it. We go to Dartpad. Here we find var number equal 42. That's what's mean. Variable is changing in our program. Can change. Variable store references. The variable called name contains a reference to a string object with the value of Bob in this example. Another option, we can declare a variable and initialize it in this way or in this way. This is similar to JavaScript, or we can in this way, integer number equal 42. Default value. What is default value? And initialized variables that have nullable type have an initial value of null. Null safely optional. If we don't initialize variable, this variable can take null. If we put question exclamation mark, that means accept null. Assert, this is condition about the variable. We return back to our video. Default value initialized variables that have nullable and null safely. Assert, note, production code ignores the assert call during development. On the other hand, assert condition throws an exception if condition is false. For example, see assert. We will talk about it later on this video. If enable null safely, you must initialize the values or add init or start value to variable. For example, 30. If you delete null safety. You don't initialize local variable where it's declared, but you don't need to assign it a value before it's used. For example, we like to count line count lines, else line count 0, print line count what this code result. Let's see. We have problem y undefined. We like to count late variables. For example, here we call var equal false or true, for example. Here the problem solved. Count lines, this is function, we call it any way. For example, this value integer term variables. Count line is return, for example, 40. Now we assigned value 40 to line count. If we run this program, we can find 40. Written back, what is late? Late keyword in null safely. Late modifier, which has two use cases, declaring a non-nullable variable that initialized after its declaration. Lazily initializing a variable. Danger. This keyword is danger. If you forget to initialize the variable, you will find error in your program. For example, if we use this code description, if we don't initialize the variable, we find the error. If we run this program, we find late error because we don't initialize the variable. Late means the variable description. We are going to initialize this value later on code before use it. If we run, no problem. But we initialize before use. If you fail to initialize late a variable, a runtime error occurs when the variable is used. This important notice. The variable may not be needed, and initializing is costly. You are initializing an instance variable, and its initializer needs access to this. This is a program only called to read thermometer, lazily initialized. String temperature, read thermometer. Now we talked about late variables and default value and variables. We move to final and const, important keywords. If you never intend to change a variable, use final or const. Const is equal to let in Swift programming language. For example, either instead of var or in addition to a type, a final variable can be set only once. A const variable is a compile time constant. Const variables are implicitly final. Note, instance variables can be final but not const. Instance variables, we'll talk about it later. Here example, creating setting final variable, final, without a type annotation, final, string nickname Bobby. We call final without type annotation or with type annotation. You cannot change the value of final variable. This is show error. Final variable can only be set once. Use const for variables that you want to be compile time constants. If the const variable is at the class level, mark it static. Const, where you declare the variable, set the value to compile time constants such as number or string literal. A const variable or the result of an arithmetic operation on constant variable. Const bar, for example, 1 million unit of pressure, constability, standard pressure. The const keyword is not just for declaring constant variable. You can also use it to create constant values in value or in variable. Let's delete this code. For example, const x equal to 3. If we print x, we find 3. If we need to change the value of x, we find error. Why? Because the variable cannot be assigned a value. If we change this, we can use y, for example, integer y equal x, that constant. If we print y, we find 3. If we need to change y, we are able to change equal 4, for example, no problem and no error. That's the difference between const in value and const in variable. Final can be const equivalent to const. You can omit const from initializing expression of constant declaration like as above. Don't use const redundantly. You can change value of non-final, non-const variable, even if it uses to have a const value. You cannot change the value of a const variable. You can define const that use type checks and casts as collection if, separate operators, and const object as integer. We can change. Not all the final object cannot be modified. Its field can be changed. In comparison, a const object, its fields cannot be changed. They are immutable. This important notice between final and const. Built-in types. We talked about variables, default value, late variables, final and const. Important concepts, introduction about Dart programming language. We move to built-in types. Dart language has special support for following: numbers, integer, double, strings, string, booleans, true or false, lists, list, also known as arrays, sets or set, maps, map, runs, often replaced by the characters API, symbols, symbol with a value and the value null. You can Also using literal, for example, this is string to is a Boolean literal, because variable in Dart refers to an object. All variables refer to an object, instance of a class. Some other types also have special rules in Dart language. Object superclass of all Dart classes except null. Future and streams used asynchrony support. Iterable used in for in loops and in synchronous generator functions. Never indicate that an expression can never successfully finish evaluating. Most often used for functions that always throw an exception. Dynamic indicators that you want to disable static. The same indicates value that never used, often used as a return type, object or object null or null and null. Classes have special rules to class hierarchy. To and bottom section, understanding null safely. Let's start. Numbers. Dart numbers come in two flavors: integer, double. Integer, no larger than 64 bits, depending on the platform. Native platforms values can be from 2 notation 63 to 2 notation 63, from -2 positive. On the web, integer values are represented as JavaScript numbers, 64-bit floating point values with no fractional part. It can be form, double, precision, floating point numbers as specified by the IEEE 754 standard. Both integer double are subtypes of num. Apps, CL, floor, among other methods. Bitwise operators such as integers are numbers without decimal point. Here are some examples defining integer letters. For example, all of this is integer. Integer, no problem. This is problem Y. Value of double cannot be assigned to variable of type integer. This is double. This solves the problem. This is double. The same idea. You can declare variable num plus assign pre-decrement. You can refer other courses in our YouTube channel. You can find JavaScript, programming language, Java, Python, PHP, or any other language, programming language in our YouTube channel. We describe all of them in details. The same ideas in Dart programming language, no difference. Programming language concepts are similar. You can refer playlists in our YouTube channel. Double, the same idea. Here how you turn string into number, integer bars or integer tribars. Tribars can accept null to string, here string to double bars. toString as fixed here in decimal points. Round the value. The integer type specified the traditional bitwise shift, complement, and or and XOR operators, which are useful for manipulating and masking flags in bit fields, for example. Bitwise and shift operator section, we will talk it later. Literal numbers and compile time constants, many arithmetic expressions, multiply, plus, minus, add, subtract, division, all of them in numbers and Dart. Now, we talked about numbers in Dart. We'll talk about strings. What is strings in Dart programming language? There are many ways to code strings. Dart string holds sequence of UTF-16 code units. You can use either single or double quotes to create string. Single or double quote. You can put value of an expression inside a string using expression, $, curly braces. If the expression is identified, you can skip the curly braces. You get string corresponding an object that calls object to string method. For example, $S, we find it. Or expression in curly braces with $. That's it. The equality operator tests whether two objects are equivalent. Two strings are equivalent if they contain the same sequence of code units. The concatenate strings using adjacent string letters or the plus operator. Adjacent, that's mean string, 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 no problem. Or plus, no problem. Another way to create multi-line string, use triple quote, either single or double quotation marks. Triple quote. You can create a raw string by prefixing it with R. Runs and giving clusters for details on how express Unicode characters in string. Symbols. Use U, \U with code. No problem. You can find all of them here. Almost. These don't work in const string. These work in const string. We find strings and regular expression also contains start with, end with, index of. Substring, split, length, to list, any other, to uppercase, to lowercase, all available. And strings, trim is empty, is not empty. Replacing replace and to string all available. Now we talked about numbers and strings. We move to Booleans. Booleans, true or false. To represent Boolean values, Dart has a type named Boolean, bool. Only two objects have type bool. The Boolean letter is true or false, which are both compile time constants. Dart type safely means that cannot use code if non-Boolean value, or still non-Boolean value instead. Check of none, check for null, check for zero, check for empty string. Now, what is lists? Perhaps the most common collection is nearly every programming language. Here, arrays, in order to group objects in Dart. In Dart language, only three ways of collections: list, set, or map only. List, arrays, or any other. This is list. Set, not refer to sorting items. Maps is key value. What's the difference? Set is most quick, faster than list. Set is faster than list. Map is faster than list. Set not consider ordering. List consider ordering. Map search by key directly. Also, map is fast. Dart list literally look like JavaScript arrays literally. A simple Dart list. Dart infer list has type list integer. If you try to add non-integer object to this list, to enter the runtime realize it. This is generic data type. You can add comma after the last item. In Dart collection literal, this trailing comma does not affect the collection, but it can help prevent copy-paste errors. If we define this list, no problem. If we print the list, we are both plain. Lists use zero-based indexing, where zero is the index of first value, and list length -1 is the index of last value. You can get list length and refer to list value just you want. You would in JavaScript length, for example, print list length run 3. Or if you want to access by index, no problem. For example, 1 print boot. To create list that compile const before literal. This line will cause error. No changing const. Here 3 points that introduce separate operator and the null aware separate operator, which provide concise way to insert multiple values into collection. For example, you can separate this way 1, 2, 3. List 2 from 0 with list 1, 0, 1, 2, 3. Print list 2. Let's print list 2. We find 0, 1, 2, 3. Expression, that means null, except null, to avoid exception. If we don't define list 1, this is no problem. For example, list var list with no value, there's no problem. Print 0. We can also use if, collection if, or for loop in list. For example, this code nav here, if true, for example, outlet, add outlet to list outlet. If false, for example, false, don't add outlet. We can use also for in list, for loop in this way. For loop, list of strings, let's print it. Now we find for loop about this list 0, 1, 2, 3. In list of integers, print hash with value 0, 1, 2, 3. Or we can make it expression plus 1, for example, no problem, 2, 3, 4. If and for more details, generic collection. This is list important data type in Dart programming language. Another is set. Set, what is set in Dart? An ordered collection of unique items. Dart supports it, provided by set literals and set type. This is set, for example, halogenies. If we print halogenies, no problem. Run, we find set of items. Dart infers that halogenies has the type set string. If you try to add the wrong type of value to set, the initializer or runtime raises an error for the information type inference. To create an empty set, use literal or assign to to a variable of set. This work also create a map not set. This create a map not set. Set or map. The syntax for map literals is similar to that for set literals because map literals came first. Curly braces defaults to the map type. If you forget the type annotation on curly braces or the variable it's assigned to, then that creates an object of type map, dynamic. Add items to an existing set using to add the add or add all method. For example, here if the value is existed in set, we don't repeat values in set. Here if we add a florin and add all halogenies, if we print elements, we don't find two florin, one florin only. Why? We run one florin. Why? Because it existed. Use length to get number of items in set. Length, print length, no problem. 5. Const with set, support separate operators also. Collection if and for, just like lists do. Now we talked about list set. We will talk about map now. Map in general, map is an object that associates keys and values. Both keys and values can be any type of object. Each key occurs only once, but you can use the same value multiple times. Different about set. Set value, not repeat. Here example of map. This example. Key and value any type, no problem. If we print gifts, for example, no problem, print gifts first, second, fifth. We find all lengths, no problem. 3. We find all also for or if we here if false, print this, run 2, not add this value. Dart map string string. You can create the same object using map constructor by this way, key value, by key and value. This way, the same idea. Map string string, collection literal when it's possible. That means map, you can use this instead. The same for this. You can use literal by key and value. If you come from a language like C# or Java, you may expect to see new map instead of just map. Enter the new keyword is optional. Adding a new key value. Key value pair. Retrieve value by key. Use length for length of map. Create map that compile time, const. Maps support separate operators. The same for set and list. If and for also. This is list set map. Now we will talk about runs and Griffin clusters. Symbols. Dart runs expose the Unicode code points of a string. You can use character package to view or manipulate user perceived characters, also known Unicode. Extended Griffin clusters. characters, for example. Now in this way, runs and grapheme clusters use Unicode backslash with U with Unicode UTF-16. Characters also you can review here. High with any symbol. Symbols different about runs and grapheme clusters. Symbol object represents operator or identifier declared in the Dart program. You may never need to use symbols, but they are invaluable for API. To get the symbol for identifier, use symbol literal. Just hash followed by identifier radix bar. Now we're back. Functions. Dart is true object-oriented language. Solving functions are object and have a type. Function, this means that function can be assigned to a variables or passed as arguments to other functions. You can also call an instance of the Dart class as if it were a function for details callable classes. Here an example, implementing function is noble integer atomic number, return noble goes atomic number not equal null. Also, effective Dart recommends type annotation for public API. Function return type. We can use void functions. That means no return. Void. That is main no return type. Is noble return for functions that contain just one expression. You can use shorthand syntax. By equal arrow expression, syntax shorthand for return expression. The arrow notation is sometimes referred to as arrow syntax. Only an expression, not a statement, can appear between the arrow and the semicolon. For example, you cannot put an if statement there, but you can use conditional expression. What is parameters? Function can have any number of required positional parameters. These can be followed either by named parameters or by optional positional parameters, but not both. Some APIs notable, Flutter, widget constructor use only named parameters, even for parameters that are mandatory. You can trailing commas when pass arguments to a function or when you define function parameters. Named parameters are optional unless they are specially marked as required. When calling a function, you can specify named parameter using parameter name colon value. For example, enable flags, bold, true, hidden, false. When defining a function, use param1, param2, etc. to specify named parameters. Boolean, bold, Boolean, hidden. If parameter is optional but cannot be null, provide default value. Although named parameter are kind of optional parameter, here is required keyword important. Widget child. If someone tries to create scrollable without specifying the child argument, then analyzer reports an issue. Optional positional parameter. Wrapping a set of function parameters in square brackets marks them as optional positional parameter. Result from this message. If device not null, result with the device, return result. Here an example of calling this function without optional parameter, no problem. And here is an example of calling this function with third parameter. Default parameter value. inside null safely in Dart programming language. If you don't need to required, you can make default parameter values. The function can use equal to define default value or optional parameter. Both named and positional the default value must be compile time constants. For example, bold equal false, hidden equal false. Enable flags bold true. This accepted because hidden equal false initial value. Deprecation note, old code may use a colon instead of equal, the default value of named parameter. The reason is that originally only colon was supported for named parameter. That support may be deprecated, so we recommend that use equal to specify default values. This example show how to set default values for positional parameter. The same idea equal with default value. You can also use list, pass list or map as default values. The following example define a function, do stuff that specify default value, default list for the list parameter, and the default map for gifts parameter. This is function and parameters. The main function is important in Dart. Every app must have a top-level main function which serves as the entry point of the app. The main function return void. This means no return or optional return and has an optional list string parameter for arguments. Here is a simple main function, print hello world. We took it first of our video. Here example of the main function for a command line app that takes arguments. Print arguments. You can use arg library to define parse functions as first class object. You can pass a function as a parameter to another function, for example, integer element, print element for each print element. The return value for this is, let's see this example. The return value or the value for this function, we use it in another function. Here, print element integer element, print element. For lists, for each list item, print element. Run, print 1, 2, 3. You can also assign a function to a variable such as message to uppercase, modify message to uppercase. Anonymous function. What is an anonymous function? Most functions are named such as main or print element. You can also create an ableist function called anonymous function, or sometimes lambda or closure. You may assign an anonymous function to a variable so that, for example, you can add or remove it from collection. For example, this function is anonymous. No name for this function. For example, we embed this function into this function. For each item, avoid using for each with function literal. No problem. Text of item 0 equals 1 2. This anonymous function with literal or arrow function, shorthanded function, the same for previous. Lexical scope. What is lexical scope? That is a lexical scope language, which means that the scope of variables is determined statically. Simply by the layout of the code, you can follow the curly braces outwards to see if a variable is in scope. Here is an example. Top level, see this example. Top level true, main, inside main, my function. Inside function, true, nested function, inside function, true, top level, inside main, inside function, inside nested function. That's how nested function can use variable from every level all the way up to the top level. We find lexical closure also. Closure, a function object that has across access to variables in its lexical scope, even when the function is used outside of its original scope. Function make other 2, make other 4. No problem, we can use function outside the void main. Testing function for equality. Here example. For class A static void main a bar comparing static methods. Instance 1 of A, instance 2 of A, equality, assert. Return values. All functions return a value. If no return value is specified, the statement return null is implicitly append to the function body. This is functions in Dart programming language. What is operators? That supports the operators shown as the following table. You can implement many of these operators as class members. Ordinary operators, plus plus, minus minus, in parentheses, unary prefix, not unary plus plus, minus minus, await, expression, multiplicative, additive, shift, bitwise and bitwise XOR, bitwise or relational, and type test, as is not, equality, equal or not equal, logical and logical or if not, if null, conditional, ternary operator, cascade, assignment, etc. Operator precedence is an approximation of the behavior of Dart parser. For definitive answers, consult the grammar. When you use operators, you create expression. Some examples: a plus plus, a plus b, a equal b equal b. This result true or false. This is assign value of b to a. Ternary operator a is t. Operator table for operators that take two operands. The leftmost operand determines which method is used. For example, if you have vector object and a point object, then a vector plus a point uses vector addition. What is arithmetic operators? What is arithmetic operators in Dart? Dart supports usual arithmetic operators as shown in the following table: add, subtract, unary, minus, also known as negation, reverse the sign of the expression, multiply, divide, returning an integer result, get the remainder of an integer division modulo, assert, we have also other postfix, increment and decrement operators, plus plus variable, variable plus plus, minus minus variable, variable minus minus. To understand all of this, you can refer any programming language course in our playlist videos on YouTube channel. For example, JavaScript, PHP, Python, or any programming language. The same idea. For example, integer a, b, a0, b, plus plus a, increment a before b gets its value. Increment after b gets value. Decrement before, decrement after. Equality and relational operators, equal, not equal, greater than, less than, greater than or equal to, less than or equal to. All of this return false or true. Operators, type test operators, the as is and is not operators are handy for checking types at runtime. As typecast also use it to specify library prefix. Is true if the object has the specified type, is not true if the object does not have the specified type. Employee as person, first name Bob. Employee is person, check. is not the same idea. The code is not equivalent if employee is null or not a person. The first example throws an exception, the second does nothing. Assigning operators, we find this assignment operators equal, multiply equal, division equal, left or right, exponential, plus equal, division equal, left or right, shift, or, and minus, integer division, compound assignment, equivalent assignment. The same idea. The following example, a multiply 3, 2 multiply 3 equals 6. Logical operators, we find also logical operators, not expression or logical and. Here example, bitwise and shift operators and or unary bitwise complement, shift left, shift right, unsigned shift right. Conditional expression, this is one line, conditional expression. For example, visibility is public or private. Let's see what this code result is. Public true visibility. Let's print visibility this result in public. Run public is to change to false, this print private. Now null check this example. For example, to question mark means if this existed, print this, not existed, print default value. Cascade notation, the same idea. Cascade notation with text, if text null, use its member. Syntax requires at least 2.12 version of Dart SDK. The previous code equivalent to the following: button text classes add on click listen. You can nest cascade, for example. Be careful. Construct cascade function returns object. Other operators function application presents function call. Subscript access represents a call to overridable operator. Conditional subscript access, member access or accessors. Conditional member access, null assertion operator. This come in last of the line. Cast expression to its underlying non-nullable type, throwing a runtime exception if the cast fails. Example, assert who is non-null and selects the property bar, unless who is null, in which case a runtime expression is thrown. Now we talked about operators, functions, built-in types, and variables, and some introduction of Dart programming language. We move to control flow statement. We have many of it in Dart programming language. We have if else, we have for loops, while and do while loops, break, continue, switch case, and assert. We'll talk about exceptions, try catch, and throw later. If and else, Dart supports if and else statement with optional else statement as the next sample shown. Let's see this. Is raining, you bring raincoat. Else if is snowing, wear jacket. Else put hook down. Unlike JavaScript, conditions must use Boolean values, nothing else. Boolean values. For loops, you can if is public, for example, print public, the same idea to ternary operator. Else what code executed if this condition not true. Print private only. Print private. We don't need visibility. Otherwise, that's it. Run private. We can also use else if with condition and nested if else statements. For loops, the same. You can iterate with standard for loop, for example, for I write message, conclusion dart for loops, capture the value, avoiding common pitfall found in JavaScript. For example, consider I equals 0, I less than 2, I plus plus. That was 0 and 1. You can use for in within keyword form iteration. This is similar to for each. The same idea to practice using for in. For each, we have for in and for each and regular for loop. While and while loop evaluate condition. Here, if we type for var I in, for example, 10, here we need to define value integer, for example, integer x equal 10. Here type x, print I, here x, use it for loop, must implement iterable. For I equal 0, for example, I less than x, I plus plus, print x 0 from 0 to 9. While the same idea, but we don't know how much we loop or iterate while syntax. The difference between for loop and while loop. For we know how much iteration loops. While we don't know. What's the difference between while and do while? While don't necessarily do this function inside while condition, but do while and or we do this function one time at minimum. Do while loop evaluate condition after the loop. Break and continue. What is break and continue? Break from keyword, break the while loop and go outside while. Continue, skip one iteration to next iteration. You may write that example differently. Iterable, switch and case. What is switch and case? Command, execute pending, execute closed, break, execute approved, denied, open, execute unknown. Command open, error missing, break. Why? For example, omit break statement in case close first generate an error. Command runs for both closed and now closed because no break after case. If really want for a throw, continue executing at the now closed label. Case close can have local variables which are visible only inside the scope of that clause. Assert. What is assert? Important keyword. During development, use an assert statement, assert condition, optional message to disrupt normal execution if Boolean condition is false. You can find example of assert statement throughout this tower. Here are some more. Assert text not equal null. Make sure variable has no null value. Assert number less than 100. Assert URL starts with HTTPS and many uses of assert. To attach a message, HTTP URL string should start with HTTPS. First argument of assert can be any expression that resolves to a Boolean value. If expression's value is true, the assertion succeeds, and execution continues if it's false. The assertion fails and expression an assertion error is thrown. When exactly do assertion work? That depends on the tool framework you are using. Flutter enable assertions in debug mode. Development only tools such as Declarative typically enable assertions by default. Some tools such as Dart Run and Dart2JS support assertion through command line flag enable asserts. In production code, assertions are ignored, and the arguments to assert are not evaluated. Now we talked about control flow statements. If and else, for loops, while and do while, break, continue, switch and case, and assert. We talked about many issues in Dart programming language: introduction, variables, built-in types, runs and functions, and operators, and control flow statements. Now we move to exceptions. What is exceptions or defensive programming? How we code it in Dart programming language. Your Dart code can throw and catch exceptions. Exceptions are errors indicating that something unexpected happened. If the exception is not caught, the isolate that raised exception is suspended, and typically the isolate and its program are terminated. In contrast to Java, all Dart's exceptions are unchecked. Exceptions method don't declare which exception they may throw, and you are not required to catch any exception. Dart provides exception and error types as well as numerous predefined subtypes. You can, of course, define your own exceptions. However, Dart programs can throw any non-null object, not just exception and error object as an exception. Exceptions deferred load exception, format exception, integer division by zero exception, terminated, IO exception, isolates bound exception, null rejected exception, OS error timeout exception. Error is also abstract class instantiation error, argument error, assertion error, async error, concurrent modification error, forward errors, unimplemented error, unsupported error, type error, state error, stack overflow error, remote error, out of memory error, null thrown error, no such method error, any other. You can refer in Dart. Throw, here an example, throwing or raising an error, format exception. You can also throw arbitrary object. At least one section. Here example. Run. Throw exception. Production quality code usually throws types that implements error or exceptions. Throw distance to point other, throw an implemented error. Catch, what is catch? Catching or capturing an exception stops the expression from propagating unless you rethrow the exception. Catching an exception gives you a chance to handle it. Try on or try on catch. You can use multi-on catch one. Out of Lilmos exception, by more Lilmos, breed more Lilmos. Unknown exception, something really unknown. Try exception details. Stack trace. You can define your own exception by through class try on catch exception actually hand exception will propagate, rethrow keyword, allow callers to see the exception, misbehave, try for dynamic, void callable. Here we write this code, run code, misbehave actually handled JS search method error, main finished handling JS search method error. Rethrow the same, repeat. Finally, what is finally in exceptions? Try finally to ensure that some code runs whether or not an exception is thrown. Use finally close. If no catch clause matches the exception is propagated after the finally clause runs. Always clean up even if an exception is thrown. Finally, error, handle exception error, then clean up. We talked about exceptions. Now we move to classes. As we talked before, Dart is object-oriented language. Dart is an object-oriented language with classes and mixed-based inheritance. In other programming language, we find in Swift, for example, protocol. Protocol equal to makes sense with keyword in Dart language. Every object is an instance of a class, and all classes except null descend from object. Mixin-based inheritance means that although every classes here in classes in Dart, we find extents for inheritance and implements for interface implement. We don't find keyword interface, we find abstract for interface. All of these keywords in object-oriented programming. To understand more, you find all of these terms. Inheritance, we find implements, class implements. What's the difference between implements and or extends and implement? Extends for one class. Class A extends class B, only one. But implements may be one or more. For example, class A implements class B, C, and D, for example, but not extends more than one class. To resolve or to solve this problem, we find makes sense is equal to protocol in soft programming language, for example. Makes sense class A extends class B with keyword with is with class B, C, etc. Using class members. For example, here we find delete this. We define any class, for example, class A, for example, class animal. Here we define abstract. Abstract, that means this is interface. We can define attributes and methods. For example, Boolean is alive equal true. Here in abstract, no problem. By true, we don't need true, only undefined name. We assign value true. We define methods, for example, eat, string eat, for example, eat. That means a function or method. Define another string, another method. Move, for example, with no return value because it's abstract or interface. This is three methods. We make another class. For example, class birds, for example. Bird extends animal. Now we have error. Why? Because eat and move not implemented. We use implements. Now use override eat, for example, string eat, override string eat, return string. That is what string for bird, knock knock, for example. And another override for move. For move function, move. In this way, we find undefined name E, Y, correct name to one that defined, missing concrete implementation, guitar animals is alive, and sitter is alive. In this way, can find this alive is alive equal true. Is alive equal true, that means we have overridden numbers. We need here to define override before is alive. No problem. Positional argument. Here we define, for example, birds, for example, equal bird. We assign values to bird. For example, we assign values eat, for example, another move, for example. Anyway, print bird to string. We have now if we print bird, we find compilation error. Variable must declare it because using const final variable or type of name variable, for example, If we use, for example, bird eat and print bird move, for example, move fly fly, and fly run eat and move, knock knock fly fly. Let's see another implement for instance or interface animal. Let's define const, for example. This is static field, cannot be declared. Another way, there must be declared. Variable can name keyword var. Var. Now before run this code, we define another implementation of animal cat, the same attributes and methods. We constructor or define copy of this class cat and bird, assign values, and print the result. Run knock knock fly fly meow meow hash hash. This is implementation. Now if we want to extend extend, for example, here define a class, for example, chicken. Chicken extends bird, bird. Here we find chicken extends bird. All of these properties we find here without any code of this. Knock knock fly fly. If we want to change this function, for example, we can override move to Coco, for example, not fly, move. For chicken, we define another value, for example, integer, any other value, for example, integer weight, For example, integer weight 10. We define chicken here. Chicken. If we try to chicken, if we try to access any properties, we can find it. Chicken, if we print chicken, we find all of properties in it. Weight is alive, eat, move, or any other properties. Let's see. Print is alive. Weight, for example, move. Eat, for example, move. Run this code and see what's the result. 2 is alive. Weight 10. Knock, knock, cook, cook, cook. This is classes and object-oriented in Dart, in short. Using class member dot operator instead using constructors, same idea. Also new, no need to new, const constructors, immutable point, const omit, getting an object type, runtime type. If we print this, for example here, we print bird dot runtime type. Here we find the name. Let's do it first. The same bird, cat, and chicken. Run bird, bird, bird. See here bird, not chicken. Why? Bird is bird, eat and fly. Cat is bird. Cat implements animal is bird. Runtime, oh bird. We need to define the name. Cat, chicken, runtime chicken. Run this bird, cat, chicken. That's true. Runtime type, instance type variables, the same. We took it. Declare instance, declare null. Nullable. Date time now. Factory constructor. Factory, what mean by factory? Factory constructor, late, be careful. Factory constructor, the same as implementing of interface. Here we find logger, implement the interface of logger, I find catch put if absence name logger internal name factor from JSON and internal this name. This is factory. Factory implementation of interface in class. Constructors. What is constructors? The same idea. Constructors. This keyword with a way to do this. Stay tuned. This x equal x. This y equal y. Implement. Not use this only when there is the name conflict. Otherwise, Dart style omits this. Pattern. Point this. Syntax suitable for setting x and y before the constructor body runs. Default constructors. Constructors are not inherited. Name it constructors. We find also set and get for classes and constructors. Initial list, initializer list, superclasses, no args constructor, main class, no args constructor. If you run this code in person employee instance of employee, person from JSON in person, employee in employee extends person. In main employee from JSON, print employee, prints in person employee, instance of employee. Warning arguments to the superclass constructor don't have access to this. For example, arguments can call static methods but not instance methods. Initializer list. Assert warning the right hand side of an initializer does not have access to this. Assert. Redirecting constructor. Constant constructor. Another way to handle late initialization of a final variable is to use late final carefully. Factory constructor have no access to this. Invoke methods. What is methods? Are functions that provide behavior for an object. Instance methods. This distance to. This is methods. Operators. Operators are instance methods with special names, plus, minus, division. We discussed it before. You may have noticed that some operators like not equal are not in the list names, and are not in the list of names. That's because they are just syntax sugar. For example, expression is sugar for not equal. The same operator. Getter and setter. We talk about this. Getter and setter for hide information in class. For example, let's define class A. We define variables, integer, variables age, for example, equal 25. Delete all of this, don't need. Here we call get, integer get, value equal age. You don't need if you is already in Dart, get and set. This is already existed. But if you want to change the value, you can change. If you want to set the same idea, set value with integer value, integer v, return age equal v. This is return to our code main a equal a. If we call value here equal to 30, print a value, run this code, we find 30. But if we don't use this, also this, we find 25. That's it. This is getter and setter. Operators such increment, decrement, all of this, abstract classes talked about. This is equal to interface in other programming languages. Factory implement interface or abstract. Implicit interfaces implements keyword. We talked about you can implement many interfaces or abstracts classes, extending a class one class. if you need to extend more than one class, you need to use extend with or mixins in Dart, override, and warning, if you override equal, you should also override object hash code getter. For example, overriding equal and hash code. Implementing map key. No such method. This is unless you override no such method using a non-existing member result in no such method error. You cannot invoke an implemented method unless one of the following is true. The receiver has a static type dynamic. The receiver has a static type that defines the unimplemented method. Abstract is okay. The dynamic type of the receiver has an implementation of no such method. That's different from the one in class object. Extension method, the same. Enumerated types. Enumerated types in object-oriented programming. Here we find, for example, enum color, red, blue, white, red, green, blue. Can't be used as identifier because it's a keyword. Enum we define out of the main class color. Then we define color equal color enum cannot be instantiated. Color, if we print color, we find this values. Print color. With operator, we find color name to string, no such method invocation, runtime type. For example, non-nullable local variable color must be assigned before it can be used. Color, for example, here, color runtime type. Non-nullable local variable must be assigned before it can be used. Equal color return to enum. List colors, color value, assert colors, which statement, a color blue. For example, variable color equal color dot blue, green, red, and this. For example, blue. If we print color, we find it is color type. If we print color is blue. You cannot subclass mix in or implement an enum. You cannot explicitly instantiate an enum. Adding features to class mixins with keyword with. With you can extend more than one class. You can also use on, extends musical with musical performer. Class variables and methods, capacity, static variables are not initialized until they are used. Note, lower camel case, preferred for constant names. Static methods. What is the static methods? Class methods don't operate on an instance and thus don't have access to this. They do, however, have access to static variables, as the following example shows. You invoke static methods directly on a class. Note, consider using top-level functions instead of static methods for common or widely used utilities and functionalities. We talked about classes in Dart programming language. We talked about multi things, control flow statement, exceptions. We talked about operators, functions, built-in types, variables, and keywords, and some introduction about Dart programming language. We move to generics. What is generics in Dart programming language? If you look at the API documentation for basic array type list, you will see that type is actually a list of type E. The notation marks list as a generic or parenthesized type, a type that has formal type parameters. By convention, most type variables have single letter names such as E, T, S, K, and G. Why use generics? Generics are often required for type safety, but they have more benefits than just allowing your code to run. Properly specifying generic types, use generics to reduce code duplication. Strings you can declare as list of string. Leave that list of string. That way your fellow arguments, programmers, and your tools can detect that assigning a non-string to the list is probably a mistake. Here's an example. Another reason for using generics to reduce code duplication. String, generic collection, and types they contain. Note, in contrast, generics in Java use eraser, which means that generic type parameters are removed at runtime. In Java, you can test whether an object in a list, but you cannot test whether it's list string. You can refer Java playlist course in our YouTube channel for more information or for more description. Restricted the parameterized type extends, for example, T extends object. T extends some base class, foo some base class, extender. It's okay, specify to generic argument. Specifying any nonce-based class type results in an error. Using generic methods. The same. T of T-list. Using generic methods. Initially, that generic support was limited to classes. A newer syntax called generic methods allows type arguments on methods and functions. Here, generic type parameters on first T allows you to use the type argument T in several places. In the function return type, in the type of an argument list type, in the type of local variable T temp. Libraries and visibilities. Import and export and extend. Import library if you are curious why Dart uses underscores instead of access modified keywords like public, private. CSDK issues. Using libraries. How to use libraries. Use import to specify how to namespace from one library is used in the scope of another library. For example, web apps generally use Dart.html, import Dart.html. Or package test Dart. No problem. Requires keyword import. Package name. The package if you specify. URI stands for Uniform Resource Identifier. URLs Uniform Resource Locators. Are a common way, a common kind of URI. Specifying URI prefix by aliasing as live2, for example. You can use it live2, importing only part of a library. Show foo, hide foo, you can use this. Easily loading a library, differing loading, also called lazy loading, allows a web app to load a library on demand. If and when the library is needed, here are some cases when you may use deferred loading to reduce a web app's initial startup time, to perform A/B testing, trying out alternative implementation of an algorithm, for example, to really use functionality such as optional screens and dialogues. Only Dart2JS supports deferred loading. Flutter, the Dart VM, and Dart Diff C don't support deferred loading. To lazily load a library, you must first import it using default as hello. When you need to the library, invoke load library using the library identifier. Library await hello. Load library, for example, hello greeting. You need to alias keyword. Everything code await keyword pauses execution until the library is loaded. Here await async default as asynchronous support. You can invoke load library multiple times on library without problems. Library is loaded only once. Keep in mind the following when you use default loading. Default library constants are constants in the importing file. Remember, these constants don't exist until the default library is loaded. You cannot use types from a default library in the importing file. Instead, consider moving interface types a library imported by both the default library and importing file. That implicitly inserts load library into the namespace that you define using default as namespace. The function returns a future. Implementing libraries, set create library package, including how to organize library source code, how to use the export directive, when to use BART directive, when to use library directive, how to use conditional imports and exports to implement directory that support multiple platforms. Asynchrony support, we talked about generics, we talked about classes, Dart programming language, exceptions, control flow statement, operators, functions, built-in types, variables, keywords, important concepts, and introduction about Dart programming language. We will talk about asynchrony support future stream. In short, async await keyword support asynchronous programming, letting you to write asynchronous code that looks similar to synchronous code. That's different from thread in other programming language. When you need the result of completed feature, you have two options. Use async await as described and in the synchronous programming code lab. Use the future API as described. Code that async and await is asynchronous, but it looks a lot like asynchronous code. For example, here is some code that uses wait to wait for the result of an asynchronous function. To use await, code must be in async function and function marked as async. Use await. Not although an async function may perform time-consuming operations, it does not wait for those operations. Instead, the async function executes only until it encounters its first await expression. Then it returns a future object, resuming execution only after the await expression completes. Try catch, and finally, handle errors and clean up in code that uses await. No problem. Await, interpoint, async, for example, await, and await expression, async, await. In main, declaring async function. The preceding example uses a async function check version without waiting for a result, a practice that can cause problems if the code assumes that the function has finished execution. To avoid this problem, use an awaited future linter rule. An awaited Now declaring async function, string version, async before return, handling streams, async await for. If you get a compile time error when implementing an asynchronous for loop, make sure the await for is an async function. Generators sync *6 synchronous asynchronous. Synchronous generator returns a retrievable object. Asynchronous returns a stream object. Yield asynchronous here, stream here retrievable. This is the difference. Async yield callable classes. If you run this code, hi there gang. One of our functions string A, B, C print with each other. One of our function hi there gang. Print out. This is generics and callable classes. Generators, asynchrony support. We move to isolates. What is isolate? Most computers, even on mobile platform, have multi-core CPU. To take advantage of all those cores, developers traditionally use shared memory threads. Running concurrency, however, shared state concurrency is error-prone and can lead to complicated code. Instead of threads, all Dart code runs inside of isolates. Each Dart isolate has a single thread of execution and shared no mutable objects with other isolates. Type diffs. Type alias, often called type diff because it declares with the keyword type diff, is a concise way to refer to type. Here's an example declaring and using a type of alias named integer list. Type diff integer list of integer list 1, 2, 3. Type alias can have type parameter. List mapper x, map x, list x. Type div. Before 2.13, type divs were restricted to function types. Using the new type divs requires language version to at least 2.13. We recommend using inline function types instead of type divs for functions in most situations. However, function type divs can still be useful. Type divs compared to integer function TATB. Sort, main, use it. What is metadata? Use metadata to give additional information about your code. A metadata annotation begins with the character at, followed by either reference to compile time constants such as deprecated or a call to constant constructor. 3 annotations are available to all Dart code: deprecated, and override. For example, using override, we talked about in object-oriented classes before. Deprecated was turn on instead. You can define your own metadata annotation. Here is an example: define to do annotation that takes 2 arguments: to do who what, then who what. Do something, to do. Metadata can appear before library, class, type divs, type parameters, constructor, factory, function, field, parameter, or variable declaration, and before an import. This is way, or export directive. You can retrieve metadata at runtime using reflection. We talked about many things. Introduction about Dart, keywords, variables, built-in types, functions, operators, control flow statements, exceptions, classes, generics, asynchrony support, libraries and visibility, and generators, callable classes, isolates, type diffs, metadata. Now we talked the last section in our video. Comments. What is comments? How we use it? Dart supports single line comments, multi-line comments, and documentation comments. Single line comments only as this slashes, two slashes. If we need two multi-line comments, slash aesthetics or star, we close by the same. This way, commented is good. Multi-line. If we need to document code, documentation code 3. Documentation comments are multi-line or single-line comments that begin with 3 slashes or slash with 2 asterisks on consecutive lines have the same effect as multi-line documents comments. Inside the documentation comment, the analyzer ignores all text unless it is included in brackets. Using brackets, you can refer to classes, methods, fields, top-level variables, functions, and parameter. The names in brackets are resolved in the lexical scope of the documented program element. This is an example. Here an example documentation. Here another way. In this class generated documentation becomes linked to the documents feed, becomes linked to documents food. Another way to parse Dart code and generate HTML documentation, you can use Dart documentation generation tool, Dart doc, for an example generated documentation. Dart programming language, more features. Algorithms in Dart. Also, you can find in Amazon. If you need technology, you can refer to Udemy course we publish in Udemy. And that's it, Dart. programming language. Short tower of the runs and graphs, clusters, symbols. We talked about functions, parameters, the main functions as first class object, anonymous function, lexical scope, lexical closures, listing functions for quality, return values. We talked about operators, arithmetic operators, equality and relational operator, type test operators, assignment operators, logical operators, and bitwise and shift operators, conditional expressions, cascade notation, other operators. We talked about control flow statement, if and else, for lose, while, break and continue, switch and case assert. We talked about exceptions, throw, catch, finally, classes using class members, using constructors, getting an object's type, instance variables, constructor methods, abstract classes. We talked about implicit interfaces, extending a class, extension methods, enumerated types, adding features to class makes sense, class variables and methods. We talked about generics, why use generics, using collection literals, using parameterized type, and we talked about generic collection and the types they contain restricted parameterized type using generic methods, libraries, and visibility, using libraries, implementing libraries. We talked also about asynchrony support, handling features, declaring async functions, handling streams, generators, callable classes, isolates, type diffs, and aliases. We talked about metadata, comments, for example, single line comment, multi-line comment, documentation comments. This is Dart programming language, easy to use, and you can fast learn it. If you code with any programming language other like Java, Swift, Kotlin, Objective-C, C#, Python, PHP, any other programming language, you can easily learn Dart programming language. Dart programming language is modern Dart programming language used by Flutter technology. This is by Google company, produced now. Latest version Dart SDK 2.16. This is video about Dart programming language. I am engineer Mouaz Shahmeh, software engineer developer. I have 5 years experience, about 5 years experience of Flutter technology and Dart language. Here we go. You practice Dart programming language. It's easy to use. Practice this programming language in Dartpad or any IDE program, for example, Visual Studio Code or Android Studio, IntelliJ, Xcode, any IDE other. And peace upon you. Assalamu alaikum wa rahmatullahi wa barakatuh.
And the conclusion. What are resources of this course? The main resource is a book of data structures and algorithms in Dart. implemented in practical data structures in Dart. Jonathan Sandy, based on material by Kelvin Lowe and Vincent NGO. First edition. This edition in Null Safely Dart language 2.15. Useful book. Contain many examples, many competitions, questions and answers. Can buy it from Amazon or any other place. The source code on GitHub from this book on this link. Rewenderlich. And before requirements, before YouTube video, about 3 hours, description of Dart language as previous requirements to this course. On my YouTube channel, you can search on YouTube Dart Programming Language Tower and Mouaz Al-Shahmeh. Why learn data structures and algorithms? What is data structure? Data structures are a well-studied discipline, and the concepts are language agnostic. A data structure from C is functionally and conceptually identical to the same data structure in any other language, such as Dart. At the same time, the high-level expressiveness of Dart makes it an ideal choice for learning these core concepts without sacrificing too much performance. This is data structures. What is algorithms? Algorithms, on the other hand, are a set of operations that complete tasks. This can be a sorting algorithm that moves data around to put it in order. Or it can be an algorithm that compresses an 8K picture to a manageable size. Algorithms are essential to software, and many have been created to act as building blocks for useful programs. There are many of data structures and algorithms, although it depends on the show. Deal with it. The best algorithm or data structure depends on your problem you solve. This is introductory to this course. We talked about introductory. Now we move to complexity. For algorithms, scalability refers to how the algorithm performs in terms of execution, time, and memory. The complexities, there are important term is big O notation. We use it. Time complexity is a measure of the time required to run an algorithm. Constant time. A constant time algorithm has the same running time regardless of the size of the input. Consider the following. Void function, don't return any value. Check first list of strings, names. If names is not empty, print names first, else print no names. The number of items in names has no effect on the running time of this function, whether the input has 10 items, 10 million items, or any other number. This function only prints the first 10 million items or any other number. This function only prints the first element of the list. Here is a visualization of this time complexity in a plot of time versus data size. This is best case scenario. Time with constant time with data O1. We go notation O1. Another time is linear time. Consider the following snippets of code: void print names, list of names, or final name and names, print name. This function prints out all the names in a list as the input list increases in size. The number of iterations that the for loop makes increases by the same iterations that the for loop makes increases by the same amount. This buffer is known as linear time complexity, ON. The relation between time and data is ON. This is linear time, constant time, linear time, and quadratic time. Quadratic time, more commonly referred to as n squared. This time complexity refers to an algorithm that takes time proportional to the square of the input size. Consider the following code: print more names, list of names for 2 for loops, final underscore and names for final name and names, print name. There are 2 for loops. This time the function prints out all the name and names, print name. There are 2 for loops. This time the function prints out all the names in the list for every name in the list. If you have a list with 10 pieces of data, it will print the full list of 10 names 10 times. That print 100 print statement. If you increase the input size by 1, it will print the full list of 11 names 11 times, resulting in 121 print statement. Unlike the previous function, which operators in linear time in squared algorithm can quickly run out of control as the data size increases. Here is a graph illustration of the behavior between time and data. The relation is ON square, quadratic. The relation is ON square, quadratic. So we have constant, linear, quadratic. We have logarithmic time. For example, const numbers 1, 3, 56, 66, 68, 80, 99, 105, 450. Boolean native contains integer value, list of integers, list. For loop, final element in list. If element equal value, return true, else return false. This algorithm is logarithm n, an algorithm that can be repeatedly through half of the required comparison. Will have logarithmic time complexity. Here is a graph given the logarithmic time complexity. Here is a graph given the best think how a logarithmic time algorithm behaves. Here is best code before Boolean alternative contains integer value list of integers list. If list is empty, return false. Final middle index list length division by 2. If value greater than list middle index. For loop var I equal middle index, I less than list length, I plus plus. If list I equal value, return true. Else, another for loop for I equal middle index, I greater than or equal 0, I minus minus. If list I equal value, return true. Another return by default false. This is logarithmic time or logarithmic n. Another time is quasi-linear time. Another common time complexity will counter is quasi-linear time. Quasi-linear time algorithm performs worse than linear time, but dramatically better than quadratic time. You can think a quasi-linear as kind of like linear time for large datasets. An example of a quasi-linear time algorithm in that sort method. Note at the time of this writing, the list sort algorithm Dart internally uses quasi-linear. Dual by list sort algorithm Dart internally uses quasi-linear. Dual pivot quick sort algorithm for large set lists. However, for lists below size threshold of 32, it uses an insertion sort. The big notation for quasi-linear time complexity is O n log n, which is a multiplication of linear and logarithmic time. Here is the graph. The relation between time and data in quasi-linear time is O n log n. Comparing the time complexities, take a look at how the time complexities compare to each other for large datasets. We have O1, best case scenario, O log other for large datasets. We have O1, best case scenario, O log n, O n log n, and O n square. 5 major time complexities. Remembering how these curves relate to each other will help you compare the efficiency of various algorithms. We have other time complexities. On of k, polynomial time. O2 n, exponential time. On factor, factorial time, and there are many more. How to improve algorithm performance? Improve in I++, sum, add or equal I, return sum. Sum from 1 to 1, 10,000 or 10,000. The code loops 10,000 times and returns 15 million and 5,000. It is O n and will take a moment to run as it counts through the loop and prints results. If you're curious about how long it takes to run on your machine, you can measure it like so. Final start date time now. Final sum from 1 to 10,000 inside parentheses in +1 division, integer division of 2. We have space complexity, another concept. The time complexity of an algorithm can help predict scalability, but it is not the only metric. Space complexity is a measure of memory required for an algorithm to run. Consider the following code: integer multiply integer a and integer b, return multiply a and b. List of string, fill list integer length, return list filled length by a letter. With one small change, you could make that algorithm have a quadratic space complexity in each element of the list. Specifying 5 for length would create a list of length 5 whose elements are 5 A letters, as with quadratic time complexity. The big O notation for quadratic space complexity is O in quadratic or square. We have other notations other from than big O notation. We have big omega notation is used to measure the best case runtime for an algorithm. This is not as useful as big O because getting the best case is often untenable. Big theta notation is used to measure the runtime for an algorithm that is between the best and worst case scenarios. Other from than big O notation, we have big omega notation is used to measure the best case runtime for an algorithm. This is not as useful as big O because getting the best case is often untenable. Big theta notation is used to measure the runtime for an algorithm that is between the best and worst case scenarios. We have talked about time complexity and space complexity, memory and time. In time, we have many relations between data and time. We have linear constant, best case scenario. We have linear time. We have quadratic time. We have and worst case scenarios. We have talked about time complexity and space complexity, memory and time. In time, we have many relations between data and time. We have linear constant, best case scenario. We have linear time. We have quadratic time. We have logarithmic time. We have quasi-linear time. And we compare between them, which is better, which is worse. We talked about improving algorithm complexity, talked about space complexity and other big O notation. This is complexity. Dart programming language tower. There are 3 of data structures in Dart programming language, 3 basic. In Dart code library contain main data structures, list, map, and set. What is list? Look at this example. Final people, Pablo, Manda, Megan. Order. Elements in a list are explicitly ordered. Use it above people list as an example. Pablo comes before Manda. We talked about list and map and set in previous video on YouTube channel. You can refer it to full description about these data structures. Which is better, which is speed more than others. In search, for example, in sorting, neither. The best is map and set in speed. To repeat the item, map we have key and value. Set randomly elements but no repeat the element. All elements in list have a corresponding 0 based integer index. Start with 0 index. For example, people has 3 indices, one corresponding to each element. You can retrieve the value of an element in the list by writing the following: people 0 printing Pablo, people 1 printing Manda, people 2 printing Megan. Order is defined by the list data structures and should not be taken for granted. Some data Structures such as map have a weaker concept of order. List performance, insertion location. First inspect is where you choose to insert the new element inside the list. The most efficient scenario for adding an element to a list is to add it. People will look at last of list. People insert 0 array, we find it at the first with index of 0. We have capacity of list also. This is list. We have map. A map is collection that holds key value pairs. For example, there's a map contains usernames and scores. Eric 9 mark 12.1. Scores and row equal 0. Print scores, we'll have it in map. Import Dart collection, hash map. For example, hash map of scores. Print hash map, we find it the same result. This is list and map. We find set in Dart programming language. A set is a container that holds unique values. Imagine it being a bag that allows you to add items to it but rejects items that have already been added. For bag, candy, Joyce, Jummy. Bag add candy. Print bag, candy, Joyce, Jummy. Since sets enforce uniqueness, they lend themselves to a variety of interesting applications such as finding duplicate elements in the collection of values. My list 1, 2, 3, 1, 2, 2, 3, 4. If we move it to set, duplicate of 2, don't find it. Duplicate of 2, don't find it. Items in my list. My set contains item. My set already has it, so it's a duplicate. My set had item. This is list, map, and set in Dart programming language. We have enum. Enum not as data structure. This is related to object-oriented or class objects, constructors. We define enum with values and then we select from these values. This is basic data structures in Dart. We move to stack linked list queues. These are everywhere. Here are some common examples of things you would stack: pancake, box, paper, cache. Or notification, for example. In any system, notification is a stack. The stack data structure is identical to physical stack of objects. When you add an item to stack, you place it on top of the stack. When you remove an item from the stack, you always remove the topmost item. Here the bitter, you first eat the bitter, but the good new, but the bad new. If you want to eat any other of the bitter, you new, but the bad new. If you want to eat any other of the bitter, you first need to eat butter. Stack operations. Stacks are useful and also exceedingly simple. The main goal of building a stack is to enforce how you access to your data. There are only two essential operations for a stack: push, add an element to the top of the stack; pop, remove the top element of the stack. Limiting the interface to these to operations means that you can only add or remove element from one side of the data structure. In computer science, stack known as LIFO, last in first out, conversion of Q. Q is FIFO, first in first out. Stack is LIFO, last in first out, conversion of Q. Q is FIFO, first in first out. Stack is LIFO, last in first out. Elements that are pushed in last are the first one to be popped out. Stacks are used prominently in all disciplines of programming to list a couple, memory allocation, programming language support recursion, backtracking. Memory allocation uses stacks at the architecture level. Memory for local variables is also managed using a stack. Programming languages that support recursion manage the function calls with stack. If you accidentally write an infinite recursion, you will get stack overflow website. We have account in Stack Overflow website. We have gold, silver, and bronze patches in this website. We contribute. If you have any question, you can add in this website, beautiful website. You can find answers, multi-answers in this website, Stack Overflow. Search and conquer algorithms, such as finding a path out of a maze, use stacks to facilitate backtracking. We define a class stack of E, stack storage E, list of E storage. Override to string, return stop, storage reversed, join, enter new line this course. You can refill it. Final stack integer, push 1, push 2, push 3. Add the following two operations to your stack. Storage add element, pop, push. Another way in queue, we don't have pop and push, we have include the queue. In the queue. Push storage add element, storage remove last. Stack push 4, print stack element, stack pop, popped element. Job 4, 3, 2, 1, popped 4. This is the result. We have other operations we can use it in stack. Useful. Peek is empty, is not empty. Peek storage last with not deleting. Is empty is to look at the top element of the stack without mutating its content. Non-essential operators, there are a couple of nice to have operations that make a stack easier to use. Creating a stack from an iterable. You may want to take an existing iterable collection and convert it to a stack so that the access order is guaranteed. Of course, it would be possible to loop through the elements and push each one. However, you can add a named constructor that just sets the underlying private storage. Add the following constructor to your stack implementation. Stack of iterable elements, storage, list of elements. Now run this example in main. List smoke, S-M-O-K-E, smokestack, stack, then print smokestack pop. This is stacks. We have another data structure is linked list. What is linked list? Linked list is a collection of values arranged in linear and directional sequence. It has several theoretical advantages over contiguous storage options such as Dart list. Constant time insertion and removal from the front of the list, reliable performance, characteristics. A linked list is chain of nodes. What is node reference? Linked list 12.1 3 nodes have two responsibilities. Hold a value, hold a reference to the next node. A null reference indicates the end of the list. Node and reference, a node holding the value of 12. What is the node? Create a folder called live and root of your project on GitHub, the existing with the link. Then add a new file to this folder called linked list dart. At the top of that file, add a class called node with the following code. Node T, this is skeleton. Node require this value, this next. T value, node T next. This value, this next. T value, node T next. Since node only known about a single value, we use the standard term people use to mean that the node can hold any type. Later, when you create a linked list of nodes, you will use E to refer the type since they are elements of the list. Making node printable recursively. Override to string. Override string to string. If next equal null, return value. Return value next to string. We import linked list package. Node 1, node value 1, node 2, node value 2, linked list package. Node 1, node value 1, node 2, node value 2, node 3, node value 3, node next, node 2, node 1 next, node 2, node 2 next, node 3. Print node 1. Linked list containing a value 1, 2, and 3. Reference of 3 is null, so it is the end. Run the code and you will see the following output in the console 1, 2, 3. Linked list. A linked list has the concept of a head and tail, which refers to the first and last nodes of the list respectively. Head and tail, null. Head first item, tail last nodes of the list respectively. Head and tail, null. Head first item, tail last item. Head and tail of the list. Implement these characteristics by adding the following class below node linked list dart. Class linked list, node E head, node E tail, maybe equal null. Boolean get is empty, head equal null. Override to string. If is empty, return empty list. Other return head to string. We define function push, void push, E value, head node value, and next head, node value, and next head, tail, exist, other head. Final list, linked list integer, list push 3, push 2, push 1, print list. We have the result of 1, 2, 3. Adding values to list. We have 3 ways to add value to list, linked list. Push, append, insert after. Push adds the value at the front of the list. Append adds the value at the end of the list. Insert after add the value after a particular node in the list. Append, if is empty, push value, return to tail next equal node value. Tail equal print list. We find 1, 2, 3. In append, we first define if linked list is empty or not. If empty, the first value is first pushed value or append. If not empty, we define tail next equal to node value, the last item plus 1. Another, we predefine or second define to tail, redefine tail to new value. Linked list insert after, we have two attributes, node e value. If tail equal node append value, return tail. Second node next equal to 1. We have function of node at, return node e or null, integer index, current node head, current index equals 0, while current node not equal null, and current index less than index, current node equal current node next, and current index equal current index plus 1. Return current node. We use it to add middle node, list insert after middle node 42, print after the list before 1, 2, 3. Another we find 1, 2, 42, 3. What about performance of linked list? You have functions that add values to a linked list and a method to find a node at a particular index. Push append insert after node at. Before insert at the head, push. Append insert at tail, insert after a node. Node at returns a node at a given index. Time complexity, O1 for push, O1 for append, O1 for insert after, OI where I is the given index in node at. Linked list pop, value, head equal head next, if is empty, tail equal null, else return value. Linked list push 2, 3 to 1, open value is empty, tail equal null, else return value. Linked list push 2, 3 to 1, open value list pop after open value. Open value 1, 2, 3 after 2, 3 open value 1. Removing values from the list. There are 3 main operations for removing nodes: pop, remove last, remove after. Pop removes the value at the front of the list. Remove last removes the value at the end of the list. And remove after removes the value after a particular node on the list. Remove last if head next equal null, return pop, particular node on the list. Remove last if head next equal null, return pop, var current equal head, while current next not equal tail, current equal current next. Final value equal tail value, tail equal current, tail next equal null, return value. List linked list, push 3 to 1, print before, remove value list, remove last, after 1 to 3, after 1 to remove it 3, last item, both first item, remove last item, remove after index, current index or item, remove last item, remove after index, current index or defined index. Remove after, we have node, value next value, node next value, if node next equal tail, tail equal node, node next equal node next, next. Return value. Here we define break the link and redefine the link. Removing the middle node. Remove 2, remove the link between 1 and 2 and link 1 to 3. List 1 to 3, after 1, 3, remove it value 2. Push 3 to 1 before 3, after 1, 3, remove it value 2. Push 3 to 1 before first node last list node at 0. Remove it value list remove after first node. Remove it value. Performance. What about performance? You have hit another checkpoint. To recap, you have implemented the 3 operations that remove values from a linked list. Bob, remove it last, remove after. You have runtime complexity. Bob, remove at head, time complexity 01. Remove last, remove at tail, time complexity on is length of the list. Remove after, remove the next node, time complexity is terrible. We have override, iterator throw unimplemented error. Is empty head equal null. Abstract class iterator, get current, Boolean move next. Making a list iterable with most tab collections, you can iterate through them using a for loop. For example, here is a basic implementation of looping through a standard list. For number 1 to 3, or find a number in numbers, print number. However, if you were to try to do that with your linked list implementation, you would get an error. You can try by running the following code in main. List linked list, push 3 to 1, or element in list, print else, current node next, return current node, not equal 0, null. Class linked iterator implements iterator, linked list iterator, list, final linked list, list. Node, current node, override get current node value. Going through a list. Now that your iterator is finished, you can use it in your linked list. Replace an unimplemented iterator, getter that you added earlier to linked list with the following. Override iterator, get iterator, linked list iterator, this. Now you are ready to see if it works. Return the same code that you unsuccessfully tried earlier. In list, print element. This time it works. It prints out the following values as expected, 1, 2, 3. We talked about stacks, linked lists. We move to queues. Everyone is familiar with waiting in line. Whether you are in line to buy tickets to your favorite movie or waiting for a big renter to print a file. These real-life scenarios mimic the queue data structure. Queues, as we talked before, use FIFO, first in, first out ordering, meaning the first element that was added will always be the first to be removed. Queues are handy when you need to maintain the order at class queue, in queue element, the queue element, get is empty, get beak. There are meaning of the core operations in queue. Insert an element at the back of the queue. Return true if the operation was successful. The queue remove the element at the front of the queue and return it. Is empty, check if the queue is empty. Beak, return the element at the front of the queue without removing it. List-based implementation. List, doubly linked list, string buffer to stacks. That core library comes with a set of highly optimized data structures that you can use to build higher level abstraction. One of them that you are already familiar with the list, the data structure that stores a contiguous ordered collection of elements in this section. You will use a list to create a queue. Front, back, but that list can be used to model the queue. In QVK is empty equal false. The queue array in the front. Class queue list E implements queue. Final list E overriding queue through an implemented error. The queue is empty beak. Leveraging lists. Replace leveraging lists. Place is empty and beak in your queue list. The following is empty, list is empty, beak is empty, return null, else return list first. Using features of list, you get the following for free. Check if the queue is empty, return the element at the front of the queue, or null if the queue is empty. These operations are empty. These operations are both O1 notation. Now in queue. In queuing an element at the back of the queue is easy. Just add an element to be list. Replace in queue with the following. Override boolean in queue element. Take element E. List add element return true. In queuing an element is on average an O1 operation. This is because the list has empty space as the block. Front back. In the example, notice that once you add Mike, the list has 2 empty spaces. What about full list spaces? The list has 2 empty spaces. What about full list spaces? In query, list is full. If list is full, you need to optimize list length. This is in queue. The queue. What about the queue? The queue, removing an item from the front requires a bit more work. Replace the queue with the following. The queue is empty. Return null, else return list, remove at 0. If the queue is empty, the queue simply returns null. If not, it removes the element from the front of the list and returns it. This is first step. Remove the element from the beginning of the list is always linear time operation because it requires all the remaining elements in it. This is first step. Remove the element from the beginning of the list is always linear time operation because it requires all the remaining elements in the list to be shifted in memory. Queues, testing the list-based implementation. Add a new method to override toString queue list so that you can see the result of your operation. toString list toString. final Q, Q list string, Q in Q Ray, in Q Brian, in Q Eric, print Q, DQ, print Q, Q big, print Q. We find Ray Brian Eric, Brian Eric. If we make DQ, if we make big, Brian Eric, Ray Brian Eric, Brian Eric. If we make DQ, if we make big, Brian Eric. Board package Q. What about performance of Q? Here is summary of algorithmic complexity. In Q, the Q space complexity. Average case, worst case. In NQ, average case O1, worst case ON. The Q, average and worst case ON. Space complexity, average case and worst case is ON. List-based Q. There are many other of list-based Q ways. Doubly linked list. We import a package. Doubly linked list ways. Doubly linked list. We import a package. Doubly linked list in Q. The Q is empty weak. In Q, override list append element, return true. In Q, hit next, previous, tail, and in Q, DQ. DQ and doubly linked list. To remove an element from the queue, replace the queue with the following list Bob. Bob does exactly what you want to the queue to do, so you can use it directly. Removing from the front of the linked list is also an O1 operation compared to the list implementation. You don't have to shift elements one by one. Instead, as shown in the diagram below, checking the state of queue, similar to the list implements, can implement weak and is empty using the properties of doubly linked list. Replace is empty and weak with the following: is empty, list is empty, weak list head value. Testing and performance of doubly linked list based queue. Override to string, list to string, Q, Q linked list, string, Q in Q, Ray Brian Eric, print Q, DQ, print Q Brian Eric, beak, print Q Brian. Run the code and we will see the result Q list implementation. Performance, what about it? Operation, average case, worst case. Include the Q space complexity. Include O1, O1 in average and worst case. The Q O1, O1. Space complexity ON, ON. There are another way to build Q rather than list and doubly linked list. We have ring buffer implementation. Ring buffer, also known as synchronal buffer, circular buffer, is a fixed size list. This data structure statically wraps around to the beginning when there are no more items to remove at the end. Example, to follow the example, how Q can be implemented using ring buffer. First item, read and write. You first create a ring buffer that has a fixed size of 4. The ring buffer has 2 pointers that keep track of 2 of the queue. The right pointer keeps track of the next available slot so that you can overwrite existing elements that have already been read. Chris, read write. Chris, Pablo, Manda, read write. Chris, Pablo, Manda, read write. Chris, Pablo, Manda, Vicky. First we have value, read, write in front end. Here we have values, last item. Here if we have value, print, wiki. If list is full, return back to the first item, read write. Import ring buffer, implements queue, ring buffer, integer length, ring buffer equal ring buffer. If buffer is full, return false, else ring buffer write element, return true. To append an element to the queue, you simply call write on the write buffer. This increments the write pointer by 1. Since the queue has a fixed size, you must now return true or false to indicate whether the element has been successfully added in queue. Is still an O1 operation. The queue. Next, replace the queue with the queue ring buffer read. To remove an item from the front of the queue, you simply call read on ring buffer. Behind the scenes, it checks if the ring buffer is empty, and if so, returns null. If not, it returns the item at the read index of buffer and then increments the string buffer. And what about performance? Override to string. We have the same results. What about performance? Performance operations, average case, worst case. We have include queue space complexity. In queue, average case and worst case on 1. The queue average case and worst case is also 1, and big and space complexity in average case and worst case is ON. We have list, doubly linked list, and buffer. And ring buffer implementation of queue. We have another way is double stack implementation. Double stack implementation, generic queue stack to queue, implementation of queue. We have another way is double stack implementation. Double stack implementation, generic queue stack to queue, as shown below. Left stack, right stack, the queue and in queue. We put items in right stack 1 to 3 and reverse it in left stack 3 to 1. The queue, first item 1. If we need to dequeue from left stack, if we need to enqueue from right stack. As illustrated in this shape, leveraging lists, implement is empty, left stack is empty, and right stack is empty. Beak, how to find beak, stack is empty. Beak, how to find beak, left stack is not empty, left stack last. Right stack other, right stack first. In queue elements, right stack add element. Return to. Recall that the right stack is used to queue elements. Simply push the stack appended to the list from implementing the queue previously. You know that appending an element is an O1 problem, as we took it in stack data structure. Dequeue, another operation. Dequeue if left stack is empty, left stack add all, right stack reverse it. Another operation. Dequeue if left stack is empty, left stack add all, right stack reverse it, right stack clear. Then if left stack is empty, return null, else return left stack remove last. This is the queue operation. The following explanation: numbers, if left stack is empty, set it as reversed of the right stack, reverse it to left stack. Second, invalidate your right stack since you have transferred everything to left, just clear the right. Remove the last item element from the left stack if it is not empty. To left, just clear the right. Remove the last item element from the left stack if it is not empty. Testing double stack based implementation and performance. What about it? To implement toString, override string to string, final combine it, left stack reversed, right stack, join, combine it, return combine it. Here simply the same results we find. What about performance? Two stack based, double stack based queue. We have include queue, space complexity, average case and worst case for space complexity, average case and worst case for in queue, O1, ON, average case and worst case to the queue, O1, ON, and space complexity to average case and worst case is ON. Compare the two images below. A list has its data stored contiguously in memory, 1, 2, 3, 4, 5, 6. Another is maybe cache, missing cache, or in memory missing. We have 1, 2, 3, 4, 5, 6, doubly linked list. The data for a linked list, on the other hand, could be all over the place. This non-locality could lead to more cache misses, which will increase access time. This is stack main data structures in Dart language. List, map, set. We talked about complexity and some introduction. Now we move to trees. Binary trees, binary search trees, AVL trees, tries, binary search, heaps, priority queues. We return back. We talked about some introduction about data structure and algorithm in Dart. Next, we talked about complexity, what is importance about complexity, about basic data structure in Dart programming language, list, map, and set. Then we talked about stacks, linked lists, and queue. Is the data structure of profound importance. It's used to tackle many recurring challenges in software development, such as representing hierarchical relationship, managing sorted data, facilitating fast lookups operations. A tree, such as this. Terminology. Many terms are associated with trees, and there are some you should know right off the bat. There are nodes, like the linked list. Trees are made up of nodes. Each node can carry some data and keeps track of its children. Then we have children and parent in trees. Parent and child. Trees are viewed bottom, just like real tree will look exactly the opposite of real tree. Every node except for the topmost one is connected to exactly one node above it. That node is called parent node. The nodes connected directly below a parent are called child nodes. In a tree, every child has exactly one parent. That's what makes a tree a tree. Parent, children. We have root in tree. The topmost node in the tree is called root of the tree. It is the only node that has no parent. And we have leaf. A node is a algorithm. Tree node, this value, the value list, node, children. Void add tree node, child, children add child. Import tree, beverage tree node, beverage. Hot tree node, hot. Cold tree node, cold. Beverage add hot, cold. We have found beverage, hot and cold. Traversal algorithm, iterating through linear collection, such as list or linked list, is straightforward. Linear collection have a clear start and end. Iterating through trees is a bit more complicated. Start, end, maybe start equal null, maybe end equal null. Depth first traversal, for each depth first. Void function tree node, and this for final child and children, child for each depth first, perform action. We find the tree node, make beverage tree node, beverage hot, cold tree, coffee, coca, cacao, black, green, chai, soda, milk, ginger ale, bitter lemon. Tree add hot, cold. Hot add tea, coffee, chocolate. Cold add soda, milk. Tea add black tea, green tea, chai tea. Soda add ginger ale, bitter lemon. Then we find the tree as this illustration. Beverages, cold, hot. Cold we find milk, soda, bitter lemon, ginger ale. Hot we find cacao, chocolate, coffee, tea. Beverages, cold, hot. Cold we find milk, soda, bitter lemon, ginger ale. Hot we find cacao, chocolate, coffee, tea, chai, green, black. Tree make beverage tree for each depth first node, print node value. We find this. We have level order traversal in trees. A tree can be divided into levels based on the distance of the node from the root. The root itself is level 0. Nodes that are direct children of the root are level 1. The children of these children are level 2, and on it goes. Here what that looks like in image 4. Level 0 at the root, level 1, level 2, level 3. And on it goes. Here what that looks like in image 4. Level 0 at the root, level 1, level 2, level 3. Import queue for each level order, function, perform action. Final queue stack, perform action list, children for each queue, and queue, var node queue the queue, while node not equal null, perform action node not children for each queue and queue, node queue the queue. Final tree, make beverage tree for each level, order node, print node value. Then we have the result as this. Search, what about searching tree? You already have two methods that iterate the result as this. Search, what about searching tree? You already have two methods that iterate through all the nodes. So building a search algorithm should not take long. Relatively long bottom tree node. tree node result for each level order. If node value equal value, return node, else return result. Iterate through each node and check if its value is the same as what you are searching for. If so, you return it as the result, but returns null if not. Head back to main to test the code. Replace the function body with the following: final tree, make beverage tree. Head back to main to test the code. Replace the function body with the following: final tree, make beverage tree. Final search result 1. Tree search generally. Print search result value generally. Final research result 2, search water, value equal null. We will talk about binary trees. We look at the base tree where each node can have many children. Binary tree, a tree where each has most 2 children, right or left. Often referred to left and right children. Parent, right children, left children. Binary, from its name, binary 2 children. Implementation binary node value. Left create binary tree 0 binary node 0 1 5 7 8 9. 7 left child 1. As the result, this illustrate 7 right children 1, 1 right children 0, 1 right child 5, 7 right child 9, 9 left child 8. Building diagram. Override to string, return diagram this. Diagram node top root bottom. If node equal null, return root null. If node left child equal null and node right child equal null, return root node value. Else return a diagram node right child to 3 7 9 8 5 1 0 null. Final C diagram node left child bottom, bottom down row right row, bottom return ABC. The result will be as this tree. Traversal algorithm. Previously you looked at a level order traversal of a tree. With a few tweaks, you could make that algorithm work for binary trees as well. However, instead of re-implementation, level order traversal, you look at 3 traversal algorithm for binary trees in order pre-order node. If current node has left child, recursively visit the child first, then visit the node itself. If the current node has right child, recursively visit the child. Here is what an in-order traversal looks like for your example tree. 0 1 5 7 8 9. Traversal in order, void function t value, action, left child. Traversal in order, action value, right child, traversal in order, action. 3. Create binary tree. 3. Traversal in order, print. We have this value, we have this result. Another way is pre-order traversal. Pre-order traversal always visit the current node first, then the result is 7 1 0 5 8 9 9 8. First current value, then left and right. Current value, left and right. Current value, left, done, right. Current value, left and right. Traversal pre-order action, left child, traversal pre-order action, right child, traversal pre-order action. Then the result will be 710598. Post order, another way. Post order traversal only visit the current node after the left and right child have been visited recursively. Post order traversal in order traversal. Post order traversal, left and child traverse post order. The result will be 051897. Comparison, list comparison between this. Take a moment to review the difference between those traversal algorithms. Left child traversal in order action, right child traversal in order. Traverse pre-order, another way, action, left child traverse pre-order, right child traverse pre-order. Another way, traverse post order, left child, right child, then lastly action. Here action between left and right. Here action before, here action after. The method contains child, then lastly action. Here action between left and right. Here action before, here action after. The method contains some lines of code but executes them in varying order. The list below summarizes that order. Traverse in order, left action right. Traverse pre-order, action left right. Traverse post order, left right action. The difference is only where the action takes place. Each one of these traversal algorithms has a time and space complexity of O(n). This is binary trees. Now we move to binary search trees. Binary search tree (BST) is a data structure that facilitates fast lookup, insert, and removal operations. Consider the following decision tree where picking a side forfeits. This is binary trees. Now we move to binary search trees. Binary search tree (BST) is a data structure that facilitates fast lookup, insert, and removal operations. Consider the following decision tree where picking a side forfeits all the possibilities of the other side, cutting the problem in half. Should I go to the gym? Did I go yesterday? Yes or no? No. Did I go jogging yesterday? Yes or no? No, I am still feeling sore. Yes or no? No, go to the gym. Yes, rest for the day. Did I go jogging yesterday? Yes. Did I run 5 kilometers? Yes or no? No, go to the gym. Yes, go to sleep. Another. Did I run 5 kilometers? Yes or no? No, go to the gym. Yes, go to sleep. Another. Did I go yesterday? Yes. Did you slack off in the last session? No break. Yes. Go to the gym. Once you make a decision and choose a branch, there is no looking back. You keep going until you make a final decision. At the leaf node, binary trees let you do the same thing, especially a binary search tree imposes two rules on the binary tree you saw in the previous chapter. The value of a left child must be less than the value in its parent. Consequently, the value of right child must be greater than or equal the value of its parent. Binary search trees use these properties to save you from performing unnecessary checking. Versus BST, binary search tree. To illustrate the power of using BST, you will look at some common operations and compare the performance of list against the binary search tree. Consider the following two collections, list and binary search tree. One for 18, 20, 25, 40, 45, 70, 77, 88, 105. Then binary search tree, 40, left 18, left 1, right 20, right 4, right 25, 77, left 70, right 105, 70, left hand 45, 105, left hand 88. Look up, there is only one. Not the case for binary search tree. Binary search tree 105, bigger or less than 40, bigger, go right. 77, bigger or less than 105, less than, go right. 105, equal node, yes, then stop. Every time the search algorithm visits the node in binary search tree, it can safely make these two assumptions. It must be the left subtree. If search value greater than the current value, it must be the right subtree. By leveraging the rules of the BST, you can avoid unnecessary checks and cut the search space in half every time you make a decision. That's why element lookup in BST and insertion, the performance benefits for the insertion operation follow a similar story. Assume you want to insert 0 into a collection. Inserting at the front of the list causes all other elements to shift backwards by one position. It's like putting in line. Everyone in the line behind your chosen spot needs to make space for you by shuffling back. Inserting 0 in sorted order. But in binary search tree, 41 greater than or less than 40, less than left. (18) compared to 1, less than or greater than, go left. Move an element in a list also triggers a shuffling of elements. Remove 25. Remove and shuffling all elements right of 25 to left. But in binary search tree, 25 bigger or less than 40, less, go left. 18 compared to 25, go right. 20 compared to 25, go right. Then remove 25. We don't need to shift any item. Nice and easy. There are complications to manage when node you are moving as children, but you are looking to that later even with choose complication. Moving an element from BST is still in all look-in operation. Choose complication. Moving an element from BST is still in all look-in operation. Implementation, how to implement. Import binary node, binary search tree comparable, dynamic, binary root, toString, root to string. Insertion element, adding an insert method. Insert element value, root, insert at root value. Binary node, insert at binary node value. If node equal null, return binary node value. If value compared to node value less than 0, node left child, insert at node left child value. Else, node right child, insert at node right child value. Other way, return node. Testing it out, import package compared to node value less than 0, node left child, insert at node left child value. Else, node right child, insert at node right child value. Other way, return node. Testing it out, import package, binary search tree, void main tree binary search tree for var I equals 0, I less than 5, I plus plus, tree insert I, then print tree. We find the result as this 5, 4, 3, 2, 1, 0, null, null, null. Balanced versus unbalanced trees. Here is unbalanced 0, 1, 2, 3, 4, unbalanced. Here balanced 3, 4, 1, 1, 2, 0. Here unbalanced, here balanced. Balanced versus unbalanced trees. Here is unbalanced 0, 1, 2, 3, 4, unbalanced. Here balanced 3, 4, 1, 1, 2, 0. Here unbalanced, here balanced. If we moved from 0 to 4, we move 1, 2, 3, 4 times, but unbalanced 1 times. Building balanced tree, add the following function below main, binary search tree, building example tree, 3 binary search tree, 3 insert 3, 1, 4, 0, 2, 5. To traverse through its node, it's possible to come up with relatively simple implementation by using the existing traversal mechanism that you learned about in the previous chapter. Add the following method to binary search tree. Contains a value, if root equal null, return false, far found equal false, root traverse in order other, if value equal other, found equal true, else return found. Next, head back to main to test this out. While a tree build example tree, if tree contains 5, print found 5, else print could not find 5. Contains. Relying on the properties of BST binary search tree can help you avoid needless comparisons. Back in binary search tree, replace contains with the following. Contains current equal root, current not equal null, current value equal value, return true, if value compared to current value less than 0 equal, then current equal current left child, else current right child. Removing element. Removing element is a little more tricky because you need to handle a few different scenarios. Removing leaf node. Removing elements. Remove elements is a little more tricky because you need to handle a few different scenarios. Removing a leaf node. Remove a leaf node is straightforward, simply remove a leaf node is straightforward, simply detach the leaf node. 3, 1, 2, removing 2. Removing nodes with one child. When removing nodes with one child, you will need to reconnect that child with the rest of the tree. Then link 3 with 5. Remove 4, then link 3 with 5. As linked list. Removing nodes with 2 children. Here is the shown nodes with 2 children are a bit more complicated. So a more complex example tree will better illustrate how to handle this situation. Assume that you have the following tree and that you want to remove that value of 25. Remove 25, then 50, 73, 20, or 12, or 12. Link 50 with these values. Now we move to replace 25 with 70, 27. If we move 27 to here, remove 27 from down, this is the result. Good resolution, good result. Now 27 in this location, finding the minimum node in the subtree. Minimum finder on binary extension. We make extension to understand extension. Min finder on binary node. When we get minimum left child minimum this. This will help you find the minimum node in subtree. Implementing remove. Now add two methods to binary search tree. Remove element, remove root value. Binary node E, remove binary node E, node E value. If node equal null, return null. If value equal node value, more to come. Next, else if value compared to node value less than 0, node left child remove node left child value. Else remove node right child value, other return node. Handling the remover cases, replace equal null and node right child equal null, return null. Second, if node left child equal null, return node right child. If node right child equal null, return node left child. Third, node value equal node right child min value. Node right child equal remove node right child node value. If node is a leaf node, you simply return null therapy, removing the current node. If node has no left child, you return node right child to reconnect the right subtree. If the node has no right child, you return node left child to reconnect the left. This is the case in which the node to be removed as both left and right child. Replace the node value with smallest value from left and right child. Replace the node value with smallest value from the right subtree. You can call remove on the right child to remove this swapped value. To test binary search tree, head back to main and test remove by running following. Find a tree built example tree. Bring a tree before removal. 3, remove 3. 3 after removing root 3. We find the result as this: 5, 4, 3, 2, 1, 0. Null. If we remove 4, if we remove 3, we find 4 here. 4, 5, 2, 1, 0. We talked about binary trees, binary search trees. We move to AVL trees. What is perfect balance? The ideal form of binary search trees is the perfectly balanced state. In technical terms, this means we talked about binary trees, binary search trees. We move to AVL trees. What is perfect balance? The ideal form of binary search trees is the perfectly balanced state. In technical terms, this means every level of the tree is filled with the nodes from top to bottom. Perfectly balanced trees. Not only is the tree perfect symmetrically, the nodes at the bottom level are completely filled. Is the requirements for being perfectly balanced. Good enough balance. Good enough balance is, although achieved perfectly balanced is ideal, it is really possible. A perfectly balanced tree must contain the exact number of nodes to fill every level to the bottom, so it can only be perfect with a particular number of elements. Good enough balance is, although achieved perfectly balanced is ideal, it is really possible. A perfectly balanced tree must contain the exact number of nodes to fill every level to the bottom, so it can only be perfect with a particular number of elements. For example, 3 with 1, 3, or 7 nodes can be perfectly balanced, but a 3 with 2, 4, 5, 6 cannot be perfectly balanced since the last level of the tree will not be filled. Unbalanced, this is unbalanced. Finally, there is the unbalanced state. Binary search trees in this state suffer from various levels of performance loss depending on the degree of imbalance. Binary search trees in this state suffer from various levels of performance loss depending on the degree of imbalance. Unbalanced trees. Keeping the tree balanced gives the find, insert, and remove operations an O-log in time complexity. FL trees maintain balance by adjusting the structure of the tree. When the tree becomes unbalanced, you will learn how to work as you post degrees through the measuring the balance. To keep a binary tree balanced, you will need a way to measure the balance of tree. The evil tree achieves this with a high property in each node. In tree speak, the high of node is the longest leaf node. 3, 2, 0, 1, 0, 0. Node markers with high. Balance left, high right. 50, 1, balance, high 1. 25, minus 1, balance, 1, high. 37, 0. 75, 0, 0. So I will 3 with balance factors and high. Another 3, 50, 2, unbalanced 3, 2, 3, 0, 0, minus 1, right high, right high, right child high, if not exist, minus 1. Right high, left high, balance factor is left high minus right high. Left high minus right high. 2 minus 2. Rotations. Two producers use it to balance a binary search. 3 are known as rotations. There are 4 rotations in total. 1 for each of the 4 different ways that a tree can be unbalanced. These are known as left rotation, left-right rotation, right rotation, and right-left rotation. Left rotation to imbalance caused by insertion 40 in rotation after rotation. So import Dart math as math, add the following left rotate, AVL node, pivot node right child, node right child, pivot left child, pivot left child equal node. Node high equal 1 plus math max, node left high, right high, pivot high equal 1 plus math max, pivot left high, right high. Then return pivot. 2, 52, 25, minus 2, 75, 0, 37, minus 1, 40, 0. Before left rotate of on left rotation. Right rotation, the same idea. Right rotation is symmetric composite of left rotation when a series of left children is causing an imbalance. it's time for right rotation. Generic right rotation of node X look like this. X, Y, D, C, Z, A, B for right rotation. After Y, X, C, D, Z, A, B. Right rotate, AVL, node final pivot, node left child, node left child, pivot right child, pivot right child equal node high equal 1 plus math max node left high, node right hand, node right high, pivot high, right high, pivot high equal 1 plus math max pivot left high, pivot right high. Then return pivot. What about right left rotation? You may have noticed that the left and right rotation balance nodes that are all left children or all right children. Consider the case in which 36 is inserted into the original example tree. The tree now requires a right left rotation. Now before rotations 0, 1, minus 2, 2, 0. Right rotate on 73, then left rotate 2, 2, 0. Right rotate on 73, then left rotate on 25. It's right left rotation. Right left rotation, if right child equal null, return node right child, right rotation node right child, return left rotate node. We have left right rotation, we have right rotation, left rotation, right left rotation, left right rotation. Left right rotation is the symmetrical opposite of the right left rotation. Here is an example: 15 with 10, then 15 with 25, with 10, then 15 with 25, left rotate, then right rotate. Even node left right rotate, if node left child equal null, return null. Node left child left rotate, node left child, return right rotate node. What about balance? The next task is design method that uses balance factor. Balanced, switch node balanced factor, case 2, case minus 2, default return node. The sign of child balance factor can be used to determine if a single or double rotation is required. Balance factor can be used to determine if a single or double rotation is required. AVL balanced, AVL node, switch node balanced factor, case 2, left, final left node, left child, if left not equal null, and left balanced factor is equal minus 1, return left right rotate node, else return right rotate node. Case minus 2, right node right child, if right not equal null and right balanced factor equal 1, return right left rotate node, else return left rotate node, default return node. You have already done the return right left rotate node, else return left rotate node, default return node. You have already done the majority of the work. To remain fairly straightforward, replace insert at with the following. Insert at AVL node element node and element value. If node equal null, return AVL node value. If value compared to node value less than 0. Node left child equal insert at node left child value. Else node right child insert at node right child value. Final balanced node high equal 1 plus max balanced node left high balanced high. Then return balanced node. Import AVL 3 AVL 3 figures or var I equals 0 I less than 25 I plus 3 insert I print 3. Here 7 0 1 2 3 4 5 6 8 9 10 11 12 13 14. What about revisiting remove? Retrofitting the remove operation for self-balanced is just as easy as fixed insert. Enable 3 find, remove, and replace the final return node statement with the following: balanced high, balanced node. 3 avail 3 of integer, insert 15, 10, 16, 18, print 3, remove 10, print 3. Then if we remove 10, the result as this. This is AVL trees. We talked about binary trees, binary search trees, AVL trees. Now we move to tries. Tries, pronounced try, is a tree that specializes in storing data that can be represented as a collection, such as English words. Root, A-T-C-O-U-A-T-T-E. Try containing the words cat, cute, to, and a. Prefix, return words where word, return words starts with prefix to list. Imagine the number of words Google needs to parse. This is example of try. Here is the root. C, cute, cat, to, a. Go, there, dart, cat, cute, to, ads, zoo. What about implementation of try? Try node. You will begin by creating node for try. Class try node of t. Try node, this key, this parent. 1 t key. 2 try node t parent. The key holds the data for the node. This is nullable because the root node is the try has no key. In a map of key value pairs to store children nodes. Try node holds a reference to its parent. This reference simplifies the remove methods later on. In binary search trees, nodes have a left and right child. In a try, a node needs to hold multiple different elements. The children map accomplishes that. Fourth is terminating as a marker for the end of the collection. Follow points to note. In Dart, string is collection of UTF 16 code units. So that's why the type for try node is integer rather than string. The key and parent of a tries root node are always null. Next, you implement four operations for try, insert, contains, remove, and match prefix. Insert try works in collection internally, so you will need to take whatever string inserted and convert it code units into tries node case. Add the following methods: string try insert, current root, second for loop var code unit in text code units, current children code unit. If the following methods: string try insert, current root, second for loop var code unit in text code units, current children code unit. If exist, if not, try node, key code unit parent current. Current equal current dot children code unit. Third, current is terminating equal to. What about contain? Contains is very similar to insert. Add the following method to string try. Contains string text var current root, for loop code unit in text code unit, final child current children code unit. If child equal null, var current root, for loop code unit in text code unit, final child current children code unit. If child equal null, return false, else current equal child. Then current is terminating. Then import package string try, main try, string try, insert quote, insert. If try contains a quote, quote is in the try. Run that code and the following quote is in the try. What about remove? Insert contains, then remove function, take string text, define current equal root, for loop code unit in text code unit, root, for loop code unit in text code units, child current children code unit. If child equal null, return, else current equal child. If not current is terminating, return. Second, current is terminating equal false. 3 or third, while current parent not equal null, current children is empty, and not current is terminating. Current parent children, current key equal null, current equal current parent. Let's try. String try, insert quote, cut to quote, cut and quote. Assert try contains cut, try remove cut. Assert try contains cut, not contains cut. Assert try contains quote. Print quote is still in the try. Run and the result as this: quote cut is in the try, quote in the try, remove and cut, quote is still in the try. What about prefix matching? The most iconic algorithm for a try is the prefix matching algorithm. Write the following: match prefix, current equal root, for loop, second return more matches prefix current. What is function of more matches? Takes two parameters, string prefix, try node of integer node, child in node, children values, final code units equal child key, results at all more matches, prefix string from character code, code unit, child, return results. If we test this code, try equal string try insert car, card, care, carried, cars, carbs, car base, cargo, print collection starting with car, prefix with car, try match prefix car, prefixed with car, print collection starting with care, then print collection starts with car, car, card, care, carried, cars, car base, cargo, collection starts with care, then print collection starts with car, card, care, carried, cars, car base, cargo, collection starts with care, the result is care, carried. This is a try. We talked about binary trees, binary search trees, evil trees, and tries. Now we move to binary search. What is binary search? Binary search is one of the most efficient searching algorithms with a time complexity of O log n. You have already implemented in binary search once using binary search tree. We implement binary search on a sorted list. Two conditions need to be met for the type of binary search tree. We implement binary search on a sorted list. Two conditions need to be met for the type of binary search that describe it. The collection must be sorted. The underlying collection must be able to perform random index lookup in constant time. As long as elements are sorted, the artlist meets both of these requirements. Step 1, find the middle index. Step 2, check the element at the middle index. Step 3, recursively call binary search. Left and right, the same idea. Search versus binary search. Linear search, we move multi times until find the value, but in binary search, less than login or login, less than linear search time exclusion. Implementation adding extension on list, sorted list, comparable dynamic on list, integer binary search, evalue integer start, integer end, testing it out, import binary search, list for example, end index, end or length, start index second, start index greater than or equal end index, return null, third, file size equal end index minus start index, middle start index plus size division by 2, index, integer, return value, if this middle equal value, return middle, 5 else return value compared to this middle less than 0, return binary search value start index middle, else return binary search value middle plus 1 end index. This is binary search. Another tree is heaps. Heaps are another classical tree based data structures with special properties to quickly fetch the element. What is a heap? A heap is complete binary tree, also known as binary heap. that can be constructed using a list. Don't confuse these heaps with memory heaps. The term heap is sometimes confusing used in computer science to refer to pool of memory, leak of memory. Memory heaps are different concepts and not what you are studying here. Heaps come in two flavors: max heap, minimum heaps. Max heap, in which element with a higher value have a higher priority. Min heap is which element with a lower value have a higher priority. The heap priority property, heap has essential characteristic that must always specify this. Characteristic is known as heap property. The lower value have a higher priority. The heap priority property, heap has essential characteristic that must always specify this. Characteristic is known as heap property. Look at this example. Max heap, here min heap. Note that unlike binary search tree, it's not requirement for the heap property that the left or right child needs to be greater. For that reason, a heap is only partially sorted tree. The shape property, another essential aspect of heap, is a shape property. A heap must be complete binary tree. Heap is a shape property. A heap must be complete binary tree. This means that every level must be filled except for the last level. Additionally, when adding elements to the last level, you must add them from left to right. In the diagram below, you can see the first two levels are filled. The last level, level 3, is not full yet. But the nodes that are located on the left. Heap applications. Some practical applications of a heap include calculating the minimum or maximum limit of collection, implementing the heap sort algorithm, constructing a priority queue, building graph algorithm that use a priority algorithm, fitting binary tree into a list. Look at this: 0, 1, 2, 3, 4, 5, 6, 7. Level 1, level 2, level 3, level 4. Accessing nodes. The left child of this node at the index 2i plus 1. The right child of this index is at index 2i plus 2. Look at this example. The parent of this node is index I minus 1 multiply 2. Implementation: adding constructor, element, final priority. Providing basic properties is empty, size, peak. Size elements length, peak is empty, null, or elements first. Calling peak will give you the maximum value in the collection for max heap, or the minimum value of the collection for minimum. This is one operation. Preparing helper methods. Any complex task can be broken down into similar steps. In this section, you will add few private helpers methods to make the node manipulation you will perform later a lot of easier. Left child index, integer parent index plus 2, integer parent index, integer child index, return child index minus 1, multiply 2. Selecting a priority. First hash has high priority. Return value compared to value. High priority integer index A, integer index B. Then if index A greater than elements length, return index B. Final value A, elements index A, value B, elements index B is first. First has higher priority, value A, value B. Return is first, index A or index B. Swapping values, then we make swapping values. Swap values, index A, index B. Temp, elements index A, elements index B. Inserting into a heap. The same idea. We start with the max heap shown in the image below. 8, 6, 4, 3, 2, 5, 1. Then replace with 6. Then replace with 8. 8 is bigger. Stop at this point. Implementing insert. Add value. Elements add value. Shift up elements length -1. Shift up integer index, child index, parent index, child. While child bigger than 0 and child equal higher priority, child parent. Swap values, child parent heap. Heap insert 7, print heap. The result as this. Removing from heap. Another important process. Basic remove operation removes the root node from the heap. For example, this 10, 3. Compare 3 with 10. Remove 10. 3 with 8. Remove 10. Then replace with 8. Then replace with 6. Then stop. Inverse of shift up is shift down. The same idea. While 2 left child index parent, right child index parent with 8. Remove 10. Then replace with 8. Then replace with 6. Then stop. Inverse of shift up is shift down. The same idea. While 2 left child index parent, right child index parent. Chosen higher priority left parent. Chosen higher priority right chosen. Chosen parent, return, swap value parent, parent chosen. Implementing remove. Element remove is empty, return null. Swap values, element length -1. Final value elements remove last, shift down, return value. Testing remove. Then heap remove. Print root heap the value right child index parent. Chosen higher priority left parent. Chosen higher priority right chosen. Chosen parent, return, swap value parent, parent chosen. Implementing remove. Element remove is empty, return null. Swap values, element length -1. Final value elements remove last, shift down, return value. Testing remove. Then heap remove. Print root heap. The value is this 10. Removing from arbitrary index. Add the following method to heap. Remove at last index elements length -1. If index less than 0 or index greater than last index, return null. Second, if index greater than last index, return last. Third, elements length -1. Final value parent, parent chosen. Implementing remove. Element remove is empty, return null. Swap values, element length -1. Final value elements remove last, shift down, return value. Testing remove. Then heap remove. Print root heap. The value is this 10. Removing from arbitrary index. Add the following method to heap. Remove at last index elements length -1. If index less than 0 or index greater than last index, return null. Second, if index equal last index, return elements remove last. Third, elements length -1. If index less than 0 or index greater than last index, return null. Second, if index equal last index, return elements, remove last. Third, swap values index, last index. Final value elements, remove last. Fourth step, shift down index, shift up index, return value. This is example 5.8. Remove 5. Then 8 with 7. Place. Shifting up case, shifting down case. Then remove 7 with 1, 1, 5, 10. And the result 10, 5. Find result as this. Searching for an element in heap. Index of value integer index equal 0. Index greater than or equal elements length. Return -1. If first has higher priority value elements index, return -1. If value elements index, return index. Final left index value index, left child index. If left not equal -1, return left. Return index of value index, right child index. Testing it out. Final heap integer, heap insert 107251 heap, print heap, final index heap index of 7, print index is 1. Equal property max, priority max. This element equal null. List all elements. Build heap. What is build heap function? Build heap is empty, return null, return. Final start equal elements length multiply by 2 minus 1. For I equal start I greater than or equal 0. I minus shift down I. Testing it out. Heap equal heap elements. For example, list 1, 12, 3, 4, 1, 6, 8, 7. Print heap. While not heap is empty, print heap, remove. We find this heap 12 list priority minimum. Then the value is this, verse of this. What about data structure, heap data structure, operations, time complexity? We have remove, insert, search, pick, operation and time complexity. Remove, log in. Insert the same, log in or log in. We go notation log in. Search on, but pick O1. Queues are simply lists that maintain the order of elements using first in, first out, FIFO ordering. Priority queue is another version of queue in which elements are queued in priority order in which the element at the front is always the largest, in which the element at the front is always the smallest, minimum, max, priority. Applications of priority. Now we talked about binary trees, binary search trees, AVL trees, tries, binary search heaps, in trees. Now we move to priority queues. What applications of priority queues? Some practical applications of priority queues include gesture algorithm, a pathfinding algorithm, heap sort, Huffman coding, and any other. Gesture algorithm, which uses the priority queue to calculate the minimum cost. Pathfinding algorithm, which uses the priority queue to track and explore routes that will Heap sort, which can be implemented using a priority queue. Huffman coding that builds a compression tree. A main priority queue is used repeatedly. Find two nodes with the smallest frequency that do not yet have a parent node. Huffman code using in images compression, for example, GPG, GIF, PNG, any other, and video compression, H2064 and 65, MPH, MP4, another multi-uses of Huffman coding algorithm. These are just some of the use cases, but priority queues have many more applications as well. Common operations. Queues. In queues, establish the following interface for queues. In queue, the queue is empty peak. Priority queues has same operations as a regular queue, so only the implementation will differ. In queue, inserts an element into the queue and returns 2 if the operation was successful. The queue removes an element, the element with the highest priority, and returns it. Returns null if the queue was empty. Is empty checks if the queue is empty. Makes return the element with the highest priority without removing it. Returns null if the queue was empty. Implementation. You can create priority queue in the following ways: sorted list, balanced binary search tree, heap. Sorted list, this is useful to obtain the maximum or minimum value an element in O1 type. However, insertion is slow and will require ON. Time, since you have to first search for the insertion location and then shift every element after that location. Balanced binary search tree, this is useful in creating a double-ended priority queue, which features getting both the minimum and maximum value in O. Time, insertion is better than sorted list, also O. Heap, another way to implement priority queues. Heap, this is a natural choice for a priority queue. A heap is more efficient than a sorted list because a heap only needs to be partially sorted. Inserting and removing from a heap are O while simply querying the highest priority queue. A heap is more efficient than a sorted list because a heap only needs to be partially sorted. Inserting and removing from a heap are O while simply querying the highest priority value is O1. Import heap and queue. 1. Export heap, show priority. Second, class priority queue extends comparable dynamic implements queue. Priority queue lists elements, priority max. Third, heap elements, priority, late heap. Implementing the queue interface is empty, heap is empty, peak is empty, heap is empty, heap peak. First in queue, heap insert element, late heap. Implementing the queue interface is empty, heap is empty, peak is empty, heap is empty, heap peak. First in queue, heap insert element, return to the queue override the queue heap remove. Testing out priority queue elements 1, 12, for example 3, 4, 1, 6, 8, 7. While priority queue is empty, not empty, print priority queue the queue. This is the result: 12, 8, 7, 6, 4, 3, 1, 1. This is trees with main, list, set, map, and we talk about stack, linked list, in queues. Then we move it to trees. Trees, binary search trees, evil trees, tries, binary search heaps, priority queues. Now we move to sorting algorithms, ON square, merge sort, radix sort, heap sort, quick sort. Now we're talking about data structures in details. Now we move to algorithms, sorting algorithms. ON square, merge sort, radix sort, heap sort, and quick sort. What is ON square? The target of these algorithms is that they have constant open space complexity, making them attractive for certain applications where memory is limited for small data sets. These sorting algorithms compare very favorably against more complex sorts. We will talk about bubble sort, selection sort, insertion sort. All of these conversion-based sorting methods, since they rely on conversions to order the elements. You can measure a sorting technique general performance by counting the number of times the sorting algorithm compares elements. Begin with bubble sort. Bubble sort, one of the most straightforward sorts, is the bubble sort, which repeatedly compares adjacent values if it needs to perform the sort. Therefore, the larger values in the set will bubble up to the end of the collection. 9, 4, 10, 3. Dinari. Swipe 4 with 9. Swipe 4 with 9, 3, 10. Swipe 3 with 10. 4, 3. Swipe 9 with 3. Swipe 3 with 4. Swipe 9 with 10. Implementation. Adding a swap extension to list. Extension swappable list. On list of element, void swap integer index A and integer index B. Final term this index equal this index B, this index A. 3. Original list, bubble sort, bubble sorted. The value, the result as this. Create swap dart, import swap dart, bubble sort, extends comparable dynamic list element E list. 2 for loops, for loop var end list length -1 and equal and greater than 0 and minus var swapped false. Second for loop var current equals 0, current less than and current plus. If list current compared to list current plus 1 greater than 0, list swap current plus 1, swap it equal true. Third, if not swap, follows the basic idea of bubble sort but improves this algorithm by reducing the number of swaps. Comparison. Selection sort will only swap at the end of each pass. You will see how that works in the following example. 10, 4, 9, 4, 10, 3. Swap 3, 4, 10, 9. Then swap 3, 4, 9, 10. Implementation. Import swap dart. Selection sort extends comparable dynamic list elements. 2 For loops and if condition lowest not equals 3, swap 3, 4, 10, 9, then swap 3, 4, 9, 10. Implementation. Import swap dart. Selection sort extends comparable dynamic list elements. 2. For loops and if condition lowest not equals start, list swap lowest start. Testing out. Import package selection sort. List 9, 4, 10, 3. Original and selection sorted. The result as this. Loops and if condition lowest not equals start, list swap lowest start. Testing out. Import package selection sort. List 9, 4, 10, 3. Original and selection sorted. The result as this. What is insertion sort? Insertion sort is more useful algorithm like bubble sort and selection sort. Insertion sort has an average time complexity of O(n) square, but the performance of insertion sort can vary. The more the data is already sorted, the less work is needed to do. Insertion sort has the best time complexity of O(n) if the data is already sorted. It has the best time complexity of O(n) if the data is already sorted. Dart itself uses insertion sort for lists with 32 or fewer elements. The sort method defaults to an insertion sort. Only for larger collection does Dart make use of a different sorting algorithm. First, 9, 4, 10, 3. 4, 9, swap. 3, 10, swap. 4, 9, 10, 3, swap. Then swap 3, 10. Then swipe 9 and 3. Then swipe the latest swipe. Now plus. Second for loop, var shifting equal current. Shifting greater than 0, shifting minus minus. If list shifting compared to list shifting minus 1, less than 0, list swap shifting. Shifting minus 1, else break. Stability, a sorting algorithm is called stable. If the elements of the same time retain their order after being sorted, for example, say you had an sorted deck of cards in which the 5 of clubs comes before the 5 of diamonds. If you then sort the cards by number, only the 5 of the clubs would still come before the 5 of diamonds in a stable sort. That would not necessarily be true for an unstable sorting algorithm. The sorting algorithm. Testing out, import insertion sort, list take list. For example, then apply insertion sort, then the result will be true. Merge sort is divide and conquer. Use approach named divide and conquer. Now, O(n) square, we talked about bubble sort, selection sort, insertion sort. We move to merge sort. with the type complexity of ON log n, merge sort split first and merge later. Look at this. 72639, 72639, then 72639, then 72639. Split all deck of cards. Then sort and merge. 27396, 27369, then merge all. 23679. Implementation. Merging lists. List merge extends comparable dynamic. List A, list B. Var index equals 0, var index B equals 0. The result will be while index A less than list A list, value B index list B index B. Second, if value A compared to value B less than 0, result add value A index A equal index A plus 1. Else, if value A compared to value B greater than 0, result add value B index B equal index B plus 1. Else, result add value A, result add value B index A equal index A plus 1, index B equal index B plus 1. Index A, if index A less than list A length, result add all list A get range index A list A length. If list B less than list B length, result add list B get range index B range list B length, then return result. Splitting. Now length multiply by 2. Left list sublist 0 middle, right list sublist middle. Merge sort. If list length less than 0, return list, middle list. Merge sort list sublist 0 middle, right merge sort list sublist middle. Return merge left right. Import merge sort. Then we take, for example, list 72639, sorted merge sort list, then original list merged list, merged sort. The output will be working. Bubble sort selection and insertion sort, where enumeration in memory to do it work. How much there are log 2n levels of recursion, and at each level n elements are used that makes the total O n log n. In space complexity, if you are clever with your bookkeeping flow, you can reduce the memory required to ON by discarding the memory that's not actively being used. Merge sort is also stable. Elements of the same type retain their relative order after being sorted. This will also be true for radical sort. In the next, we'll talk about it, but not heap sort and quick sort that you will learn about later. Merge sort is one of the classic sorting algorithms. It's relatively simple to understand and serves as a great introduction to how divide and conquer algorithm work. What about performance of merge sort? The best, worst, and average time complexity of merge sort is quasi-linear. We talked about n complexity before, or ON log n, which is not too bad. If you are struggling to understand where n log n comes from, think about how the equation works. As you recurse, you split a single list into two smaller lists. This means the list size 2 will need one recursion level. A list of size 4 will need 2 levels. A list for size of 8 need 3 levels, and so on. If you had a list 1024, need one recursion level. A list of size 4 will need 2 levels. A list for size of 8 need 3 levels, and so on. If you had a list 1024, now would take 10 levels of recursion, splitting in 2 to get down to 1024. Single elements list. In general, if you have a list of size n, the number of recursion levels is log 2n. The cost of single recursion is O(n). A single recursion level will merge n elements. It does not matter if there are many small merges. Over one large one, the number of elements merged will still be n at each level. This brings the total cost. Does not matter if there are many small merges. Over one large one, the number of elements merged will still be n at each level. This brings the total cost of O log n multiply On is equal to On log n. This is merge sort and On square sort algorithm. Now we will talk about radix sort. The word of radix means base. The base of number system, for example, decimal is base 10 and binary is base 2. You can use any base with a radix sort, but to keep things simple, this chapter will focus on sorting base 10 integers. Radix, for example, wants thousands. There are multiple implementations of radix sort that focus on different problems. One type sorts by the least significant digits, LSD, and another by most significant digits, MSD. Sorting by least significant digit. Look at this example, LSD radix sort. First, 8, 0, 2, 0, and 1s. Now we put it in. We have got 1, 8 from the final digit of 188, 0 from the end of, and 2 from 0 to 9 places. Now 0, 20, 40, 410, and 2, another, and 8, another. Now, second round, tens, we put the 10 places, 1, 2, 7, 8. Then, hundreds, 0, 4, 7. Then thousands, 0 and 1. Then sort it. 20, 88, 40, 410, 1772. This way. 2. Final buckets list generate base integer for each number. Remaining part number multiply base. Digit remaining part division. Base, and for buckets digit add number. If remaining part multiply division by base greater than 0, then equal false. 5 place multiplied by place equal place multiplied by base. Then clear and add all buckets, expand elements element. For testing, list original and radix sort. The result is true. Sorting by most significant digit, list, original and radical sort. The result is true. Sorting by most significant digit. The same for LSD, MSD. Lexicographical order. See this? 1, 4, 5. We have hundreds, tens, and ones only. Begin with hundreds, then thousands, priority, then 5 and 6 in other. Then we sorted 13, 1000, 30, 345, 459, 46, 500, 999. Implementation. Extension digits on integer, static const base 10, integer digits count 0, number this, number not equal 0, count plus 1, number multiple 999. Implementation. Extension digits on integer, static const base 10, integer digits count 0, number this, number not equal 0, count plus 1, number multiple division by base, return count. Print 13 digits is 2, 999 digits is 3, 1345 is 4 digits. Board that math, digit at if position greater than or equal digits, return null, number equal this, while number division by power, base position plus 1, base, return count. Print 13 digits is 2, 999 digits is 3, 1345 is 4 digits. Board that math, digit at if position greater than or equal digits, return null, number equal this, while number division by power, base position plus 1, not equal 0, number division by base, return number division by base. Print digit at, then extension, in digits is empty, return 0, return reduce max digits. We have list max digits 4. We continue adding the recursive sort methods. Lexicographical sort, sorted MSD radical sorted this 0, clear add all sorted. First, MSD radical sorted list integer position if list less than 2 or position greater than or equal list max digits, return list. Final box equal list generate 10 integer list. Priority bucket equal list of integers. For var number in list latest number bar. Then first final bucket order equal bucket reduce result bucket. If bucket is empty, return result. Final sorted MSD radix sorted bucket position +1. Return result add all sorted. Third and final return priority bucket add all bucket order. For testing, list lexicographical sort print list. Then we have the list ordered. And that's what we want if you're asking for lexicographical order. This is radix sort. We talked about ON square, we talked about merge sort, we talked about radix sort. Now we move to heaps. Heap sort takes advantage of heap being by definition partially sorted binary tree with the following qualities. In max heap, minimum heap. Max heap, all parent nodes are larger than or equal to their children. Minimum heap, all parent nodes are smaller than or equal to their children. Diagram below illustrates 10.8.5.1.4 1.2.5.8.4 max and minimum heap. Once you have a heap, the sorting algorithm works by repeatedly removing the highest priority value from the top of the heap. Building a heap. How to build a heap? For example, this example, the same idea for the heap. Total time complexity of building a heap is O n log n. Sorting the list in heap. Once you have heap, you can go on to use its properties to sort the list in ascending order. Because the largest element in max heap is always at the root. You start by swapping the first element at index 0 with the last element at index n-1. After being swapped, the last element of the list is in the correct spot but invalidates the heap. 5, 12, 21, 9, 8, 18, 2, 6, 26. Now, then, here we find 18, 2, 6, 9, 8, 5. Then 12, the same idea, 12, then 9, then 8, then 6, then 5, then 2, and last item. Using heap class, import heap. Heap class extends comparable dynamic list A list. First final heap equal heap of elements list to list, priority minimum. Second, sorted, while heap is empty, add value, return sorted. Import package heap sort, sorted heap sort, then print sorted, the value is 2. Sorting in place extension heap sort, extends comparable, then preparing private helpers methods. Integer left child index as the heap we talked about. Return 2 multiply parent index plus 1. Right child index integer parent index. Return 2 multiply parent index plus 2. Swap values integer index A and integer index B. Final attempt this temp swipe, normal swipe. Modifying the shift method shift down, required integer start, required integer end, attempt swipe, normal swipe, modifying the shift method, shift down, required integer start, required integer end, parent start, while true, left child index, then right the same, then chosen equal parent. Second, if left less than end and this left compared to this chosen greater than 0, chosen equal left. If right less than end and this right compared to this chosen greater than 0, chosen equal right, chosen equal parent, return, swap values parent with chosen, parent equal chosen. Add main extension method, keep sort in place, if is empty return, final start parent, return, swap values parent with chosen, parent equal chosen. Add main extension method, keep sort in place, if is empty return, final start length division by 2 minus 1 for var I equal start I greater than 0, I minus minus, shift down start I, end length. Second, for var end equal length minus 1, end greater than 0, end minus minus, swap values 0, end, shift down start 0, end, end. Testing it out. Final list, print list, heap sort in place, list danger result. Beautiful. What about performance of heap sort? The performance of heap sort is O in log n, or its best, worst, and average. Heap sort in place, list danger result. Beautiful. What about performance of heap sort? The performance of heap sort is O in log n, or its best, worst, and average cases. This uniformity in performance is become because you have to traverse the whole list once, and every time you swap elements you must perform a down shift, which is an O log n operation. The space complexity of your first implementation heap sort was linear since you needed the extra list couples. However, your second implementation heap sort in place. First implementation heap sort was linear since you needed the extra list couples. However, your second implementation heap sort in place had a constant O1, then space complexity. Heap sort is not a stable sort because it depends on how the elements are put into the heap. If you were heap sorting a deck of cards by their rank, for example, you may see their sweep change order compared to the original deck. This is heap sort. We talked about O(n) square in bubble sort, selection sort, and section sort. And we talked about merge sort, and we talked about radix sort and heap sort. Now we move to quick sort as quick sort algorithm. Quick sort is another conversion-based sorting algorithm, much like merge sort. It uses the same strategy of divide and conquer. One important feature of quick sort is choosing a pivot value. The pivot divides the list into 3 partitions: values less than the pivot, values equal to the pivot, and values greater than the pivot. In the example, the pivot is 8, while the partition on the left has values less than 8, and the partition on the right has the values greater than 8. Quick sort continues to recursively divide each partition until there is only a single element in each one At this point, the list is sorted. The quicksort algorithm is not stable, that may have different final locations depending on their initial positions. For example, if you're only sorting by numerical value, a 9 of clubs may come before a 9 of hearts one time, but after it another time. See this example: 8, 2, 10, 0, 9, 18, 9, minus 1, 5. Let's take pivot, then split values. Now we take 2, pivot, split values, take 0, split values, and stop. Take the right section, 10, split values, and 9. List E list. First, list length less than 2, return list. Second pivot equal list 0. Third, final list equal list where value, return value compared to pivot less than 0. Final equal list where value compared to pivot equal 0. Greater compared to pivot equal greater than 0. Then return quicksort naive list to list equal quicksort naive greater to list. Import quicksort, then try list sorted quicksort naive, then print sorted. The result is true. Partitioning strategies. There is partitioning strategies. Swappable, each other, return, then swap. We have Lomuto algorithm. Lomuto algorithm in partitioning strategies. Lomuto partitioning algorithm always chooses the last element as the pivot value. The algorithm then partially sorts the list by putting the lower values before the pivot and higher values after it. Finally, Lomuto returns the index of the pivot location within the list. The same example 5, for example, pivot, then pivot, then pivot, here 5, 2, pivot, index, auto, comparable dynamic, list of key, list, integer low, integer high, pivot index equal low, for low, integer I equal low, I less than high, I plus plus, list I compared to pivot, less than 0, list swap pivot index I, pivot index equal pivot index plus 1. Fourth, list swap pivot index with high, return pivot index. Quicksort Lomuto comparable dynamic, list E list, low high, then if low greater than or equal high, return final pivot index. Partitioning Lomuto list low high. Quicksort Lomuto list with attributes list low pivot index minus 1. Quicksort Lomuto list pivot index plus 1 with high. Testing it out, this one. This will result true values. What about Hur's partitions? We talked about Lomuto. Now we talked about Hur's partition. Hur's partition algorithm always chooses the first element as the pivot value. Then it uses 2 pointers moving towards the middle from both ends. When the pointers reach values that are on the wrong side of pivot, the values are swapped to the correct side. This is example: right and left, 8, left 2, 10, 0, 9, 18, 9 minus 1, 5. Then right left till true. Left equal low minus 1, right equal high plus 1. While true, do left plus 1. While left compared to pivot less than 0, do right minus 1, while left right compared to pivot greater than 0. If left less than right, left swap left right, else return right. Quicksort for extends comparable. If low greater than or equal high, return. Final left high partition here, list low high. Quicksort for list low left high. Quicksort for list left high plus 1 high. For list left high plus 1 high. Testing it out. Final list. Quicksort for list 0 list length minus 1. Print list and result will be 2. Effects of bad pivot choice. The most crucial part of implementing quicksort is choosing the right partition strategy. You have looked at 2 different partition strategies so far, choosing the last element as pivot, choosing the first element as pivot, Lomoto and yours. What are the implications of choosing a bad pivot? Take the following example. If you use Lomoto algorithm, the pivot will be at last element 1. This results in the following partition: list equal list empty equal 1 greater all. Example, if you use Lomoto algorithm, the pivot will be at last element 1. This results in the following partition: list equal list empty equal 1 greater all elements is greater. An ideal pivot would split the elements evenly between the less and greater partitions, choosing the first or last element of the already sorted list as pivot. Makes quicksort perform much like insertion sort, which results in the worst case performance of O(n) square. Median of 3 strategies. One way to address this problem is by using median of 3. Pivot selection strategy. Here you find the median of the first, middle, and last element. Median of 3 strategies. One way to address this problem is by using median of 3. Pivot selection strategy. Here you find the median of the first, middle, and last element in the list and use that as a pivot. This selection strategy prevents you from picking the highest or lowest element in the list. Implementing median of 3. Center low plus high. Division by 2. If list low compared to list center greater than 0, list swap low and center. List swap low and high, list swap center and high, then return center. Quicksort median extends comparable. Pivot index median of 3, list low high. Pivot index partition Lomoto list low high, list swap center and high, then return center. Quicksort median extends comparable. Pivot index median of 3, list low high. Pivot index partition Lomoto list low high. Quicksort Lomoto list low, pivot index minus 1. Quicksort Lomoto list, pivot index plus 1 high. Testing it out. Let's take example as already we talked before. Quicksort median list 0 list length minus 1 and parent list will talk the true result. Dutch national flag partitioning. Another way of partitioning from Lomoto and Pures partition flag partitioning. Another way of partitioning from Lomoto and Pures partitions of code sort, we have Dutch national flag partition. A problem with Lomoto and Pures algorithms is that they don't handle duplicates well. With Lomoto's algorithm, duplicates end up in the list partition and are not grouped together. With Pures algorithm, the situation is even worse, as duplicates can be all over the place. Solution to handle duplicate elements is Dutch national flag partition. This technique is named after the Dutch flag, which has three horizontal colors bands of red, white, and blue. These three bands are equal to the pivot. They all go in the middle partition. Dutch national flags partitions is an excellent technique to use if you have a lot of duplicate elements. Smaller equal larger. Let's see this. 8, 2, 2, 8, 9, 5, 9, 2, 8. Smaller equal, then smaller equal, then smaller equal, larger, then smaller equal larger, then smaller equal larger, then smaller equal larger, return it back, equal than larger. If list equal compared to pivot less than 0, list swap smaller equal smaller plus 1 equal plus 1. Else if list equal pivot equal plus 1, else list swap equal with larger minus 1, and by default return range smaller larger. Quick sort Dutch flag extends comparable. If low greater than high, return and stop the function. Final middle partition Dutch flag list low high. Quick sort Dutch flag list low middle low minus 1. Quick sort Dutch flag list middle high plus 1 high. Testing it out, the same idea, the same result is true. Testing it out, the same idea, the same result is true. If any description code samples were confusing, use debugger and IDE, VS Code, or any other we talked about in video of Dart programming language to understand these steps. Explanation can be misleading, but code does not lie. Now we talked about sorting algorithms, O(n) square, merge sort, radix sort, heap sort, and code sort. We talked about many things in this course. We talked about introduction, we talked about complexity, we talked about basic data structures in Dart, list, map, set, we talked about stack. Complexity, we talked about basic data structures in Dart, list, map, set, we talked about stack, linked list, and queues. We talked about trees and many examples of trees. Then we talked about sorting algorithms, O(n) square, and merge sort, radix sort, heap sort. Now we move to latest topic in this course is graphs. Graphs, we have breadth first search, registrar algorithm. Now we will talk about graphs. What are graphs? The migration patterns of birds, even protons in the nucleus of an atom. This section gets you thinking deeply and proudly about using graphs and graphs algorithms to solve real world problems. What do social networks have in common with booking cheap flights around the world? You can represent both of these real world models as graphs. A graph is a data structure that captures relationship between objects. It's made up of vertices connected by edges. Different about trees. There are nodes and references. Here no. Here no. Here is vertex and edges. The circles in the graph below represented in the vertex, and edges are the lines that connect them. This is graph. Types of graphs. Graphs comes in a few different flavors. The following sections will describe their characteristics. Weighted graphs. In a weighted graphs, every edge has a weight associated with it that represents the cost of using this edge. These weights let you choose the cheapest or shortest path between two vertices. Take the airline industry as example. Here network with varying flights paths: Singapore, Hong Kong, Tokyo, Detroit, Austin, Texas, Washington DC, Seattle, San Francisco. Weighted graphs with price. Another type of graphs, directed graphs. As well as assigning a weighted to an edge, your graph can also have direction. Directed graphs are more restrictive to traverse because an edge may only permit traversal in one direction. The diagram below represents a directed graph. Singapore, Tokyo, Hong Kong, San Francisco, Washington, Austin. From San Francisco to Tokyo, you can buy a round trip ticket between Singapore and Tokyo. There is no way to get from Tokyo to San Francisco. Undirected graphs. You can think of undirected graphs as directed graphs where all edges are bidirectional. The directed graphs, two connected vertices have edges going back and forth. The weighted of an edge applies to both directions. Common operators. There are a number of common operators that any graph needs to implement. Before you get those through, you need two basic building blocks, that is the vertex and edges. Defining a vertex. Image of the vertex. There are not yet a graph. Graph dart vertex, class vertex T. Const vertex requires this index and this data. Finite index T data override to string data to string. Here you define vertex, old piece of data. Then define an edge. To connect to a vertex, there must be an edge between them. There are the lines in the image as this: edge source, destination, and weight. Weight is double. Defining a graph interface, edge type, directed and directed. Enum. Now abstract class graph E. Iterable add each vertex source destination each type with edges source double weight vertex source destination. This interface describes the common operations for a graph. Vertex returns all of the vertex in the graph. Create a vertex and adds it to the graph. Add edge connects two vertices in the graph with either directed or undirected. Edge in the weight is optional. Edge returns a list of outgoing edges from a specific vertex. Weight returns the weight of the edge between two vertices. We have adjacency list. First graph implementation that you will learn uses adjacency list for every vertex and graph in the graph. The graph stores a list of outgoing edges. Take the flight network you saw earlier as an example. Can describe relationship between vertex adjacent list. Implementation. Adjacency list implements graph. Map vertex list index connections. Next index equals 0. Override iterable vertex get vertex connections keys. Creation of vertex. Vertex create vertex. First vertex equal vertex index next index data. Next index plus connections vertex equal empty list return vertex. First create a new vertex with unique index. Then you add the vertex as a key in the connections map. You have not connected it to any other vertex in the graph yet, so the list of outgoing edges is empty. Adding an edge. Now, here directed, here undirected. Add edge, source, destination, edge type, weight, connection source, add edge, source, destination, weight. If edge type equal edge type undirected, connections, destination, add edge, destination, source, weight. Retrieving the outgoing edges from a vertex. Continue. Override list edges, source, weight. Retrieving the outgoing edges from a vertex. Continue. Override list edges, source, return connection source. If not, return empty list. Retrieving the weight of an edge. Override weight, vertex source and destination. Match, final match, edges source, where edge. Return edge destination equal destination. If match is empty, return null. Return match first weight. Making adjacency list printable, easy to implement. Override to string. Final result string buffer. First connections for each vertex and edge. Final second. Final destination equals edge. Easy to implement. Override to string. Final result string buffer. First connections for each vertex and edge. Final second. Final destination equals edges map. Edge. Return edge destination. Join. Third result write in vertex destinations. Then return result to string. First, you loop through every key value pair in connections. Second, for every vertex, you find all of the destinations and join them into a single comma-separated string. Third, put each vertex and its destination on a new line. Finally, you build a string. Third, put each vertex and its destination on a new line. Finally, you build first graph. What about building a network? See this example, graph, adjacency list, Singapore, graph, create vertex Singapore, Tokyo, graph, create vertex Tokyo, the same for Hong Kong, Detroit, San Francisco, Washington DC, Austin, Texas, Seattle, Nevada. Graph add edge. Here add vertex, then add edge. Singapore, Hong Kong weight 300, the same, Singapore, Tokyo, Hong Kong, Tokyo, Tokyo, Detroit, and print graph will result as this. Finding the weight, can also obtain other helpful information, such as the cost of a flag from Singapore to Tokyo. This is the weight of the edge between those two vertices. Add the following code at the bottom of the main function. Find a cost graph weight, Singapore, Tokyo, to integer, print costs cost to fly from Singapore to Tokyo. The result, 500. Getting the edge. How to get the edge? Print San Francisco outgoing flags for each final edge in graph edges San Francisco. Print edge source to edge destination. Here is the result. Adjacency list, adjacency matrix. Adjacency matrix uses two-dimensional grid or table to implement the graph data structures. Each vertex has its own row and column in the table. The cells where rows and columns intersect hold the edge weights. If any particular cell is empty, that is, if the weight is null, then that means there is no edge between the row vertex and the column vertex. Here example, we find vertex, destination, Singapore, Hong Kong, Tokyo, Washington DC, San Francisco, from 0 to 4. Source and destination, 0, 1 is exist from Singapore to Hong Kong, from Singapore to 2 equals 0. What about implementation? Adjacency matrix implements graph, final list, vertex, vertex, empty list, list of double weights, next index equals 0, override vertex, triple, get vertex, vertex. Creating vertex, see this and this, zeros and this zeros. Now vertex, create vertex, index, next index, data, data, next index, plus, plus, vertex, add vertex. For loop, var I equals 0, I less than weights length, I plus plus, weights index equal weight. If each type equal each type undirected, then weights destination index, source index equal weight. The logic here is similar to how to implement add edge in the adjacency list previously. Always add a directed edge. If the edge type for the graph is undirected, then also add another edge going from the destination to the source. Retrieving the outgoing edges from a vertex. Override list edge E edges, vertex E source, list edges, empty list, then first for loop, var column 0, column less than weights length, column plus plus, final weight, weight source index column, if weight equal weight source index column, if weight equal null, continue. Third, final destination equal vertex column, edges add edge source, destination weight, return edges. Retrieving the weight of an edge, override double weight, vertex source, vertex destination, return weight source index, destination index, because it's grid or matrix. Making adjacency matrix printable, override to string, output string buffer for final vertex and vertices, output return vertex index, vertex data. Two for loops, for I with length, j weight length, plus final value with ij, if not 0 to string, output return vertex index, vertex data. Two for loops, for I with length, j weight length, plus final value with ij, if not 0 to string, output write value bad write 6, output write 10, output to string. Building network of matrix adjacency. See this graph adjacency list string, graph adjacency matrix string. 0 Singapore, 1 Tokyo, 2 Hong Kong. Read it to row and the same result is. Graph analyzes. This chart combines adjacency matrix string. 0 Singapore, 1 Tokyo, 2 Hong Kong. Read it to row and the same result is. Graph analyzes. This chart compares the cost difference graph operations for adjacency list and adjacency matrix. V represents the number of vertices and E represents the number of edges. Storage space, add vertex, add edge, finding edge, and weight. Conversion between adjacency list and adjacency matrix. Here we find storage space, OV plus E, OV square. In add matrix, O1 and OV square. In add edge, O1 and O1, OV and O1. Adjacency list OV, adjacency matrix O1. This is introduction about graphs. Now we will talk about breadth first search. What is breadth first search? Remember that objects are just vertex and index, and edges represent the relationship between them. Several algorithms exist to traverse or search through the graph's vertex. One such algorithm is breadth first search, BFS algorithm. The BFS algorithm visits the closest vertex from the starting vertex before moving to further vertex. BFS can be used to solve a wide variety of problems, generating a minimum spanning tree, finding potential paths between vertices, and finding the shortest path between two vertices. How breadth first search works? Breadth first search starts by selecting any vertex in the graph. The algorithm then explores all neighbors of this vertex before traversing the neighbors, and so forth. You will use the following directed graph as an example to explore how BFS works. For example, Q, A, B, B, D, C. Then QA, QB, the same idea. DCE, QAB, then FGH, GH, then continue, H latest, Q all the elements, all the vertex, A, B, D, C, E, F, G, H. Then the result as this. Implementation, import Q and graph, extension breadth first search on the graph, list vertex of A element, breadth first search, vertex source, Q stack vertex, vertex set, include visited list, return visited. Q in Q source, include add source, while true on a vertex include Q, if vertex vertex. For loop, final edge and neighbor edges. If not include contains edge destination, Q in Q edge destination, include add edge destination. Testing it out. Declare graph adjacency list. A graph create vertex A. The same for B, C, D, E, F, G, H. Then add the edge. Graph add edge A, B with 1. The same, 2 edges. Final vertex graph breadth first search A, vertex for each print. The result will be this. A, B, C, D, E, F, G, H. What about the performance of BFS? When traversing a graph using BFS, each vertex is included once. This process has a time complexity of OV. During this traversal, you also visit all the edges. The time it takes to visit all edges is OE. Adding the two together means that overall time complexity for breadth first search is OV plus E. The space complexity of BFS is OV, since you have to store the vertex in 3 separate structures: Q, include, and visit. This is breadth first search. Now we will talk about depth first search. What about depth first search? We talked about breadth first search, which you had to explore every neighbor of the vertex before going to next level. Now, in depth first search, another algorithm for traversing or searching graph. There are a lot of applications for DFS, depth first search, topological sorting, detecting a cycle, pathfinding such as in maze puzzles, finding connected components in a sparse graph. To perform DFS, you start with a given source vertex and attempt to explore a branch as far as possible until you reach the end. At this point, you backtrack and explore the next available branch until you find what you are looking for or until you have visited all the vertices. How the first search works? Let's see this example. Now AB, F, G, then complete, stack, this first, A, B, E, F, G, complete, C, then C from stack, complete, CG, F, CGF, complete, another, CGF, H, E, then complete, A, then complete bob B, then complete A, bob D, bob A. First item, bob A, then the result will be this: A, B, E, H, breadth first search, this depth first search. This is the difference between two. Import stack and graph, extension depth first search. On graph E, list vertex depth first search, vertex source. Stack vertex E, pushed vertex E, and visited vertex E. Stack push source, pushed add source, visited add source. Return visited. Traversing vertex. Now complete. Visited vertex E. Stack push source, pushed add source, visited add source. Return visited. Traversing vertex. Now complete. Outer loop to continue or break. We defined it before for loops or while loops. While stack is not empty, final vertex stack peak. Second neighbors equal edges vertex. Third for loop, final edge in neighbors. If not pushed contains edge destination, stack push edge destination. Pushed add edge destination, visited add edge destination. Fourth continue outer loop. Then stack move. Testing it out. We declare graph adjacency edge destination, visited add edge destination. Fourth continue outer loop. Then stack move. Testing it out. We declare graph adjacency list. A graph create vertex from A to H. Then add edges between them, A, B, A, C, and other. Then vertex graph depth first search. A vertex for each print. The result will be the same: A, B, C, A, B, E, F, G, A, C, H, D. What about performance and depth first search? Depth first search will visit every single vertex at least once. This process had time complexity of OV. When traversing a graph in depth first search, you have to check all neighboring vertex to find one available to visit. The time complexity of this is OE because you have to visit every edge in the graph in the worst case. Now overall, the time complexity for depth first search is OV plus E. The space complexity of depth first search is OV, since you have to store all the vertices in three separate data structures: stack, pushed, and visited. What about cycles? Cycle depth first search is also useful for finding whether a graph contains cycles. A graph is said to have a cycle when a path of edges and vertex leads back to the same source, checking for cycles. Now, extension cycles graph on graph for cycles. Now, extension cycles graph on graph. For example, cycle graph. In the directed graph below, if you start at A, you can go to B, then to C. And then back to A again. Since it's possible to arrive back at the starting vertex, this is a cyclic graph. If you remove the C to a edge, this graph would become acyclic. That is, there would be no cycles. It would be impossible to start at any vertex and arrive back at the same vertex. else return true, push it, remove source, return false. To complete the code, Boolean has cycle vertex source, set, push it, empty set, return has cycle source, push it. You are essentially performing a depth-first search traversal by recursively diving down one path until you find a cycle and backtracking by popping off the stack to find another path. The time complexity is OV plus A. Testing it out, graph adjacency list, graph ABCD, create vertex and edge, graph has cycle A. The result is ABC, BC, CAD, D, true. Fastest time from one place to another gesture algorithm is particularly useful in GPS networks to help find the shortest path between two locations. The algorithm works with weighted graphs, both directed and undirected, to calculate the optimal routes from one vertex to all others in the graph. Gesture algorithm is known as greedy algorithm. That means it picks the most optimal path at every step along the way. It ignores solutions where some steps may have a higher intermediate cost but result in a lower overall cost for the entire path. Nevertheless, gesture algorithm usually arrives at a pretty good solution very quickly. Some applications of gesture algorithm include communicable for the entire path. Nevertheless, gesture algorithm usually arrives at a pretty good solution very quickly. Some applications of gesture algorithm include communicable disease transmission, discovering where biological diseases are spreading the fastest, telephone networks, routing calls to the highest bandwidth path available in the network, mapping, finding the shortest and fastest path for the travelers. How gesture algorithm works. Now imagine the directed graph below represented roadmap. The vertex represented physical location and the edges represents one-way routes of a given cost between locations, while each weight can refer to the actual cost. It is also commonly referred to. Imagine the directed graph below represented roadmap. The vertex represented physical location and the edges represents one-way routes of a given cost between locations, while each weight can refer to the actual cost. It is also commonly referred to as distance, which fits with the paradigm of finding the shortest route. However, if you like the word cost, you can think of route finding algorithm as looking for the cheapest route. What about initializing? Gesture algorithm, you first choose starting vertex, since the algorithm needs starting point of the path to rest of nodes. In the graph, assume the starting vertex you pick is vertex A. What about initializing? Gesture algorithm, you first choose starting vertex, since the algorithm needs starting point of the path to rest of nodes. In the graph, assume the starting vertex you pick is vertex A, for example. Shortest route from A to other vertex. Start A, B, C, D, E, F, G, H, null. If you work through this example, you each call table to save two pieces of information. The shortest known distance from A to this vertex, the preface vertex, and path. We have 8 passes. Begin, first path from vertex A, look at all up to distance of 8, A to F distance of 9, A to G distance of 1. Now we define values. Second pass, A1 is shortest, AG. Next we visit G, then G, G to C3 plus 1 is 4. Third pass, from C we find E and B. We pass from C to E1, from C to B is 3. We find E to B 1, E to D 2. We find E to B. In fourth pass, E to B, 1 plus before 6, 1 plus 5, 6. Then fifth pass, turn to B. B is one option to F3. Then return sixth path of the remaining unvisited vertex D is closed A with distance of 7. However, D, no outgoing edges, so it's dead end. You can just move on. We return back on another ways from B to F, then from F to H. Here we don't find, return back to 8th pass, return, because there is no path, the columns for H is null. This is null, H. Creating distance vertex pairs in Gestra algorithm. Import graph, pair extends comparable, pair this distance, this vertex, global distance vertex, override compared to pair distance vertex, override compared to pair other, distance equal other distance, return 0. If distance greater than other distance, return 1. Return else, return -1. Override to string, distance and vertex. Setting up a class for Gestra algorithm. Class Gestra, this graph, final graph. Generating Gestra allows you to pass in any graph that implements the graph interface. Generating the shortest path. Initializing a Gestra algorithm. Import priority queue. Now map vertex pair shortest path vertex source. Final queue, priority queue. Visited vertex and paths vertex. Now map vertex pair shortest path vertex source. Final queue, priority queue. Visited vertex and paths vertex set of vertex and pair. For loop, final vertex and graph vertex, path vertex equal null, queue and queue pair 0 source, path source equal pair 0, visited and source return path. Visiting a new vertex while queue is empty, final current queue dequeue, final saved distance path is current, vertex distance. If current distance greater than saved distance, continue. visited at current vertex. Looping over outgoing edges is current vertex. Now final neighbor equal edge destination. If visited contains neighbors, continue. Final weight is weight or double infinity. Total distance, current distance plus weight. Final noun distance, paths neighbors distance, or doubly infinited. If total distance less than noun distance, here path neighbor equal pair total distance current vertex. Q and Q pair total distance neighbor. To trying it out, to test it out, we define graph adjacency list with vertex and edges from A to H, with edge type directed, gesture graph, all paths gesture shortest paths A, then print all paths. The result will be this. Finding a specific path. To finding a specific path, shortest path, vertex source destination, pairs paths. First vertex and pair. Final all paths or shortest path source. If all paths, not all paths, contain key destination, return empty list. Var current equal destination, path equal vertex E. Current, while current not equal source. Final preface all paths current vertex, and current not equal source. Final preface all paths current vertex, and if previous equal null, returns empty list. Path as previous, current equal previous, then return path reverse it to list. To try it out, path just the shortest path AD, print path, then the result is this. AGCED. AGCED. That's true. What about performance in gesture algorithm? When performing gesture algorithm, we need to visit every edge. That means the type complexity is the D. That's true. What about performance in gesture algorithm? When performing gesture algorithm, we need to visit every edge. That means the type complexity is the at least OE. After visiting an edge, you add the destination vertex to priority queue. If the distance for this edge is shorter, however, in the worst case scenario, where every edge is shorter than the previous one, you would still have to enqueue a vertex for every edge. Since enqueuing and dequeuing with your heap-based priority queue and has logarithmic time complexity, this operation would be O-log E. Repeating that for every edge would thus be OE-log E. Logarithmic time complexity, this operation would be O-log E. Repeating that for every edge would thus be OE-log E. What about when you visited all of the vertex at the beginning of the algorithm to set the paths to null? That operation was OV. So you could say the overall time complexity is OV plus E log E. Now, however, you can assume that for a connected graphs, V will be less than or approximately equal to E. That means you can replace OV plus E log E with E plus E log E. You can rearrange that as OE multiply 1 plus log E. the same result. Then drop the 1, 2, again leave you with O, A, log A. Remember that big O notation is just a generalized way to talk about the complexity of an algorithm as the number of components increases. Constant values can be ignored. This is just an algorithm. We talked about graphs here, breadth first search, depth first search, just an algorithm in graphs. We talked about many things in data structures and algorithms in this course. We talked about some introduction, about big O notation and other big notations and other notations. We talked about also basic data structures in Dart, list, set, map. We talk about stacks, linked list, and queues. Stack, we have push, pop, peek is empty. Queues, we have enqueue, dequeue is empty, peek. In linked list, we have the same idea. And we talked about trees and binary trees, binary search trees, APL trees, tries, and Google search, use it. We talked about binary search heaps and priority queues. Then we talked about sorting algorithms. Sorting algorithms, ON square. We talked about in trees we have nodes and references. Now in graphs we talked about breadth first search, depth first search, and just algorithm. We use it almost in maps, Google Maps, etc. to calculate distance between 2 points, fastest way from 2 points, just algorithm. This was data structure and algorithms course in Dart programming language, approaches a difficult problem. Now in conclusion, at times you may not even know what data structure or algorithm you should use to solve a particular problem. Here are a few ideas to help with that. Draw a diagram to model the issue. There are many diagrams. For example, UML diagram, unified modeling, even if it's horribly slow and inefficient. Analyze what the time and space complexity are of your current implementation. How could they be improved? Step through your current implementation line by line in debugger, debug mode in your Android Studio, VS Code, and any other IDE. For code, you can use debug important way to trace your code and runtime or any other. This often shows you endless tasks that your algorithm is performing. Keep reading and watching videos about data structure and algorithms that you are unfamiliar with. The more you know, the more naturally a solution will pop into your head when you come up against a hard problem. Learning tips. You hear about a new data structure algorithm that you would like to learn. Here are some steps you can take to maximize your learning experience. Try to get an intuitive grasp of how the data is structured or how the algorithm works. Find illustration or videos that describe it well. Draw yourself pictures or manipulate objects such as playing cards. We'll talk about heap, in binary search trees, on other concepts we talked about in this course. Illustration is useful. After you understand the data structure algorithm on a conceptual level, try to implement it in code by yourself. Don't look at the other people's implementations. Just imagine that you are a computer scientist in the 1015th. Imagine that you are a computer scientist in the 1015th. Finally, check out the implementations in other language like C or Java or Python and convert them to Dart. There are many of codes to any problem you thought about it. Just search it in any programming language and convert it in Dart. This is easy to solve this problem. This is learning tips and the conclusion. This was data structures and algorithms in Dart course. I was with you, Engineer Mouaz Al-Shahmeh. Peace.
Hello, this is Engineer Mouaz Al-Shahmeh, Google Dev Library author in Flutter and Dart, Google developer, software engineer. What we will talk in this tutorial, we will talk about Flutter, apps development by Flutter. This is my Linktree QR code. I am Mouaz Al-Shahmeh, content creator on YouTube, Medium, Stack Overflow. I have many badges on Stack Overflow. I have silver, bronze and gold, many of them in my account in Stack Overflow. I write blogs on Medium, also on Google Dev Library. Also, I participate or contribute for many events with Google developer groups with Flutter technology and Dart programming language. I publish many tutorials on my YouTube channel about Dart programming language. I have one about 3 hours. Also, I published data structure and algorithms with Dart about 4 hours on my YouTube channel. Developed many applications on Android, iOS, Windows, Macintosh and web, and many of them with Flutter technology. What is this tutorial purposes or aims? We are going to achieve these purposes. First, apps building by one code base by Dart programming language and cross-platform. Cross-platform, we mean write one code and deploy anywhere with 6 platforms stable with Android, iOS, Mac, Windows, Linux, web. No null safety programming, which released with Dart 2.12 version of Dart. This is very important feature with Dart programming language. Also, we will achieve build interactive and responsive apps for multi-screen sizes. That means media query of context and uses of it. Responsive design for multi-screen sizes. Also, build beautiful, fast and native apps by Flutter. We will achieve using effective routing between apps screens. We will talk about navigating 1 and navigating 2.0, which is very important topic and feature with navigation with Flutter, which is navigation 2.0. We will talk also about declarative thinking or declarative UI, declarative routing with Flutter with package named CoRouter. Also, I published package on pub.dev named meta-SEO. I use meta-SEO with GoRouter package. We'll talk about data management in app effectively and deal with relational and non-relational database. That's mean data management, which is state management in application. State management, we have many packages or methods we can deal with it, such as provider, block or qubit, riverboot, or any other package or state management method or tool. Also we are deal with relational and non-relational database, with schema database or no schema, or SQL or no SQL database. Also we are differentiate between databases work with internet or online or offline databases, which is located into your app without need to connection of internet or the server. Also achieve app tests in real case and prepare it for publishing into app stores. Fortunately, I published many of apps of Android apps for Google Play Store and iOS apps in App Store, in Apple App Store, and many of them have good rates on stores. The same idea for Windows apps, for Microsoft apps, Microsoft Store. The same idea for Mac apps. We will talk about app tests also, performance topics, and DevTools topics. We will talk about clean code, apps programming by state management. Clean code, that mean differentiate of business logics in your app and architecture your app wisely, wisdomly, depend on your app itself. That means you decide the architecture or design better related to your app or business logic in your app. What is the components of this tutorial? We'll talk about Flutter Introduction firstly. This is big topic and we will cross it fastly as we can because there is many of topics. Last is most important from introduction. Many of them is very important for real app development by Flutter technology. Then we will talk about development environment configuration. We'll talk about Android and iOS, which program code, IDE, integrated development environment. Also we'll talk about run first your first Flutter app. We'll talk about declarative versus imperative, which is the most important topic with the Flutter. In my opinion, Flutter is based on declarative. The structure of Flutter or any enhancement in Flutter technology or Flutter architecture is based on declarative. From first edition in 2018, from first edition of Flutter, any enhancement or update with the Flutter SDK you compare with changelog, you find it related to declarative topic. Maybe in my opinion, this is the most important topic in Flutter development or Flutter environment. Declarative thinking or declarative UI or declarative programming, whatever you name it, you call it, it is declarative, not imperative. This is the difference between what you need or how you need. Imperative related to how your program or how your UI user interface is structured, but declarative is related to what you need. Finally, what you need, what you program, what the result of your program or any user interface. This is declarative. We'll talk about responsive design, media query of context, also gallery of Flutter, which appear Material 3 and Cupertino design for Apple, or Fluent UI for Windows 11. All of them you can use by Flutter in one code base with responsive design. Responsive design also from enhancement in Flutter SDK from media query of context. You can now, of foldable devices, you can know the middle points of foldable device, such as Samsung Ultra or Samsung foldable devices. You can know what is the middle points of your device, so you can design the right section or the left section, what you want in responsive design. We'll talk about null safety. Null safety is the most important topic in Dart programming language. This feature is most professional and modern in Dart programming language. Maybe I don't find this feature in any programming language. We find null safety, but maybe there is exceptions in many of programming languages such as Java, Kotlin, Swift, Objective-C, any other programming language. There is exception of null safety, but if we call it null safety, there is another topic in Flutter which name it or call it sound null safety. That means when you write the code, there is announcement or warning about null values of your attributes when you are coding. This is most important feature in Dart programming language, which name it sound null safety. There is not existing in any programming language, in my opinion. Sound null safety. Also, we will talk about state management. State, this is mean by data in your app, data management in your app, state management, whatever you name it. We'll talk about state management with Flutter. There are many of packages with state management, and this topic is most stressful idea for developers, for apps developers, mobile developers. Any of them really stress of this idea or this topic. We will talk about state management. What's the difference between state management of mobile apps and web apps? In web apps, we find two approaches: server side or client side. The server side, maybe we use sessions in web apps, maybe use sessions or local storage. All of them is servers or server-side session, but client-side maybe use cookies or local storage in browser. This is named client-side states or state management. There is two approach: client-side or server-side. But the apps, the idea is different, because apps, in my opinion, the apps, it is near to client-side. Client-side, you need something of state management, but you need to consider the performance of your app, the headache of memory, the headache of your app on memory, on RAM of your device, on network, on any other features, on CPU of your device. All of them is imported in your apps programming or apps development for mobile section. We will talk about provider, we will talk about book or qubit, we will talk about riverboot. Also another topic, we will talk about keys. Although state management is existing in Flutter development, the keys is still important to know or to understand in apps development. Keys, if we say everything is widget in Flutter, we will continue the phrase to every widget has a key in Flutter. So consists of keys, or distinguish between the keys for global keys or local keys. We'll talk about them in details later. Also, we'll talk about routing with Flutter. The routing with Flutter, the difference between navigating 1 and navigating 2. We'll talk about some packages, and the most important packages, Go Router with declarative routing navigation 2. We'll talk about Go Router with navigation 2.0 for declarative routing with Flutter. Also, we'll talk about database options. There are many of database options. This is the strong feature with the Flutter. Is there many of database options? You can deal with it from local databases, SQLite, SQL Entity, Hive, or any other package, or you can use JSON. We'll talk in details with database options. Also, you can use online packages such as backend as a service, for example Firebase, which is NoSQL database related to MongoDB or JSON or document databases. Also, we'll talk about backend as a service, which named Supabase. Supabase related to SQL database, relational databases, related to PostgreSQL. And if you don't need backend as a service, you need to deal with API. Also, this is approved or possible. You can use APIs over HTTP or DU packages. There are many of them. You can deal with it. If we talk about API, we talk about any backend technology. You can deal with it. For example, PHP Laravel or C#, .NET, .NET MVC, .NET Core, whatever, or JavaScript, Node.js with Express, or Python with any package or framework with Python, Flask, Django, Fast API. You can deal with any backend technology by API with Flutter. Also, we will talk about these topics in details with database options. We'll talk about performance tests. This is important for mobile apps, also for web apps. Performance tests is important. Tests of memory, CPU, network, any other of topics. Also, we will talk about debug mode and trace your code. Also, there is another topic is app builds types. There is 3 apps builds type, which is debug, profile, release. Which of them I use in my app, where I use which of them, where I use debug, where I use profile, where I use release, we will talk about in details later. Also, finally, we will talk about some conclusion and resources references may be useful for you. Let's begin. Flutter Introduction. We will talk about aims of this tutorial or objectives. Now we'll talk about Flutter Introduction. What is a Flutter? There are many people or experts or Googler define the Flutter. Many of them define Flutter as front-end technology. Many of them define Flutter as framework for Dart programming language, but we return back to the Flutter, how it defines itself. Flutter itself is UI toolkit, user interface toolkit. This mean is UI toolkit, Google portable UI toolkit for crafting beautiful natively compiled applications for 6 platforms: native, stable, mobile, web, and desktop from single code base. With Flutter 3.3, about history of Flutter, maybe we talk about history from first edition Flutter, nothing. Flutter 1.0, nothing with Flutter. Horrible, nothing. The performance is terrible. Flutter 2.0 is the most movement or the most change with Flutter. With the Flutter 2, we find null safety. With the Flutter 2, we find support stable for Android and iOS. With the Flutter 2, we find support stable for Windows. This is big change with the Flutter. Also for Macintosh, support Apple Silicon, all of them with the Flutter 2. 2 point any number, but Flutter 2. With the Flutter 3, also nothing. With the Flutter 3, say hi, I am here. Nothing changes with the Flutter or big change. We say it big change, nothing. With the Flutter 2, in my opinion, this is big change with the Flutter 2. This is short history about Flutter. Maybe with 25 of January 2023, maybe with Flutter 4, any change it, maybe support embed systems, maybe support 3D with Embler graphics. Maybe this ideas, maybe improvement of web server side. Maybe this ideas or this topics enhanced with the release of 25 of January 2023. Maybe I expect them, but with Flutter 3, nothing. All of changes or big changes with Flutter was handled with Flutter 2. We will talk about hot reload and hot restart. This is big feature with Flutter. If you deal with Android apps, you deal with hot reload. You need to restart all the app if you change anything to see it in your app. The same idea for Apple, you deal with the Swift UI, you need to you need to reload, you need to totally reload the app to see any change in your app. But with Flutter, there is a very good feature which is hot reload and hot restart. When you code, you see the result. This is good feature. Also with Flutter, we talk about one code base in Dart programming language. The knowing of other platform technologies may be useful for you, but not necessary. You can use packages for specific platform channels, for Android, iPhone, Windows, web, any other. But you write with one code base, Dart programming language. There are many compared development environment which is cross-platform. We find Xamarin of Microsoft. Xamarin maybe the same for Flutter, but with Xamarin, Flutter is over Xamarin with animations. We find with the Flutter very good animations with 2D rendering engine, which name it Skia. We'll talk about it later. Skia deal with 2D rendering engine, but with this rendering engine, graphics rendering engine, we find very good animations with the Flutter. Maybe with Impler, with the 3D, we find the negative area or disease area of a Flutter with a 3D, which is Unity from Microsoft. Unity is specialized for 3D apps or 3D games, which is better than Flutter until now, before Impler is stable. Also another cross-platform technologies, React Native from Meta or Facebook. React Native is based on JavaScript library or framework. You deal with components. Maybe is more difficult from Flutter or that programming language. The same results you can have with Flutter and React Native, but the programming language, in my opinion, is moved to Flutter or near to Flutter rather than framework of JavaScript. We will talk about that programming language is high level programming language, which is have many features: object programming language, object oriented programming, OOP, clean architecture, null safety, async await, future, any of them you find with Dart programming language. If you program with any programming language before, such as Java, Kotlin, Swift, Objective-C, or any other C#, any other programming language, modern programming language, you are very familiar with Dart programming language. But if we will talk about JavaScript, this is long story. I know person, without naming him, he started learning of JavaScript from 30 years. Until now, he is learning JavaScript and not finish learning. Because if you talk about JavaScript, you talk anyone with JavaScript can create a new feature, can create his own aspect of programming with JavaScript. This is more difficult idea with programming language from JavaScript, because this is more difficulties or troubles you have find in your path or your learning path. But if you deal with programming language, famous programming language concepts, for example, object-oriented programming, any other related programming concepts, you deal with familiar programming language such as Dart programming language. Also we have Kotlin Multimobile, KMM. This is cross-platform, but in Kotlin Multimobile, here you need to configure with iOS. You need to write settings for iOS. This is no one code base, so I prefer Flutter. Also, if we compare with native apps, the native apps is better than Flutter. Why? The native apps, you communicate with native SDK, native APIs, so such as Android SDK, such as iOS SDK. You deal with native SDKs, native APIs. So the programming language, the platform itself is created, so it's the better for this platform. The good ideas or the good news, Flutter, you can read or write any platform specific code into your Flutter app, and the reverse is correct. You can write Flutter code into platform specific code. You can write Flutter into Java or Kotlin. You can write Java or Kotlin into your Flutter app. The same idea for Swift. This is platform channels. We'll talk about platform channels later. The same as we talked about before. 6 platforms: mobile apps, Android, iOS, desktop apps, Windows, Mac, Linux, web apps. What is the structure of Flutter? 3 layers: embedder. You talk about platform specific, then code into app or library. Another layer is engine. You deal with C++, library to support primitive rasterizations, I/O, input-output, Dart runtime, plugin architecture. The top-layer is framework, Flutter framework or plugins, high-level features, or Flutter framework. You deal with it as a developer with Dart programming language, Dart reactive framework with platform layout foundation libraries. The architecture of Flutter is different with web because no engine. You deal with browser directly. Flutter framework consists of many of things such as foundation, painting, animation, gestures, rendering, widgets, styling, text controls, and UI theme, Cupertino material. The 2D rendering engine is Flutter based on until now is Skia. Skia is 2D rendering engine. Graphics supported platforms Windows 7, 8, 8.1, 10, Mac OS or later, iOS, Android, Ubuntu, any other. The Flutter team now is working about Impler 3D rendering graphics, which is modern graphics API based on Metal of Apple and Vulkan, which run on many of platforms such as Android, Linux, Windows, any other, or PlayStation. This APIs run on PlayStation or Xbox games. Now it is modern graphics. This is Metal of Apple and this Vulkan. It's modern APIs with the 3D. Again, this architecture of Flutter with the web, the architecture is different. We deal with browser directly, JavaScript, C++, HTML, CSS, JavaScript, Canvas, WebGL, WebAssembly, and framework simply as it. Material, Cupertino, widget, rendering, painting, animation, gestures, foundation. What is the tree of Flutter? There are three types: widget tree, element tree, render object. Widgets configuration, element lifecycle management, render object paint, or user interact with. For widget holds properties, public APIs. For element manage references, and element tree represent a widget in the tree. Render for know how to size and paint. Layout children, listen to for input, hit testing. When user input, response to user gestures, keyboard, touch screen, etc. Second animation will begin. User interface changes triggered by the tick of a timer. Build app code that creates widgets on screen. The rendering process will start. Layout paint composition. Layout positioning and sizing elements on the screen. Converting elements into a visual representation. Composition overlaying visual elements in draw order. And rasterize translation output into GPU render instruction. This is life cycle of interaction or framework processes of Flutter. Again, the tree of Flutter: widget, element, then render tree, container color. Look here, container, component element, but color box, render object element. We don't see component element, but render object element with render tree. This is platform channels, specific platform channels. It is just differentiate between names, name Flutter view controller, Flutter view, Flutter method channel, Flutter binary message, Flutter engine iOS shell, Flutter engine Android shell, custom Android code, custom iOS code, Flutter framework method channel, binary messages, custom Dart code. Maybe if you refer to any package with the pub.dev, if you open any of code or GitHub repo of any pub.dev package, you'll find native codes in package such as Android, Java, or Kotlin, or iOS, Swift, or Objective-C. Then you call your app by method channels, method invoke. This is platform channels. With the embed systems, this is different idea. We find embedder or engine. With embed system is not totally system or operating system. It is part of operating system, such as Linux embedding for Flutter, C++. We find many of uses of embed system with smartwatch, smart bridges, fridges, smart homes in common. We find it in cars, screen of car or system of car. This is embed system, such as Toyota system is embed system. Also, we find it with Samsung, for example, Samsung code devices. It's embed system. Also, we find it with BMW. BMW says our system is totally with Flutter technology. BMW posted article about Flutter technology in his website. They say about total system of BMW is based on Flutter. Now, changed all systems to Flutter before it's cross-platform. Not system, but embed system. This is tests of embed systems. All of them is done. Only one not tested. Tizen system is famous embed system used for smart screen, smart fridge, smartphones, smartwatch, any of them use embedded system. Work. The embedded system is not stable until now, but working on it is under process. This is Flutter Introduction. Now we'll talk about development environment configuration. We'll talk about development environment configuration with Flutter. You need to get device properties such as 8 RAM, enough space in your hard disk or SSD or hard disk drive. You need enough space for Flutter SDK. Then download the Flutter SDK from the website of Flutter, and then you need to download code program such as VS Code for Flutter, VS Code, Visual Studio Code, Android Studio, IntelliJ IDEA, and VS Code. You need each of them in a specific platform, such as Android, you need Android Studio, and Apple, you need Xcode. For publishing, for Cocoabots, for Java JDK, you need, for app signing, you need specific programming or specific code program. With that, you can program with any program code such as Dartpad online. With Flutter, we find zap.run, zapp.run. With Flutter, it's online compiler for Flutter. It's good, needs some improvement, but the idea is good. You can write Flutter online. All you need to connect with GitHub profile or GitHub account, add code Flutter. It simply is this. Similar to Dartpad, needs some improvement, but it's a good idea. You can use GNU Emacs, Eclipse, and Vim for that Dart programming. If you open VS Code, Visual Studio Code, you find extension of Flutter. You need to download it. If you download it, the Dart automatic ask you to download and then accept. Flutter and Dart package. You need to download, then it's easy to run your first app. Just Command Shift V, then Flutter new project, choose application, choose the destination, name Flutter app, enter. That's it. Your Flutter app is done. With all of platforms, Macintosh, Web, Windows, Android, iOS. If you need to run the app, just open emulator, and run the Flutter app. You need to run with browser Macintosh app. Also you can. It's simple. Wait for connection with platforms. Hey, we run it on native Mac application. Let's run and run with browser for web platform. It's just like this. With web browser, if we run, all things is correct and run perfect. Also the iPhone 14 is running well. All things run correct. Okay. If you want to run with Android also, it's possible. So we return back. If we want to run Android apps on Android Studio, easy, click new Flutter project. Decide Flutter SDK path. Next. Name the project and locate the project. Okay. We want to add into folder, some folder. Okay. We choose any platform we want from 6 platforms: Android, iOS, Linux, Macintosh, Web, Windows, and the language Java, Kotlin, Objective-C, Swift. Just that. We click finish and all codes we need exist. Now we find the project. If we want to run Android device, just run Android device. The same for VS Code, Visual Studio Code. The same idea. Just choose the device. If you want Chrome, Macintosh, Android, or iOS, iPhone, just run the application. You find it's running with no problem. Wait for the debug to run Android app. it's running well. If we click add button, the number is increased. In Windows, we need CMake package to download. Over that, to run Flutter application on Windows, you need to download CMake in Visual Studio program to run Windows Flutter application. Return back to slides. So we talked about some introduction about Flutter, then development environment configuration, and run first Flutter app in 6 platforms: Windows, Web, Mac, iOS, Android. The Linux is the same idea to all of this. Now we move to declarative versus imperative. What is declarative? What is imperative? As we talked firstly, declarative is what you want from your code or UI, user interface, or anything. But imperative is near to how to code or how you want your code. Declarative and imperative is simply when you code into Android, you use XML user interface, you deal with XML. But if you now Android team working on get back combos to move to declarative way, but first or older than get back combos, you need to deal with XML to illustrate user interface. This is near to imperative. Another in iOS or Swift, in iOS Apple, you need to deal with the Swift UI. The same idea, but in Flutter you need to deal with Flutter, Dart, and Flutter framework, Flutter UI toolkit. You don't need to deal with XML or Swift UI or Fluent UI with Windows. Nothing from that. You deal only with Flutter. With Flutter, you can use Material, you can use Cupertino for design of any platform, but we deal with one code base and declarative UI. Just declare the things you need and you get the result directly. The equation of declarative is UI equal if state. UI is the layout on the screen, user interface, equal your build methods multiplied by the application state. We will talk about state management later in details, but now look at this example of Dart enhancement, latest enhancement for Flutter 3.3 or whatever. Before the enhancement from enum, you need to declare enum and extension, make extension, then override all of that. But in declarative way, don't need to extension. Less code, have the result faster than before. Use override to string, then use the attributes in enum. Declare attributes into enum and override the toString easily. Print water frozen. Just that. This is the equation of declarative. The declarative of Flutter. Also, if we talk about map or for loop, if condition, if else condition, while condition, the while condition, whatever, you don't need that. With Flutter, the concept of map, declare the list or whatever you want to loop it,
then name of list dot map element or one of the list, then get the result directly, what your result you needed, into callback of the function directly. This is one example of declarative. The declarative is the base of Flutter. The structure of Flutter is based on declarative mainly. We talked about declarative, Flutter Introduction, then we talked about environment configuration, what you need, and run the Flutter first app in 6 platforms. Then we talked about declarative and imperative. Now we will move to responsive design. What is responsive design? With Flutter you can deal with multi-screen sizes by media query of context. With media query of context you can use size with many attributes, size high, size width, any of them you can use it into your app and configure the size pixels and do the design, prepare or related to what you want from the design as responsive design. It's similar to media query with CSS and web, the same idea. Here no breakpoint. Here you can find directly the breakpoint or what you need from design or from pixels of the screen. You can access every pixel in your screen from Flutter apps. Media query of context now with foldable devices, as we talked in Flutter Introduction. With foldable devices, you can with media query know what of middle pixels in your foldable device. Then you can design the right section you need whatever, and the left section you need whatever you want, or you want to switch or move something from left side to right side, or by touching, drag and drop, anything you can deal with responsive design. With Flutter, as we talked first, Cupertino, if you want to use Cupertino, the design of Apple, you can, and you can use design of Android with Material 3. Material 3 is very good features enhanced about Material 2 or last versions, previous versions. Material 3 is good concepts with design, modern design of Google. Material 3 for Android. If you want to use Windows 11 design, also you can by Fluent UI package. I wrote article with detailed about all of these packages in Medium, in my account on Medium. I publish full article about these things. There is website called galleryflutter.dev. You can access all of them. You can show the design, you can show the code of any widget you need, all of them in excellent website. Call it Gallery Flutter, attractive website. You can access all many of widgets with explanation and it's very useful. know widgets and how to use it. If you want to use material, there are many uses. For example, menu, and what the code, many of them. If you want to use Cupertino for iPhone, iOS, such example activity indicator, and this is the code. If you want documentation, if you want information, all of them detailed very well. There are many of them. Very good website if you want to know all of them. Now we talked about responsive design with Flutter. We move to null safety with Flutter. With null safety, there is a concept of null safety. It is default of variables of any object. It is default to null. So if you want to, or nullable, if you want to make it nullable or non-nullable, you choose this. But the default value is non-nullable for the warning. To if you forget, for example, to assign the value to attribute or parameter, the compiler warning you about this attribute, it's maybe have null value. This is null safety. Null safety was published first edition with Dart programming language. Sound null safety is available in Dart 2.12 and Flutter 2. This was big movement or big change with the Flutter. What is null safety? Look about these examples. With a string here, if it's nullable, we can find directly null value or string value. Here, not nullable. So if we need null, we must be across all of projects to get null value. The same here, nullable types, here non-nullable types. The same here, if the object is null, look here, from parent of tree, directly we have null or the object. With the object, number or iterable, number we have integer double, iterable we have list. All of them conclude with never. There is many types of nullability. Optional parameters must be nullable or have a default value. Types are non-nullable by default and made nullable by adding question mark. We have required. You can use it with null safety. Also required. Also, if you need to concatenate or cascade, this is question mark dot dot or the index question mark square brackets bank, the postfix null assertion bank operator exclamation mark. There is keyword not preferable for many of developers, which is late. Why it is not preferable? Because if you forget assign the value to your attribute lately, this is a problem. So your program will be crash. So you use late carefully, and we prefer don't use it in your app, because the same as we took it, if you forget to assign the value later, this is a problem. This is null safety with Flutter and Dart. Now we will talk about state management. Is the most important topic with Flutter development, Flutter apps development. What is state management? State management is the data management, the data in your app. Simply manage the data in your app. There are many concepts, there are many tools you can use with state management. There are many packages to use with state management. Provider, Riverbot, Block or Qubit, Rx, Fish, Redux, Getit, PoPX, Binder, the state of Flutter itself, GetX, Getit, Redux, many other. But we will talk about three. It's Provider and Block or Qubit and Riverbot with state management. We will talk about example of every one of this. What is the state object lifecycle? Begin from build context assigned, mounted equal true. The mounted equal true is very important with Riverbot to fix the error. With Riverbot you need to pass mounted attribute. In some cases with Riverbot, the state object lifecycle begin with init state, the change dependencies, dirty if dirty is equal true or false. Here you can use many of this, set state or build or did update widget. Set state is very trouble or very false or not good to your app state management, because if you call set state, every set state until one attribute changed, for example integer from 0 to 1. If you call set state, the whole widget in the tree is refreshed. You don't need that. You don't need the refresh of all widget tree if anything changes. This is big problem with set state. There are many solutions, more wisdom from set state, such as Provider or Riverbot or Block or Qubit. We will talk about this. So, state changes or old widget. When dirty equal false, deactivate and dispose. When dispose, call it the mounted is equal false. This is life cycle of state object. There are no one rule with the Flutter state, but we move near the concepts. There are two categories with state: ephemeral state or app state. If you need state into single widget in your app, you maybe use ephemeral state. Or if you need the state into some widgets or most of widgets, you need something, call it app state. What is ephemeral state? Ephemeral state, sometimes call it UI state or local state. You can use it, for example, page view or current page in page view, or such as current selected tab in bottom navigation bar. This is local state. Call it ephemeral state. Another type is app state. App state, you use it many widgets. For example, state that's not ephemeral, that you want to share across many parts of your app, and that you want to keep between user sessions is what we call application state, sometimes also call it shared state. What is examples of app state? Such as user preferences, such as the app is light mode or dark mode, night or day mode. What is the language of your app? For example, English, Arabic, Chinese, whatever. You need this state to be shared all over your app. Another example, login information. You need to know the state of login information into all of your app. Is it the user is logged or not logged? Another example, notification in social networking app. Another example, the shopping cart in e-commerce app. Another example, read or unread state of articles in a news app. All of this we call it app state. Look at this scenario. One is good and one is bad, very bad. The right section and the second section. The scenario one, look at data from parent widget. This is trouble, very bad scenario. If we drop this widget, for example, we need to pass data. If we need to pass data from first widget to this widget, we need to cross all of widgets above this widget to get the data. This one bad thing. Another thing, if we drop this widget, for example, we need to connect these widgets to above side, and this is another problem. Many of the problems. The question, if you want to separate block logic or business logics into your app, this is very difficult idea. You don't know how to separate concepts or separate business logic in your app in this scenario. This is big problem scenario with state management, and this is the default Flutter state management by set state and pass the attributes with widgets over widgets by attribute passing. Another example, inherited widget. This is widget is above the root of Flutter tree widgets, and we can access the inherited widget all over widget in the tree directly from scenario 2. We can, for example, this widget, we can access the data or inherited widget from the parent directly, or any widget. And this is the rule or the concept provider based on. Provider is override of inherited widget from immutable widget to mutable. Make copy of inherited widget and assign data and refresh any widget. Listen to this widget by notify listeners. This is the idea of provider. We'll talk about it later. Here, the business logic, if we use first scenario, this is big problem if you need to separate business logic. If you need to make clean code, this is the problem. Business logic, user interface with database, network, or API or services, database and UI user interface. Business logic, if you need to separate business logics, this is very important in your app, such as large scale apps. This is very important. Clean architecture, maybe some people make the importance of layers first, and other people make the importance of features first. This is dependent on your app. No rule here. If you need, for example, ERP, entity relationship management, or the resource for commerce app applications, you need to features first. For example, customer management, sales management, buys management, HR management, whatever. All of this we call it by feature first. Another way is layer first. You discrete or illustrate your app into layers from domain, application, presentation, framework, presentation and data. Over there, all this is framework. Domain, application is your code. Domain is modules as you want to design it. For example, integer ID, string name, username, string first name, string last name, date or timestamp, whatever of this. This is all, we name it domain. The application is your code to deal with domain. Another layer is presentation. It's user interface, presentation, the design or the user interface or the user experience. All of this is presentation. And the data, you deal with it, whatever the source. For example, if you want to deal with network data, you deal with API or anything, or backend as a service. We will talk about backend or database options in details lately, last of this section. But now you deal with data and presentation. All this is layers. Maybe you use layers first, maybe use feature first. Another concept with a clean architecture is architecture categorizing based on boundaries. If the hard feature boundaries and the hard layer boundaries, you deal with microservices. It is the most famous feature or architecture with apps development is microservices. When you deal with hard feature boundaries and hard layer boundaries. If it under engineering, single code bucket, layer package buckets, layer module buckets, or feature modules, feature packages, layer modules including feature packages, feature packages including layers packages, features modules including layer packages. It's depend to feature boundaries and layer boundaries. What is the architecture of microservices? The same with layers. With a clean architecture, the framework, view model. There are many design patterns. If you want to use MVC, model view controller, or MVVM, model view view model, or MVP, model view presenter, or whatever you use the design pattern. View model state with framework and the presentation here, application use case and interface use case data source, the data layer, interface remote data source enable, interface local data source, and deal with framework, remote data gateway service, DAO, local data gateway. This is microservice. Another way is pragmatic clean architecture. Pragmatic clean architecture, you deal with the same, but here you don't find with little difference. This is pragmatic clean architecture. Let's move to provider state management. The same we talked about first, the same inherited widget. You make the state or data above your root of your app. Then listen to the data every widget you need. You make change notifier, extends change notifier, and make notify listener to notify every widget, every listener widget to your data state. Override your app by change notifier provider or multi-provider if you need many providers. Don't use and use. This is the trick with provider enhancement of set state with Flutter. Don't use consumer above all of widgets. Just use consumer directly to your listenable widget. Here we find total price is changed. Only we make consumer above this widget, not above all of widgets. This is make good performance into your app. If we need to show the example of provider, you just add package of provider, the latest version. Just type Flutter pub add provider. I downloaded it before, so you find this error. If we delete it and return the prompt or command, we find the provider change it. After that, pub.get, just that. Now we move to the main function, override by multi-provider and change notifier provider. This idea with Riverboot is enhanced. With Riverboot you use state notifier, not change notifier. And also you can use change notifier, but not preferred. You can use state notifier and many of providers with Riverboot. Many choices: future provider, stream provider, provider, state notifier, provider, and provider proxy provider. Many of them you can use it with Riverboot. We will talk about Riverboot detailed last. Just add that. Now with controller, program your application as you want. We define title, description, the list of to-dos, the selected to-do, setter and getter, nothing. Define the model in your app, integer ID, string title, string description, that's it. And this is design, nothing related to state management. From list we begin. Here, after define the data, make consumer of to-do provider, import it. Then you can use it. That's it. With create, if you want to create to do. Here, what is the difference between read and watch? If you want to update the data or call the function or method, you call read. But if you want to listen the data, you want to use watch or consumer widget with the provider. Read and call the functions. Read title and description. Then read add to list to do create function. Here we do CRUD functions, create, update, delete, view or read, with ID, title, description. Here we don't deal with database or only state management. That's it with the create. If you need to show, here we find read, to do provider, selected to do, title, description, whatever. With the update, the same idea. We pass only the ID. With the update, to do, selected to do, then update. Call update function, update list. We define it already with controller. Update list, and pass the to do model. That's it, the update function. If you run the program or app, we find the results. If we need to add a new to do, for example, here, add to do, we add the to do item. This is show, this is edit or update. If we need to delete, that's it. Now we move to another state management tool. It's a block or qubit. The same for block and qubit. Block is business logic component. From sync in to stream out, there is stream controller. This is the structure. We composite state and event. We have block. Block is mixture from state and event. Block deal with data by request and response. If you need local data, for example SQLite or SQL entity, we will talk about database options in description or in details. Now block, after request and response, deal with state and event to present the user interface. The same as qubit. Qubit deal with the state and function. That's it. If you need to understand microservices, block is very useful for that. Block or qubit very useful for clearing or illustrate very well for microservices concept. Here is data layer, here is domain layer, and here is application layer, business logic and presentation. Let us see the example of block. With the block state management, only use Flutter block package, upload this with dependencies or pub/spec.yaml, and add the quotable if you want with latest version, and that's it. With main, you need to override with multi-block provider, the same as before with and block provider. That's it. So we move to the architecture of block. The architecture, as we talked about first, with event and state. If you don't need to all of this, there is extension with Android Studio or Visual Studio Code. Name it block with plugins. Just download it and the life is easy. It's block, maybe block, yes, I am installed before. Just install this plugin. Now if you want to add new block class, just add a new block class. Here you have many choices as freezed, equitable, basic, whatever. For example, we need equitable. Just name the block test, for example. Okay, all things is done to you with nothing. The state and event and the block. I don't need it. Delete anyway. Delete. If you need to add block or qubit, the same for both. If you need to add qubit, for example, with freezed, just qubit with freezed, the same for all of this. With qubit, there's functions. With the state, there's function. With freezed is more efficient and more easier. If we need to delete all of this, also this. If we add block with freezed, for example, test, the same. Test with freezed. Here we find test event, test state, test block, freezed. Then test event with freezed annotation and test state with freezed annotation. That's it. We delete and return to our example with to do CRUD operations with block or qubit. The block part of two, event and state. To do instances block with event and state. You mix them, we have the result block. We define events here and call events. Emit, like notify listeners, it's similar to notify listeners. The same here, remove, edit, select, we program as we want. We move to event. Event is the program we want. Here we pass the attribute we need. To do model, edit to do, select to do, and set title, set description. The state, override probes of the state with values we need. List to do's, selected to do, title and description. And override the get, setter and getter. That's it. Of probes with attributes we need. In the model, nothing. Maybe we use to import equatable with model, with block. Implement the model with equatable. This is design, nothing related to state management. With list, the same for provider. Here nothing. Just here add block builder. It's similar to consumer. Block builder with name of block and state. Name of state. Then into builder we program our data, state to-dos, title description. If we want to look here, read, we write read if we don't need rebuild, such as running function from block. We define block, name of a block, then fire the function. The same for show, the same for delete. If you want to create to do, we use block consumer, then block, the name of a block, listener, then builder. Inside the builder, here we call read function, context read, to call the function. Here the same, to change values, and here to run the function. All of them we use read. That's it. With show, the same idea. Add block builder with name of block and name of state. With block, state management is a step higher than provider. There is many specific things with block you need to specify, but it's a very effective way to state management in your app. The same idea, read and fire the function. With the update, the same idea for create. This is update block builder. Then we use read to update values. Then add the model. The same here. Also here with edit to do and fire the update function. Look here, add, all of them add. But after add, what is the event name? The name is edit to do. Here, where we define this event with block event, add to do, remove to do, edit to do, select to do, set title, set description. All of them we define an event of block and pass to do model to event with event pass the to do model. That's it for update. After we define events, as we talked, return to block and emit the function. We define add to do with event, then we do the function. The same here. If you run the application, Now we run the application just like that. It's already running. Maybe. Yes, it's running already. If you run this block example, it's run well, perfect. If we test the application, view is running well, update, it's okay. If we add another, it's run perfect. If we delete, everything is okay. That's it, block example of state management. We move to Riverboot. Now we will talk about Riverboot state management. As we talked before with provider, provider is one part of Riverboot. Riverboot is more than provider and fix many of problems with provider. With Riverboot, there are many features above or over provider. There are many providers type, such as provider returns any type. Example of service class, computed property, filtered list. Another example is state provider, return any type, filter condition or simple state object. Provider use change notifier provider, but with Riverboot we use state notifier provider. It is more performance, more or best performance from change notifier, which is state notifier. State notifier is a mutable, complex state object that is immutable except through an interface. But change notifier provider return back ON or O1 in best case scenario. I am talking about Dart programming language in details on my YouTube channel. I published a video about 3 hours and I talked about data structures and algorithms in details in my YouTube channel with video about 4 hours or over that or near that about data structures and algorithms, the complexity of algorithm, the complexity of state management. Now we talk about the complexity of state management. The complexity of state notifier is immutable, but with change notifier we have ON or O1. We have future provider, if you deal with the result from an API call. We have also stream provider, return stream of any type. Stream provider if you deal with stream of results from an API. State notifier provider returns subclass of state notifier. For example, complex state object that is immutable except through an interface. Change notifier returns subclass of change notifier, a complex state object that requires immutability. This is the difference between state notifier and change notifier. immutable and mutable. This is the difference. Maybe you don't need to know all of them, all of these providers with Riverboot, with latest version of Riverboot notation, with @a notation, or Riverboot 2.0 or 2 versions. We have Riverboot notation. The generator code is automatically generate the best provider for your code. Maybe you don't need to know all of these providers with Riverboot notation, but we highlight the features of Riverboot. The Riverboot have family. If you need to pass attributes, for example with future, for example ID, this is restricted by one value. With notation there are no limit. Maybe you can use any of them, not just object or module, but any number, by adding required and the name of your parameter. We have also auto dispose. The auto dispose in Riverboot notation is default value. Default with Riverboot notation is auto dispose equal true. But with no notation, Riverboot, you have this feature auto dispose. This is very useful. For example, when you're using Firebase to close the connection and avoid unnecessary cost, to reset the state when the user leaves the screen and re-enters it, or you don't need the screen else in your app, you can use auto dispose. This is very useful for Riverboot performance. We have, although other than provider ref.read or ref.write, with the provider we deal with context. With Riverboot we use widget_ref. Widget_ref you add it with consumer widget. Consumer widget you add into build, other than build context, add also widget_ref. You deal with the widget_ref, ref read. If you don't listen the changed, you can use ref_watch. And also another features with Riverboot, you can use ref_select and ref_listen. This is very useful one, as it's similar in every way to ref_watch, but that it does not trigger a rebuild of the widget, but instead it watches the provider, and when a change occurs you can call a function. This is useful perhaps if for navigation, etc. Ref_listen, don't rebuild the widget, but listen the state. Another way to listen the state rather than watch. And we have select. Another way, I was having conversion with a friend who brought to my attention from logs that Riverboot with change notifier, Remerozelet says that with change notifier rebuilds a few more times than provider and block, and more rebuilds when used an immutable state like with state notifier. This is understandable, as few numbers of rebuilds is not a strong hold that Riverboot is proud of. But the solution, it provides a guard at different difficulties. But if you are concerned about the number of rebuilds, you can mitigate this with the select method. This works in that in a state or class with more than one property, you can decide to listen to changes only from one or a few properties. The provider listens to the whole object by default. This is another improvement of features with Riverboot, and this is the application of it. You use select specific area of your code of your Riverboot to listen or to watch. We move to example. example, our example of riverbed. Just download the Flutter riverbed package. We have two examples with riverbed, with no notation and with notation. For example, with no notation, add this package Flutter riverbed with main. We need to wrap the app with provider scope, and that's it. All we need is done with riverbed. With controller, we make our program as we want. Setters and getters, notify listeners. Here we use change notifier, the basic, as with provider, and change notifier provider of to-dos notifier, return to-dos notifier with widget ref. The module, there are nothing related to state management. Now we move, this is style is no need. We move to view. Here we wrap by consumer widget, not stateless and not stateful. We have used consumer widget related to riverbed concept, and add here widget ref with build and use ref. Here we use ref watch to-dos provider. That's it. Here we use to-dos. If we don't need listen, we use read to run or fire function from riverbed. The same here, and navigate. If we need to show create, the same consumer widget, widget ref, and here we use read. We make changes here to the values. Set title. We use notifier to run function if we want to read property with no notifier, directly value with no notifier. But if we want to run function, we use notifier. The same here, and run add to do. That's it. The show, the same idea. Nothing, and update the same. With the update, consumer widget, nothing new. Widget ref, we deal with widget ref. And make the update function. If we run the application, if we test the application, everything is running well. If we add another, if we show, everything running well. If we need to update, Okay, if we delete the same. Now if we want to run riverboat notation, we go to riverboat notation. This is the riverboat notation. Riverboat with riverboat notation. Here we add the packages. The same for riverboat without notation, but add the riverboat notation with dependencies. Also here we add build runner and riverboat generator. With main, the same idea, provider scope, but here it is something additional. You need to run this command into your terminal if you want to make any change with Flutter. If it is running, it's okay and you can make changes to riverboat. That's it, nothing here. If we go to the provider or the riverboat, look here, we need to add this line also with the name of riverboat. Add .g .dart, this name. If we delete the generated file, okay, delete anyway. Now look at this counter override. If you need to notify listeners, you use build function and return the value. Increment is the function. If we want to use decrement, the same. For example, -1. Or this, for example, square increment. Now if you save the code, the generator do everything for you. We save the code, the generated file will be generated automatic. But here drop or false. Why? Because the name of function square increment, because of this not working. You need to nothing error or 0 error in your code to run perfect. We make save the riverboat file generated automatic. For the main screen, for example, plus we add another elevated button. Let's minus, and here decrement, for example. That's it. Here is the idea with build. If you want to notify listeners, you can use anything. Here the counter is your counter provider. Here name counter with the name of provider. If we name it counter example, for example, it will be crash automatic crash. If we save, everything gone away. Return back. Counter. Look at this. Counter example provider related to your name. All of these things is automatic generated. Counter example provider, and here counter example provider. With generator, the life is easy. Everything is easier than before. Here you code regular Dart programming. Now if we need to run the application, the same for before. If we run the application, look at this Riverbed generated file. All things of generated, automatically generated. You don't need to modify anything of this. With the second screen, the same idea. Here we use elevated button to navigation, just for check the value if it is correct or not. Maybe the one thing is not complete until now with Riverbed notation, which is the stream provider. I call it Remy Roselet about this, and he is working about this topic until now. Maybe near finish the stream provider with Riverbed notation. In my opinion, Riverbed notation is very similar with Razor or Blazor, with C#, .NET framework, or if you deal with the PHP Laravel framework, you deal with the Blade engine. The same idea with Riverbed annotation. Riverbed annotation is very smart idea, and generate automatically codes with the best provider you need to your app. This is very good idea. Just stream provider maybe need some work from Remy Roselet to finish this topic. Now if we want to test our app, the decrease and the increase, everything running well. If we want to make this 2, for example, and rerun the application, if we add multiply square, if we minus, it's running well. If we move to another screen, return back, it's still. If we need to invalidate, this is very important thing with Flutter Riverbed. Look at this. If we use invalidate, for example, if we click this button after going to another screen, for example, we need to invalidate the Riverbed or dispose. Just we call ref invalidate the name of provider, it's counter example provider, and remove the value and return back to the default value. That's it. Let's make changes. return back. Look at this. If we move to another screen, return back, return to the default value. This is invalidate. Another way is refresh. Refresh, it's very useful. Refresh, not refresh. The use of refresh, not this. Refresh, need refreshable provider. The type of refreshable provider, the same idea. That's it for Flutter annotation with Riverboot. Riverboot annotation with Riverboot 2 package. Remy Roosevelt announced that with Flutter Viking, the latest conference of Flutter in Oslo. Riverboot 2. That's it for Riverboot and state management. We talked about provider with state management. We talked about block and qubit. We talked about Riverboot and Riverboot annotation. Now we talked something about Flutter Introduction. We talked about environment with Flutter, Flutter configuration, and we talked about run your first app. We run first Flutter app in 6 platforms. We talked about declarative and imperative. We talked about responsive design with media query of context. The media query of context, if we talk about inherited widget, the media query of context is inherited widget. Everything you see in your app with of context, this is inherited widget. Theme of context, media query of context, all of them is inherited widget. And we talked about null safety. We talked about state management with provider and block and Riverboot. Now we move to keys in Flutter. Now the time for key, not T, key. The keys. What is keys with Flutter? Although with state management, still keys is more the important topic with the Flutter. You need to understand keys with the Flutter. When you use keys when adding, removing, reordering collection of widgets of the same type of some state. What are types of keys? There are two main types or categories, classification of keys: global key and local key. With local key we find value key, for example Mouaz Al-Shahmeh. Another type is object key, for example 1, 2, 3, 4. Another type unique key is generated automatically for key. Another type page storage key for scroll location. From examples of keys, if you deal with forms such as login form, for example username and password, you need to validate the form. You need to use form key. Another way, if you deal with drawer in your application, drawer in the drawer or drawer, you deal with scaffold key to open the drawer or close it. This is keys. This is the example. If make change with widget tree, the widget, the element tree connected to the widget tree, disconnect the relation and disconnect the row element, update the state and update the relation. How Flutter can update the relation? Flutter check the keys, key 1, key 2, not to exit the relation close the relation and rebuild with the new relation. Key2 with key2, key1 with key1. That's it, keys. Now we run the keys example. Let us see. All my codes exists on my GitHub account. Keys. If we run this example, we find the example here. We run pub get. Here no need to import any package to your pub-spec YAML. Nothing, all of keys into Flutter SDK. Here is navigation, nothing new. Navigation to keys. Button, this is style, nothing. Models, we define model for object key. With a global key, look at this form key. We define global key with form state with global key and define the form with global key. If we call everything is widget with the Flutter, another sentence is every widget has key. Every widget. Test any widget, it's have key. Thank you. It's have key. Every widget. So here with the form, we add form key, and with submission of form, we check the validate of this form by key. This is global key. The object key, another example of keys. Object key, we make object key by object. We define a new object here with two attributes, name and canFly. That's it. Assign name and canFly equal true. This is object key. Another type is unique key. Generate automatically key. Unique key with no assign anything. Another type is value key. Value key. Here if we want to run the example, this our example, value key, object key, unique key, and global key we use form key. That's it. This is keys in Flutter. Now we move to routing with Flutter or navigation. Now we will talk about routing with the Flutter. Routing or navigation. The routing or navigation with the Flutter is similar to stacks with data structures. I talked about data structures in details in my YouTube channel, data structures and algorithms with Dart about 4 hours. Routing is similar to stacks. You can push and pop, first in, first out. From stack, first in, last out. So you deal with stack, with navigation, with Flutter. There are many packages you can use it with Flutter, with routing. Many of them has good points with pub.dev. Many of them not very good points or community with pub.dev. There are Beamer, Flow Builder, Floro, VRouter, AutoRoute. Many of them has good points and many of them not. Beamer is good package. Lithuanian one has make it. The most important package is GoRouter. Why GoRouter? We will talk about GoRouter with example. GoRouter uses navigation 2.0 with declarative routing or declarative navigation with no context. That is GoRouter. Navigation or Navigator 2 use many methods or functions such as push, pop, push placement, push named, pop until, etc. There are change with Navigator 2 and Navigator 1. There are many problems with Navigator 1 as we talked with Flutter Introduction. With Navigator 2, many enhancement was conducted. For example, with Navigator 2, if you press back button on your device, for example Android, if you press back button, your app is exit or you have black screen. That was big problem. You cannot deal with it with Navigator 1. Navigator 1 and Navigator 2, every one of this has its usage, but with Navigator 2 has many features, has many useful things you can use it. Look at this shape, button, back button preset, back button dispatcher, pop route, modify based on system notification, app state, request changes to navigator, rebuild, router widget and router delegate, get newly configured navigation for rebuild, here operating system, initial route or new intent, route information provider until set initial route and router delegate. All of this done if you press back button. The same here, app state, first user tab button, second tab handler modify app state, my app state, notifies listeners of state changes, router run, rebuild and choose new route, navigator run topmost route, route 1, route 2, this is a stack. Let us see GoRouter example. I published package to deal with GoRouter package. I name it Midtest EO. To to generate meta tags into your header with HTML for web, specified for web applications, Flutter web application. All of my codes as I talk into my GitHub account. This is my website. All my activities, projects, products, all of them onto my website. All the codes, all the videos, meetings, courses, articles, repos, all of them into my website. Now if you want to access all of codes of this course, Flutter course, go to my GitHub account. All of repositories published into my GitHub account. Return back. Also, I published Meta SEO package and publish it into Google Dev Library. It's Meta SEO. That's it. Meta SEO. I publish it also into pub.dev. This is the code, how to use it. How to use it with GoRouter also. Add Meta SEO functions into your web application with GoRouter application, that is repos. I publish it into my GitHub with example. Also I publish it into pub.dev. Just search about Meta SEO. Yes, this is Meta SEO. You can download it and deal with it simply. Just run 3 functions into your browser, into your HTML code index, and add Meta functionality to your web app. If you use GoRouter, just add Meta SEO before build the screens into GoRouter. That's it. Easy as possible. And I make it extensible. If you want to add another features or another keys, values, it's extensible, so you can use any meta data or any meta tags into your head web application. So by this function your website is SEO friendly as possible. This is Meta SEOs. All of them you can use and add Meta to your application, to your web application. Return back to GoRouter example. If you need to deal with GoRouter, just add dependency GoRouter with latest version with dependencies. Run pub.get. Just that. With main, nothing. With main, you need to go router. Here, go router set URL path strategy is destructed or not continued, discontinued with go router versions, latest go router versions. It is now into Flutter SDK itself. You can use go route set URL strategy without need to any of this. Just add import Flutter web plugins. It is this set URL path. If we need to update go router package, or Bob upgrade, now we find the latest version is 451. Available go router available 524. If we do pub.get, everything running well. Okay, return back here, get dependencies, URL strategy, URL path strategy, set URL strategy, not path strategy. Now here we use the URL path strategy, URL strategy path. URL path strategy, or something like that. Path URL strategy. You need to write it correct to run. That's it. Now if we run the application, the hash after your URL, base URL, is gone away. Now we use just this for modify router. No need to import go router here, and add router with router attributes, route information provider, information parser, and delegate, all of them. Add to material app router. That's it, and define go to router and define all routes you need. Here we define routes. Ignore now. Router, go router, initial location, the first location. Here is the first location, the path. You have also name attribute. You can name it anything you want. And go push with name it, or go name it, or push name it with name you define here. As we talked before, here you can add meta functionality with builder. It's auto dispose in my pub or package meta SEO. If you use push or go, it's auto dispose automatic. Here we push, the same, nothing new, push screen, but into view there is some differences. Here we go screen, the same with builder and state, go router state. Here with extra data screen, with dash, for example, state extra as Flutter dash. Here the same extra information with go, here with push. If we go to dash model, the same, we use example object dash, we define it by name and canfly. This is style, nothing. Here it is the pages or view, extra data screen. We find here the data, require this data to run this widget. Now we use the object, and here we find everything we need. Nothing here, and here nothing also, and here nothing. Push screen. The point here in Go router, we use declarative navigation. We use only go and push. Another option is accessed also, but we don't need over this push and go. If we need name it, go name it, push name it, can pop, any other functions, but the main concept is go and push. Into stack, we use go to go without return back. So we mean with go, we delete the first screen and go to the second screen. After or before we navigate to the second screen, we delete the first screen. With push, we stay the first screen and push to second screen. If we return back, we find first screen in the stack. But with go, we don't find the first screen. It's deleted before navigation. That is the concept. It's similar to replace, context replace with navigation to, navigator to, but here with Go router it's declarative. Here push, here go, here push with data, name it extra, we pass object flutter dash with name and canfly. Here we use go with data extra. If you run the application, here there is no web only set plugin handler because the platform is Android. We don't need Android, we use web platform because here the plugin is specific to web, because this is not running onto Android. If you use Android, just drop down this function of set path URL. Look at this. If we use set path URL, you don't find this hash. If we drop and comment this out, rerun, the default is hash path strategy or hash strategy to URL. It's running, so you find this hash. If you don't need to watch this hash, just add this function. If you need to run the navigator or go router into Android or iPhone, just add some condition. Is key, or if k is web, you need to foundation. Just add this try catch to your app. Return back to run our application into Chrome. Now we find Chrome browser for web application. Here we find push screen, we find back button. Push screen. Look at the names, pretty URLs. If we click go, there are no return value here. Return back to the first screen. If we pass extra parameters, here we find with push we find back button, and here we pass parameters. With go, no return back. This is go router package and navigation 2.0. We talked about many things. We talked about some introduction with Flutter. Also, we talked about development environment configuration. We talked about run your first Flutter app. Also, we talked about declarative and imperative. We talked about responsive design, and we talked about null safety and state management with provider and block and qubit and riverboard. Also, we talked about keys and routes or navigation with Flutter. Now we move to important topic. Beside to state management, the complement idea or the complementary topic is database options. We have many of database options. Now we will talk about database options. With database options, there are many options with database. You can deal with it with Flutter. If you want to deal with database offline or without internet connection, you can deal with SQLite or SQL Entity or Hive. Everything run well. Or if you just like JSON file into assets, you download asset file into your asset directory, deal with JSON file, read and write. It's possible with the JSON serialize and deserialize. It's locally into your app. Another way is, or if you can use external storage package for Android or iOS, iPhone, use package of external storage to save file locally. Maybe the name is external storage. Read and write the file locally of JSON or external path, and save the file into your path and read the file. That's it. If you want to this for Android. Maybe there is with Swift or iPhone. Maybe the path function, path div. This is the path. You can use with any platform. The SQLite and shared preferences into your app, but the difference, shared preferences, you use simple state or simple data into your app. For example, the language of application, Arabic or English, or whatever the language. Or another example, you use shared preferences for login state. Is the user logged or not logged? You can save this data with shared preferences. Or another example, the mode of application, light or dark, or night or day, mode design. You can store this data into shared preferences. Shared preferences and SQLite or SQL entity, all of them use path method to store the data into your path directory, into your app. For example, for Windows, C, document, whatever, or into Windows, or Mac, or iOS, iPhone, or Android, the same idea. There is noun path for any platform. This packages use the path to store the data. Another way to store the data or deal with database, if you need to connect with internet or online database, you can use backend as a service. There are many of backend as a service. For example, Firebase, it is no SQL database or no relational database. It depends on MongoDB if you listen about it. MongoDB or JSON document database. It is Firebase. It's backend as a service. It's free until 15 gigabytes maybe, and after that it's paid over or depend on your usage, but not expensive very much. It's good. Another backend as a service is Supabase. Supabase is SQL database or relational database. You use schema, you use relations with tables. This is a relational database, Supabase. It's based on PostgreSQL. It's an advanced and modern SQL database named PostgreSQL. Another option is Supabase as backend as a service. If you want to deal with backend as API, application programming interface, so if we talk about API, we talk about request and response. You request the server over HTTP request and receive the response from the server. You deal with application as client and send the request over the HTTP method, such example get or post or options or put any method or delete anything, and receive the response. For example, receive the response with body serialized JSON, for example, and the response status code, for example, 100 for information status, 200 with OK status, 201 created, and etc. 300 is moved permanently, temporarily, and etc. 400 for not found or client errors. 400 is client errors. 400, the famous one is 404 for response code or status code from server. 404 is not found, and any other. 400 unauthorized, which many of responses. 400 it's client errors, and there is 500 it's server errors. For example, server errors 400. This is the status codes for response from your server or HTTP. Now Flutter team deal with server sockets. You can use directly without API. You deal with directly with your database with HTTP sockets. Open the channel, the connection channel with your database with username and password and the host and port. These methods. I study master in web sciences and this topics in my field, so you can use now direct connection with your database with Dart programming language. There is very good package named Dart Frog. Dart Frog, you deal with database directly. bob.dev. If you search about Dart Frog, this is good package. You deal directly with database. Open the connection and make queries or anything to your database. Get started. You have good documentation for this package. You deal with Docker, you deal with AWS from Amazon. Any backend technology, you can deal with it directly. This examples and many of tutorials. HTTP connection. Send request, response, many of them. You can deal directly with database. Another way, if you need to deal with database as API, so the field is open to any backend technology. For example, if you want to use PHP Laravel, there is no problem. You can use PHP Laravel as backend as API, and Flutter deal with the API over HTTP. There is two most popular packages, which is HTTP or DU. It's good packages. HTTP package and DU to deal with database, to deal with API connection. HTTP, the same idea. Also, if you want to, for example, use C#, .NET Framework, .NET MVC, .NET Core, .NET MVC Core, make the API backend API and deal with the Flutter with HTTP. If you want to use Python, Flask, Django, Fast API, whatever, it's easy to connect with API. If you want to use any backend technology, if you want to use Node.js with Express, also available to use or to connect with API with Flutter. The idea is simple. With API, you can use any backend technology for database. What is an API? So we will take one example over these 5 examples. What is an API? We have client and server, as we talked about. First, request. API call is initiated by the client application via HTTP request. Second, receive. Our worker B acts as an API going to Flower sender to collect nectar data. Third and finally, response. The API transfers the request data back to the requesting application, usually in JSON format, and return back the result or the response. There are many types of API: REST, GraphQL, SOAP, Simple Object Access Process, RPC, Remote Process Control, or RMI, Remote Method Invoke. The same for RPC. There is another thing is gRPC. The same idea. REST, you use usually JSON or XML format. Many advantages for everything from this. The most famous one is REST. The most modern is GraphQL. SOAP until now is working. It's old, but until now is working. No problem with SOAP with XML. For example, GraphQL mobile APIs, with REST resources-based apps, with SOAP payment gateways for security. We use XML. Another RPC, we use command-focused system. This is examples. There are 2 programs to deal with APIs. It's important. If you need to design the API or test the API, use Postman program. If you need to document the API, maybe you use Swagger or or OpenAPI. There is not programming language. It's like YAML. You need to be careful about spaces, about indentation, all of these things. With OpenAPI, for documentation, you deal with the Swagger. This is Postman. If you want to understand all of web APIs, here is the location, HTTP methods, enter URL, parameters, authentication. You have many of authentication, API key, barrier token. It's famous, Auth1 and Auth2. With Twitter, Auth1 and Auth2 is still until now still possible and available. If you want to connect with the Twitter services with Auth1, it's possible. If you want to connect with Twitter with Auth2, it's possible also. Many of type of auth with header, send attributes. It's possible, except here if you want JSON, text, HTML, XML. If you need to understand the API, this program is very useful. And if you want to test your API, design API, all of things good here. It's Postman. Another thing is a Swagger. Swagger for documentation for your API. If you want to document your API as well, Swagger. You use Open API for design your documentation. This is Swagger. There's many services with Swagger. You can use it to design your API. It's very useful to design your API. Swagger. Now we will take examples of database. Start with SQLite, for example. With SQLite or SQL entity, the same, but with the SQL entity you use ORM. No code of SQL queries, you use ORM. It's easier. Upload these packages, SQL entity gene, to generate codes, and HTTP. This HTTP is necessary to run SQL entity. Of course, you deal with offline, but this package necessary to run the SQL entity correct. This is a requirement for running. We use provider, not necessary provider. State management, we not consider the state management. Now we focus on database. And add this div dependencies, build runner with build verify. That's it. We go to main. Here we don't need anything to configure. With provider, nothing. Here is related to provider. But here we find ORM. The SQL entity located into the service here, all of the database. Here import the SQL entity, ORM config, and run from to do. Run entity queries, for example here, to do select to list. Here to do save with attributes. Here to do select where ID, then delete. Here update, assert, we use the keyword of assert. Look at this, we need ID because it's relational database. When add, no need to ID. And getter setter, nothing. For config, we use convert for SQL generated, correct, and use HTTP. Here we add this or config G and run this command into terminal to build G. After updating this file automatically generated if we delete it. Okay, delete anyway. If we run this command line, automatically generate the second file with all queries or things we needed. Everything okay? The second file, all of these things automatically generated. We don't need to write any SQL query. All of these written automatic. Insert or replace into anything. All of these automatic generated, and we don't need to update anything from this file. Now we define table, SQL entity table, with name and primary key and fields, with type of every field. Because it's SQLite, there is some limitation about this package. So about data types of the package, but it's good for the reason you use it. For example, if you need to salesman need to do some operations without need to connection of internet, maybe the salesman work with application for a week or for a month, and the travel with application, nothing or no problem with that. If he connect with the internet, sync the data to the server, for example once by a month or once by a week, it is possible. He work offline and finally return back to the online, and this process. So you can use many types of databases into your one application. Maybe use offline and online at the same time. There is no problem with that. So return back, define the ID for SQL entity and the DB model, SQL entity model. That's it. Return back to the view, the style nothing here, to the view. Here we used media query of context with size high for responsive design. We talk about this in details with responsive design before. Now here we listen only for the data. Just run this function get to-dos list from provider. Then here from list to-dos and view the data. If you want to create locally with SQL entity, the idea is simple, the same idea. Run the function of provider, latest. Here we don't need to ID as we talked about. Pass model without need to ID. Add to list, because ID is automatically generated or auto increment as we define it. With show, the same idea, nothing. With update, here we need to ID with update function. We need to pass the ID function, the ID parameter to update the record into secure entity or secure light. This is secure light or secure entity. We move to shared preferences. Another example. Of local database, shared preferences. We make CRUD operations about this package. Create, read, update, delete. Return back to the shared preferences. CRUD operations with shared preferences. We add this dependency, shared preferences, nothing else. Provider for state management. Shared preferences. With Bob Spec YAML. That's it. No need to anything here. This for provider, nothing necessary. With shared preferences, here we find shared preferences. With model, we use user. Here we use shared preferences. It's from type async await, so it's future. Use async and await. Get instance to get all or obtain shared preferences. To get string by key, it's like key value. You have many options. Get boolean, get tuple, get integer, get keys, get string list. You can use get or set. The same idea, get password and return. For register, this for login and this for register. You need set with attributes. If you want to log out, there is two options. Log out with break the shared preferences. You need to remove from key. You deal with key of value. After get instance, then remove or set or get. If we go to login screen, there is nothing here. Just fire the function. Here just fire the function of login with username and password. They register the same idea. Fire the register function. After that, snack success snack with text. Here, if you want to log out or log out with deleting the user, there is two options. I mean this trick. I put two buttons to use logout without deleting the user and logout with deleting the user. Here, just logout, go to login screen, and here fire the logout function, delete the existing user. And here regular provider operations, create, nothing here, show, update. Let us run the application to see the results. is running now. Now we have two options: register or login. Register account with, for example, 111, the password 222. Register. Now registered. If we log out, login with account we created now. If we make password error, this is error login. If we correct it, the success login. Here nothing related to state management. Shared preferences, we use it here with login process. If we break the user logit or delete the user logit, if we click here, the user remove it. So if we put the same user name and password, it is not correct because deleted from shared preferences. If we register again, another one, for example, or this, register account, log out, login, or sorry, this is true, the login is true. This is shared preferences with database options with Flutter. Now we move to Firebase example. If we open the repository of Firebase, we run pub get. All of errors gone away. You need to upload or add this dependencies in pub-spec.yaml. You need to add Firebase Core and Cloud Firestore with latest versions. And that's it. With main, you need to this command, this line, widgets Flutter binding, ensure initialize it, and run this command. Await Firebase initialize app with options, default Firebase options, current platform. This options, you got it from where? From Firebase. We will see it a few minutes later. That's it for database Firebase for configuration. Another side from Firebase website, from Firebase console, we see it now. From provider, nothing here, just Firebase service, to-dos collection, the name of collection, and get. Here from model, from JSON, query snapshot, then get the data. Here if we need to add data, just import Firebase example model. To add data, add to do data. Here is service remove data, update data, program your provider as you want with model there's nothing here. Firebase service, here is the concept of Firebase. You need to define Firebase class collection reference with Firebase Firestore instance collection with the name of collection into your Firebase. Then add data with document set. Here to update document with ID update. Here not necessary ID with documents, but to know what document you need to update. This is it. Because there is no schema, but here the ID is the ID of document, not table, not row of table. Here remove document ID delete. The same here, to-do list, to-dos snapshot. This is the option. You here define the option or the Firebase option. You have all this file from where? From Firebase. You see now from Firebase website, from Firebase console, Firebase Cloud Console. We will see it. But here the Firebase options, all of these things automatically generated from Firebase options. You don't need to do anything of this. That is a configuration of Firebase and operations you need to do. Here is the list. Just fire the function of get to-dos list, then consume the list. The same idea here, nothing. Create, just fire the function from provider. Here no need to ID because it's generated automatically with document for new documents. For showing here nothing, and update the same, nothing. You need the ID because to compare documents, just to compare the documents for updating or assert. We go back to Firebase. Here, for example, the example Firebase console. This, for example, 3 applications. If you need to add application, there is the option with the Flutter. Just run next, and you will find this application you can deal with. Flutter app. Download the application. Download the application options or configuration of Firebase from here, from new application. From here, new application. Next, and latest option. You will download the file for configuration. Because we make this process before, no need to do that. Here is the tables and documents. Document here with ID to dos. The same here. If we run our application, if we run our application on Android with Firebase, now here connect the Firebase. We delete the documents not related to the structure we determine in our application. Look at this here, nothing, no found records. If we add a new record, for example here, BBB, add to do. If we return back to our Firebase, we find new record, new document with AAA and BBB. That's great. With ID of document, here nothing named ID, and here you can update the type of data with the value. Cancel. If we add another document, return back to our application, add another document, for example YYY, CCC, add to do, return back to our Firebase, we find another document, YYY, CCC. If we need to update, the same idea. This is view, this is update. If we need to update, for example 1, 2, 3, update the record, the document, return back to our Firebase, we find update the value. If we need to delete, no problem, return back to the Firebase, we find the record deleted. If we delete the second, the same, deleted. There is no documents. It's simple. It's backend as a service with Firebase. This is Firebase backend as a service. Now we move to Supabase example. Talked about SQLite, SQL entity, shared preferences with offline connection of database, and move it to online backend as a service like Firebase. Now we will talk about Supabase example. This is Supabase with CRUD operations, create, read, update, delete. The same for Firebase. We need to configure the package, configure settings for package, just that the idea, and connect with the service and run the functions of the package. Now we will talk about Supabase example, which is relational database, deal with PostgreSQL, based on PostgreSQL. Supabase. What we need to configure, the settings, just add Supabase package with latest version, PubKit. Now into main, you need to add this line, widgets, Flutter bindings, ensure initialized to running the application well with Supabase, and that's it. With provider here, nothing to do, just Supabase handler. With Supabase handler now we will talk about from where you get the settings. Let us talk about you define Supabase client with Supabase settings, Supabase URL and Supabase key. From where you find this? From Supabase. From Supabase you find all of this information. From here, maybe with authentication. No. It's paused. Let us make a new project. Create a new. There is many pricing plans. For example, the name of project, the password, database password, not necessary, maybe use a strong password. Okay, create a new project. Now we make new project, name it example. From where you find the key and a secret, project API key. This is the key. Copy that, paste into the key. Supabase key. This is maybe changed from time to time, but you need to update here. And the Supabase URL, you need to copy URL and paste into the settings. Here, copy the URL, then return back to the Supabase. You define Supabase client, then read data PostgreSQL response as PostgreSQL response. From client we define it. From table, the name of table, then select order by ID ascending, true or false, or descending. Then execute latest. Don't forget, if we need to add data to tables, the same idea. From the name of table to those table, maybe we need to define the table into our Supabase. We define new table, create a new table, the name of table, to do table, description no need, ID. Then we need to define the attributes the same as in the application. If there is anything not true, maybe problems with your application. That's varchar nullable. Make it nullable or empty. Default value is null. No problem. Title, another thing is description, the same idea. It's simply, if you deal with relational database, the same here. You deal with PostgreSQL, it's relational database. Nothing difficult here. Maybe this is columns we need in our application. Title and description. The name of table. The ID. That's it. If you want to update when ID is equal to ID, and delete the same, delete where the equation ID equal ID, execute. Let us save the schema of table, empty table, nothing in it. If we want to reordering the table, it's possible. Sort, make the column to sort. No, we need to arrange the table. To do table, let's create latest thing, created that, the timestamp. This is title, this is ID, and this is description. This is created at its timestamp. So everything is okay now. Return back to the application. That's it for the configuration of Supabase. Return back to the module or the provider, nothing here. The module is nothing, the same as previous. Here style is nothing. List, from list we fire the get to do's function, get to do's list from Supabase, and consumer to the value. From list we create the same, just fire the function. Here you don't need to the ID because it's auto increment. You don't need to ID, but with update you need to ID to relational database. You need to ID primary key, which is primary key. Here you need to ID to update the table row. Let us run our example, our Supabase example. If you run the application, it's running correctly. Okay. Now if we add new value, for example, add to do, if we return back to the Supabase table, now we find the record inserted into the table with timestamp. Everything is correct until now. If we, what's here, corrupted. Okay, rerun the application. But the data inserted correctly into the database. We find the data into the database. If we add another record, insert it correctly. If we add another also, we find it correctly added. If we return back to our table, we find data into our table inserted correctly with timestamps of it. If we return back to our application, the show is correct, nothing here. The same here. If we need to update, for example, this one, 1, 2, 3, for example, update. If we return back to the database, look at this. The updated is correct. If we need to delete, for example, this one, GTBB, return back to the application. If we delete this one, return back. You need to program the application as well with state management, but here we focus on database. If we refresh, we find TT is deleted. If we need to delete all the data, the same idea for deleting the data. If we delete all the data, refresh, the table is empty. Everything is correctly done with Supabase. Now, finally, we highlight with API connection or API database. Let us move to API example. API HTTP code. This is dummy API. We use maybe one method or two from CRUD functions. Run pubget. What we need here, you need to add HTTP with the latest version. Just it is this with the main, nothing here. All of this related to state management provider, nothing here. If we move to provider, also here nothing. Program your app as you want. This is to complete with real API server or local host if you want. Not necessary, but the idea is clear here. If we use one of these, the idea is clear. We get API, get all to-dos, then the value we get from the API, put it into the list. That's it. With the service, this is the API connection. Import the HTTP package, and here the base URL. It is preferable way to define the attribute above your code, or split your code, split your URL or API key, maybe split it above your code. This is preferable way. This is function from type of future dynamic. We pass context. Maybe no need to context here, but okay. Maybe I delete the context, no need. Return back to the provider. Maybe delete the build context, no need. Also return to the views. Maybe delete the context, no need. Okay. Return to the API function. Here, run the HTTP request from URI. Try parse with to-dos, for example. This is dummy API. If we try this, we return the JSON data is dummy. If we use to-dos, it's dummy data. We find all of these to-dos. Nothing but is to clear or to deal with APIs. And here material no need. Here, if the status code is 200, we talked about response codes, status codes in details before. If the status code is okay, 200, return the response body with decoding as JSON, then return to the JSON data. Then with controller parse the JSON data as to the model from JSON. This is useful trick to define from JSON into your model. Then parse the JSON to the list. That's it. All of these functions, maybe you can do it with real API. The model here, nothing. With lists here, the same idea. Just run the function get all to-dos, then listen to the state. Create nothing here. It's to be completed with real API. Nothing here in show and nothing in update. The same idea. You deal with HTTP. Look at this with API. Here you deal with get. Maybe you can use put, delete, post, or head or batch, but any of them is true with your situation. Let us run the application. Nice one. Our application is running well. All of this data from API coming. To-dos. If you want to see show the item, just click the eye. It's running well. For example, this one, it's okay. If you need to update, and delete these options with real API. You can deal with it. Here, another idea to use when you're programming Flutter, use list view dot builder. Dot builder, it's best practice for performance with Flutter, because builder build the UI into your screen, into the size of your screen. Outside the builder, it is not into your UI or user interface. So it's good and enhance the performance of your app with long lists. This is good performance idea. List view dot builder. This is the API example with the Flutter database options. Now we talked about many options of database. We talked about SQLite or SQL entity. Maybe you can use Hive for local database. Another options with local database, we talked about shared preferences. If you don't want to use offline, you need to use online. Maybe you can use backend as a service, for example, relational database such as Supabase, and no relational database such as Firebase. Another options, you can deal with API, application programming interface, over HTTP request and response. We talked about many things with Flutter this course. We talked about Flutter Introduction, then we talked about configuration, environment configuration, development environment configuration, and run our first app into 6 platforms. Then we talked about declarative and imperative. We talked about responsive design. We talked about null safety, state management with provider, Riverbed, Block, or Qubit. And we talked about the keys. We talked about also routing or navigation. Then we talked about database options. We have 5, the most important database options. You can deal with it, and you can deal with any type of database technology because you have the option of API. Also, now is the option with direct connection of database is open with Dart, for example, Dart Frog. Another options, maybe you can use AWS from Amazon. It's another option available. Amplify, it is available now. You can deal with Amplify of Amazon, AWS with Flutter. It's simply and very useful. Not just the Google Cloud or Firebase servers. If you want to connect with AWS, Amazon, it's possible. The good idea from Flutter, it's no limit with database. You can use any database type because there is many options with database. So the decision returned to you. If you want to use many of database options into your application, you can. You can use offline option, for example, SQL entity or shared preferences, and you can use online option. The both at the same time, it's possible. Now we move to performance tests. It's important thing with Flutter. Now we are gonna to talk about performance tests. There are many of them. DevTools, Flutter DevTools. It's very useful. Another way is Flutter Doctor to configure your environment. Any problems with the installation of a Flutter SDK, any problem of your program, for example Android or Visual Studio Code, anything. And the Flutter debug mode, code trace for code trace with red points of your Flutter. For example, let us see this. If we run this example API, if you want to debug mode, maybe you can use this with debug. If you want to stop the code into one point, for example with list view builder, for example this one, for example list style. Let us stop code here, run with debug, stop that, run with debug. This is the idea. Waiting debug connection, running, connected. Here, stop it if you want to check the values, test anything. This is very useful. Rather than print. Print is not preferable. You need to delete any print command for a profile or to release the application. You need to delete them. Skip if child null, skip step over, also step over. If you need to understand the Flutter framework, it's the same. Resume, step into, let's style, for step into, step into, another way, repaint, circular progress indicator. If you want to see that the values when changed, it's very useful. If we remove this, rerun the application, we have the values. This is the debug mode with breakpoints. Another type is print. If you want to check, for example, print anything from things you maybe need to see is print, but don't forget to remove any print when you decide to publish the application or release the application. Look at this, sync here, look at prints, we find many of them. Each iterate, print the object. Another is DevTools. Open Flutter DevTools. This is very useful. DevTools. the DevTools with performance. It's very useful. With performance, run the DevTools. We find many of features to test our application, to test the performance. Here you will find the performance, but in debug mode. If you need to profile mode to see the real performance of your application. We will talk about app build types in the next session, but here is the performance tests. You find also many things useful. You find also CPU profiler, memory, debugger, network, logging, many of them. It's useful. The network, the logging, the provider, anything. The app size, you can analyze the app size. All of these things with DevTool. Flutter DevTool. This is tests for Flutter performance. Maybe we talked about all over of these things with Flutter tests, performance. Now we talked about performance tests, about DevTools, about debug mode, about Flutter Doctor. Let us see Flutter Doctor before moving to the next session. With Flutter Doctor, just run the Flutter Doctor command. Doctor. You can use -v for full Flutter Doctor. Yes, Flutter -v. This inspects your environment. You can use also Flutter Doctor -v to full inspect, or -v. Yes, -v maybe. Flutter Doctor -v. No. Return back to the Flutter Doctor. It's Flutter Doctor -v. Yes. This is a full inspect to your application or your environment, development environment. This is Flutter Doctor command. Now we move to app building types. This is three categories: debug, profile, and release. When you use one of them, another of them, when you use it, or where. Now we will talk about that. With debug and profile, you have the option of hot reload and hot restart. We talked about before. Hot reload and restart. For example, we have this icon for hot reload, Flutter hot reload, and hot restart appear here. Let us run the application. This topic or this feature run with debug and profile. There is no hot reload and restart with release. So this is the idea here. If you run the application, you find the hot reload and hot restart with debug and profile mode. If you need to run profile mode, you need to connect with real device, not emulator or simulator. You can connect the real device with USB or with USB cable or over Wi-Fi with modern Android SDK, for example 13 or from 11, I think from 11 or 12 Android SDK. You can use connection with real device. Here is the hot reload. If you, for example, let this screen, for example, and make hot reload, you can see the result directly. If you need to hot restart, this is the hot restart. Rerun the application, and this is the hot reload. You can use this with debug or profile mode. You can connect with real devices here with physical device or pairing using Wi-Fi. To use this feature, you need to Android 11 device or with Swift or with iOS iPhone. It is possible. The same for all of them. Just connect the device and run it with Android Studio or Visual Studio Code. Another way without command in Android Studio, you go to Tools, then Flutter, then any of them. With debug mode, you can check the print. With profile, no print. Another thing with debug is debug mode. If you run the debug mode, you find the red banner into your application. If we run the application, we find the red label into application. It's debug mode. If you want to delete it or hide it, just debug show checked banner false. But this is important to know if you run into debug mode or profile mode. If we run this, we find the banner, the red banner has gone away. Wait for running. The red label is gone. If we delete this, it is returned back. This is into the debug mode, not other thing. There is another feature with profile, as we talked, real device and real performance. With release, there is many things another of that. With release, there is something called archive with Xcode. If you want to publish the application into the stores, you need to archive the application, open it with Xcode, then archive the application. If we return back from tools, Flutter, open the application into Xcode. You need to if you want to build iOS from Android Studio, just click Flutter Build iOS, then return back to the Xcode. Automatically sign the application with the Xcode. While building, it should be from Xcode, not from here, with signed ID. Here we need to maybe rerun the application. Now if we want to archive the application for building into is here, open iOS module in Xcode from tools, trust and open. Now we open our application into Xcode. From Xcode here we find the option of archive. We choose the device, then from build, from product, we have the option of archive. Archive, build filled, no problem. You need to unique ID for the application, and you need to log in with team, with Apple team. This is important. Without signing, from product archive, you need to, everything is correct, but the idea here, there is something here to define from some settings here. With Xcode, you need the unique ID, and with Android, you need to generate signing for the application. App signing for the Android. If you want to publish your application into Google Play Store, you need to sign your app. And follow the steps in this page. That's it. Return back. With release also, you need to unique ID for application for Android and iPhone, and archive the application with team, developer team, with iPhone, with Apple. This is the app building types. It's a 3: debug, profile, and release. We talked about many things in this course. We talked about some introduction about Flutter. Next we move it to Flutter environment configuration. Then we talked about run first Flutter app, then declarative and imperative, and the importance of declarative UI, declarative programming. All of these things Flutter is based on. So if you understand the declarative, in my opinion, you understand the Flutter, the whole Flutter with declarative concept. Also we talked about responsive design with the media query of context. We talked about Cupertino and Material 3, Fluent UI with Windows 11. We talked about null safety. We talked about state management with provider, riverbed, and block or qubit. We talked about also riverbed annotation, new features with riverbed annotations. We talked about also about keys with Flutter and routing and navigation. We talked about Go Router package with meta.co, the package I published into pub.dev. You can add meta.co with Go Router package to support or to make your Flutter application, your web Flutter application is SEO friendly. Also we talked about database options such as offline database or online database. Talked about many options of database, SQLite or SQL entity. We talked about shared preferences. We talked about backend as a service such as Supabase and Firebase. We talked about API with database options. Also we see the apps building types 3: debug, profile, release, and we talked about performance tests such as DevTools, Flutter DevTools, and the command Flutter Doctor or Flutter Doctor-V. Also we talked about Flutter debug mode. If you want to trace your code, this is Flutter course. Now we move to conclusion and references. Maybe this references is useful. This is Flutter Apprentice book with version of 3.3. Be careful with the version. Choose the latest version of Flutter Apprentice. It's a very useful book with e-commerce full application into this book, step by step, in details. Very useful book. Another is optional: clean mobile architecture and building games with Flutter. This toolbox is optional. The first documentation or the first learning resource you think about it is sure you think about the documentation, the official documentation. The official documentation is Flutter.dev, the website of Flutter. Everything here you need is documented here. Another resource you can learn from it is the boring Flutter development show. It's playlist of YouTube, maybe 60 or 70 videos. One video is more than 1 hour or maybe 1 hour and a half. It's very useful. The story of this boring show is every Flutter enhancement or release or changelog with the Flutter SDK, the team of Flutter know you how to enhance your code from first edition to the second. This is the story of the boring Flutter development show. It's very useful. And the widget of the week, maybe it's more than 117 video. One video is 1 minute. Every video is 1 minute or 2 minutes maximum. It's very useful, also specific and targeted with every widget. You view the widget, how it works and the code to it. This is also resource. The pub.dev for packages. Here you need to be careful when you use packages. You need to know what is the code behind the package itself into platforms. So you use the package you need, but not all packages. So here be careful when using packages with pub.dev. Be careful with grades of this package, points of Flutter team grading. This is useful. And another resource, if you want to read Fuchsia.dev, it's operating system, total operating system built with Flutter and other technologies, totally built with Flutter. Another is Zircon. Zircon is Dart package, totally Dart package. Zircon into Fuchsia operating system. This is engineer Mouaz Al-Shahmeh, Google Developer Library author with the Flutter and Dart technologies, software engineer. This is Linktree QR code. Thank you. See you later.